Hello and welcome to Weebit.net Programming in Python. Kevin here again with Jason. What's up, Jason?
Nothing much. How you doing?
Hanging, dude. In this course, what we're going to do is take you through one of the more popular scripting languages that use a number of different industries for a number of different purposes. And I know that a lot of you guys, since Weebit.net has started, have been asking us to do a Python course. Well, now your wish has finally come true. Here it is in the flesh.
Wait, we're doing a programming? I thought we were doing a video about snakes.
That was just so I can get you to do it with me, because I knew that you didn't care about the language, so...
Yeah, I was hoping for snakes.
Yeah.
I like snakes.
Yeah, I was hoping that if I told you that it was about snakes, you would think that it was about porn, and then you would show up.
Well, now I got to put away my lotions.
Well, actually, you know what? This course is so exciting, you may want to keep them, within hand's reach.
All right, hold on a sec.
So, like we said before, guys, this course is going to be about Python. So, in the typical Weebit.net introduction style, we're just going to go over some basic things about the language, where it came from, what it is, just to kind of get your feet wet in case you're not familiar with Python. So Python is a general-purpose scripting language, and it is often referred to as a scripting language, as we talked about in the introduction to scripting, where there's some sort of divisions in scripting between dynamic programming languages and so forth. But it does fit in the category of scripting because it does run live and uncompiled most of the time. It is the primary focus of the language is for readability, at least according to those who create and support the language. It also supports many of the common software development paradigms. So this has structured programming, object-oriented, some limited functional programming aspects, as well as aspect-oriented programming. You can see that this language is full scale. It has basically every single type of programming structure that you would use in a typical software development landscape. So Python is a fully developed language.
It's everything in it.
It does. It has every
box.
Python is one of those languages that any type of project that you need to do, Python can do the job. It is very commonly executed with an interpreter. However, some people will compile it as an executable or into bytecode and run it against some runtime environments such as the Java virtual machine.
So Python's been around for a while. First version of it came out in 1989, or the first version was used in 1989. And then in 1991, the developer released the source code so that people could take a look at it.
Ooh.
Yeah.
I don't know why I just said that. It was just I'm looking for an excuse to jump in to interrupt you, because I know that you have lotions next to you, so I want to keep you occupied.
Well, you're trying to get the drama up too. So in 1991, the developer released the source code. No matter how you say it, it's really not that exciting, but it is exciting.
Like a movie trailer where they're like, in a world where the source code was not released in 1991. The source code was released.
Yeah, except for in this case, since it's like open source, you spoil the ending on your own, I guess. I don't know. Python was a successor of a little-known ABC programming language.
Never heard of it.
Yeah, I've heard of ABCs, but never as a programming language.
I've heard
you could argue
Michael
that,
Jackson context.
The English language is kind of like a programming language for people, but I don't know where I'm going with that. Anyway, moving on. First version supported many familiar programming structures like classes. We've gone over that. Inheritance, exception handling, functions, and primitive data types. All common stuff that, we're all familiar with. And that was all right there in Python right at the beginning. So it got off on the right foot and has continued on from there. So like we said, Python was inspired by the ABC language. It directly inherited from this language, kind of like how the American justice system inherited common law from the English justice system when we seceded from England in the 1700s. Go America! The C language inspired the style of syntax. C was common, so I think that was kind of the thought there, is that people would understand it a little better. Unix shell inspiration, it provided for the command line interpretation. Lisp provided its functional programming features. Perl brought in the regular expressions, and Java loaned its code packaging attributes. So Python came from, obviously, a litany of Inspirato, and came in to be something that was easy for people to learn and pick up and use.
Yeah, so basically Python stole a bunch of from a bunch of other cool languages. So the timeline here, let's go look at the different versions of Python. As Jason mentioned, the first version of Python was released in 1994. Version 2 came out in the early 2000s, and it boasted some simpler syntax, and it also provided some garbage collection, which those of you guys that are familiar with any languages that use manual memory management, that is a pain in the ass So having garbage collection is a very, very good thing. Version 3.0, I guess in the scale of things, wasn't that long ago, but as far as time is concerned, 2008, I guess it kind of feels like that was a lifetime ago. But version 3 was released in 2008, so fairly recent in terms of the release of a language. And basically...
Well, I mean, that's pretty... I mean, C++ just came out with a new version, last year, but other than that, most languages don't come out with major overhauls all that often.
Yes, and even the C++ update was not a complete from the ground up rewrite, whereas in Python, basically, they were looking back at version 2.0 and they said, we need to completely rebuild this from the ground up because the language needs a complete overhaul. And that's basically what they did. They rewrote the language for the most part from the ground up because as people were reviewing the language, they found some very deep core flaws. So basically, because of the complete rewrite, they lost all backwards compatibility for the most part. So the creed, so the slogan for 3.0 when the manifesto when 3.0 was being created, the philosophy was there should be one, and preferably only one, obvious way to do it. And what that basically means is instead of having all these different ways that you can do things, like reading a file, for example, let's make it so that there's one obvious way to do it, and let's gear developers to use that obvious way. Now, there's a clear benefit to that.
Yeah, I mean, when you only have one to rule them all, and in the darkness bind them, you can control all the realms of men, elves, and dwarfs.
Well, that's true.
Yeah,
that is one bad bad aspect of oneness.
Well, I mean, it's depending on your perspective.
I guess depending on where you are.
I've always sided with Sauron. I don't know.
I mean, the benefit to that is clearly obvious. Let's just say that Jason and I work together. He's working in a Python project, and he gets promoted, and I get promoted to take his job, and I sweep up behind him, and I'm using Python 3.0, where there should be preferably one obvious way to do things. It should be easier for me to pick up that code and run with it. Whereas in the case of Java, it takes you like 9 months to get up and running.
Or to
if you're lucky.
Child, 9 months. So the most existing Python code is written in the 2.x version. I mean, like we said, the 3.x version is only a couple years old, which I guess is pretty old now.
And that's what I was saying. 2008, when I look at the number, it doesn't look that long ago, but it was pretty long ago.
Well, really, if you think about it, I mean, Python was kind of to the web what PHP is now, like 10 years ago.
Yeah.
So that would make sense that a lot of code is written in 2.x because, a lot more Python applications were made that long ago.
Yeah, and it was in 2.x it was just around for a long time.
Yeah, 2001 until 2008, right? So
yeah, something like that. Yeah,
I know we just covered that, but I'm more worried about my lotions than I am with listening to what Kevin said.
I'm pretty worried about the lotions too. That's why we have to keep them occupied.
It is distracting.
If you start hearing weird noises, guys, let me know so I can put them on mute.
So like we said, it's been around for a while, but it will eventually be phased out. And this tutorial is part of that phasing out process, I guess, in a way, in that we're only going to teach you the 3.x way of doing things.
Why are you doing this to us, Whippet.net?
Well, we hope that you would develop new projects and do it the new way. And there's plenty of videos with the 2.x version. So we figure that we'd just be kind of reinventing the wheel there, I guess, a little bit.
Yeah, and why would we want to teach something that's outdated? I mean, that's just not cool. So Jason, let's talk about some of the reasons why 2.x is not compatible with 3.0.
Okay. Well, first and foremost, there's significant changes to the print statement. That's an important thing. So if it's completely changed and you're doing something new, you should probably know the new way to do it. Strings were switched from ASCII to Unicode. That's a pretty big difference. Python 3.0 added new data types. It radically changed fundamental language design, function annotations, and had more precise mathematical functions. So how do we deal with this? Developers created tools that converted the 2.0 code to the 3.0 code. I mean, that was awfully nice of them. They didn't have to do that. They could have just told everybody to buy our book and learn it yourself.
Yeah, right. Job security, I guess, right?
Yeah. Well, so that was pretty cool that they made a tool to help you out there. And that fixed most of the problems. And, with that, they recommend that you do migrate to 3.0. So that means that a lot of systems out there that have some of that legacy code, that old 2.0 stuff, will have multiple versions of the interpreter on that same machine.
Yeah, and I can attest to that. That is, I don't want to say hugely widespread, and it's reduced over the last maybe couple years, but there was a time, like maybe around 2010, where I saw an awful lot where Unix servers that I had worked on had multiple Python interpreters, and when you put the shebang at the top of the script, you had to be extremely careful which version you pointed at. Otherwise, it's it's not going to work.
Yeah.
So some of the other features that Python boasts are dynamic typing. So we're familiar with this in C#, where with the var keyword, the runtime environment will decide what the data type is while it's running the code, which is pretty cool and pretty useful for a scripting language. So when you declare variables, you don't have to declare the type, which is nice.
Yeah, it makes it one less thing that you got to worry about, right?
Absolutely. The automatic reference counting, again, those of you that are familiar with manual memory management are grateful that this type of stuff exists. But what it will do is automatically keep track of all the different instances that have pointers to them, and it will collect the object instances that do not have any pointers pointing at them. Late binding, which binds entities to names during execution. So those are features of scripting languages because it is running live. So we bind variables to names while it's running and not ahead of time. And it's highly extensible because modules can be written for languages like C, C++, and you can import that extended functionality. And also you can write them in Java. There's a number of languages that you can use to write modules that can be imported into Python. But that makes Python pretty fluid because if I have to write a Java class or I have to write a C++ class or some C++ code that's been written 10 years ago, I don't feel like rewriting it, I can work it in a way where I can import it into my code and use it. It's pretty awesome.
I'll tell you, Python, those guys and gals, they just seem like a very generous bunch.
They didn't around, that's for sure.
So the syntax follows the philosophy of less cluttered grammar. And that means that code is read based on white space rather than curly braces and semicolons. Developers thought this made the code look beautiful, explicit, and simple, and fun to use. I know
that I'm always smiling when I'm writing in Python, that's for sure.
I usually am because I am always smiling when I'm writing in Python because I'm drunk. So built-in data types are a mixture of mutable and immutable types. Python can be compiled to Java bytecode and run on a JVM. Jython. I imagine, I don't know who came up with that name, but I feel like they were overpaid.
Yeah.
For that.
I think it's kind of cute.
I guess. It's kind of obvious, but whatever, you know. I think it would be, if they went with Javathon, it would have sounded like a code, like people sitting there and coding for a whole weekend straight.
Yeah. Javathon, yeah. It's either like people coding, people drinking a lot of coffee, or like some like running events where they're doing it in like raising money.
Every 500 meters, you're given a steaming hot cup of coffee to just pour over your face. It's a 5K where instead of water, you're given hot coffee.
There's like that. Remember that Seinfeld episode where Kramer was running the AIDS marathon and he got the hot chocolate?
Yep, that's exactly what I was thinking. That is a Javathon. So not to be confused with Jython, which is the Python that can be compiled Java bytecode and run on the JVM.
So what industries use Python? Several. There's tons of them, but here's just a handful. The most common way that I've seen Python used in my career, and Jason, you could agree or disagree, is with server-side web development.
Yeah, it's like I said a few minutes ago. I mean, I think Python was the PHP of 10 years ago. Mm-hmm. PHP is probably the most widespread server-side web development language used now. Python was absolutely the standard 10 years ago.
Right. Now, it has, even though from how, I've been around a while in the field, so I've seen it used in web development, but even though it kind of got its start there, it has branched out into many other applications, such as systems engineering, people that are maybe in charge of, raids of Unix servers and they need cron scripts to run. And oftentimes they'll use Python as a language to do routines. Finance industry, healthcare, image processing, video games. Another big one is science, mathematics, and engineering. Because Python has a very precise math library, it's used a lot in that field. And I know that NASA actually implements Python, the National Aeronautics and Space Administration, for those of you that aren't American, for their space
for you
stuff.
Canadians, for NASA, it's for the Canadians. NASA.
No, it's NASA, buddy.
NASA, yeah.
NASA, eh?
That was a Trailer Park Boys reference for those of you out there that know what that is.
I have no idea what that is.
Oh, it's a great show, Kevin. You'd love it. It's very good.
So a couple of notable applications that use Python. Apache, those are you guys that are familiar with web servers. Lightwave, which is a 3D, you can make 3D animated videos and stuff. Yep. Inkscape, which is the open source version of, what is it, Photoshop? Or is it, no, Inkscape is...
I honestly don't know what Inkscape is.
I think Inkscape is the Adobe Illustrator, the open source version of that. GIMP.
That sounds right. Well, GIMP is the open source Photoshop.
Yeah. GIMP is, Paint Shop Pro, which, who the uses that anymore. Google App Engine and YouTube.
Well, that would make sense. YouTube is kind of one of the pioneers of the modern web. So at the time that it was coming out, I imagine they would have used Python. Notable organizations. I mean, we already talked about Google's App Engine and YouTube. So clearly Google is a big advocate of Python, as is Yahoo, NASA or NASA for you Yanks. Apple uses it, Red Hat, Linux. They're all big players and big users of Python.
And Wibbit.net? So, Jason, how popular is Python? I've heard a lot of people say, make a Python tutorial. Now, why would they ask us that?
Well, because it is 8th in the list of most popular programming languages, according to the TOBE programming community. We have the little list there in the graphic. You can see C is the reigning champion, but you go down a little bit and there's Python right underneath PHP, right above JavaScript.
And C has been the champion since it pretty much came out, and I don't really ever see that stopping. And I mean, those of you guys that question why we start with C in our programming tutorials as well, it's because C is sort of the foundation layer for everything software engineering. So why not?
Look at the whole top 5. The entire top 5 are Wibbit courses.
Yeah, right. And Visual Basic will never be a Wibbit course.
It will never be a Wibbit.
If it ever becomes one, then we've lost our way.
If it becomes one, then we are not on the video, and we've sold Wibbit.net for big dollars.
Well, that was my next thing. Was if you see one, and I will not go back and edit this to remove this if that happens. If you see one, it's because we were paid millions of dollars to make one, and we sold out.
A lot of Trident layers gum. We could have gotten that. I would take that.
I would there's no way. There's no way I would do it. It would have to be like $5 million baseline, because 50% of it's going to be taken away in taxes, right?
So we take payment in the form of wire money transfer or Bitcoin for any of you folks that want us to make a Visual Basic course for $5 million.
So let's talk about the interpreter that we're going to use in this course. Now, there are a few different versions and iterations of this, but we're going to use the Active State interpreter. So Active State is the software development company out of Canada, and they sort of make their specialty in developing, supporting cross-platform development tools, and some of that is creating interpreters, or at least maintaining and releasing interpreters for languages such as PHP, Perl, Python, TCL, or Tickle, if you're stupid, and Ruby. So that's what we're going to use, and it's very, Active State on their website. It's called Active Python. If you don't know how to go to a website and download something by now,
how'd you get here? If you don't know how to,
I have no idea.
Get to a website. I don't know how they would have gotten to this video.
I don't know. I have no idea. That's why I don't understand. Well, we'll do this when we do our lab video. We'll actually go download it and install it. But just to kind of give you a heads up, here's just the web page.
We'll feed you baby birds. Don't worry.
Yep. And now, what is this?
Well, that looks like a little bit of Python code.
No way.
Hey, buddy.
That's
some Python. That's some Python right there.
Wow. So all that we're doing here is just a very simple Hey Buddy program, and you can see it's pretty damn simple, right?
I mean, doesn't get much simpler than that. Just a print command, and you got yourself a Hey Buddy.
Done.
Python can be ran as a command line interpreter also, and it's very useful when performing math equations or short code snippets.
Right, so here's an example of that. So instead of actually having a script file containing a bunch of code, what some people will do is if they're sitting there working in a lab, I've seen this before where maybe scientists or engineers or whatever, they'll just write a quick equation and then they'll just type the equation into the interpreter and then they'll put their variables in and then run it without ever having to program anything. They could just run it from the command line, and we'll demonstrate this in our lab video later on.
Python is a OOP language, an object-oriented programming language, and it derives a lot of its functionality from C.
C. It all comes back to C.
It always comes back to C. So we highly recommend you have very highly. See, it's bold and underlined. So that means it's
and
really
italicized. It's all three.
Oh crap! You're right. That's big deal.
That's serious deal. The only thing that would make it better is if the font was slightly bigger.
It's true. Or caps lock.
Oh, caps lock. See, that would have made it even better.
Yeah, that would have been huge.
All right, wait. Actually, hold on. Wait. Boom shaka!
Oh, now it's big time.
Yeah, now we're not messing around now. Okay, this is a serious time.
You best recognize that we highly recommend that you have a working knowledge of C and at least one of the following OOP languages under your belt.
Yep.
And that's C++, Java, or C#.
Yes, sir. Preferably all three.
You could always go back and review these courses on our very own website, wibbit.net, to get the skills that you need to succeed with Python.
You know, it's funny. So I, at one point, this was a while ago, I came across some Wibbit.net review where we got killed by some guy because they're like, I was watching their Java course, and they said that you have to go back and learn C and C++ before you know Java. So they're just trying to trick you into watching their other courses. And I was just thinking, like, this guy is a complete idiot. Like, why? How could you possibly think that? Like, you know, like, this guy, you know, you want to be a doctor, but this guy makes you want to go to medical school first before you be a doctor. That's just...
He's trying to trick me into book learning.
It's like, what the hell's wrong with this guy? Of course you want to learn these. I mean, anyone that's a professional, someone that makes money in the profession and not lives in their parents' basement and uses their, you know, writes JavaScript code to download porn all day, they know that you need to start from the ground and work up. But you know, some people are just crazy. What can you do?
It's a very on-demand world. We want everything now. But stick with us. You'll learn Python. It may take you longer than a second, but in the end, you will be grateful.
And we highly recommend it.
Highly.
Ladies and gentlemen, Kevin here from Wibbit.net, welcoming you to the very first lab video for the Programming in Python course. In this lab, all that we're going to do is set up the environment so that we can create Python programs throughout this course. The first thing that I'm going to do is run out to the internet. So once I have my web browser open, let's just go to google.com and let's do a quick search for active Python. And it should come up in the very first hit here. You can see that we have the activestate.com/ActivePython. Now, in the video, in the introduction videos, we talked about ActiveState being the place where we're going to be getting the interpreter for doing this course. So let's just click on the download Python link. And that takes us to this page here. So on the download Python, we basically want to select whichever platform that we're writing for. Those of you guys that might be using Mac, you could select your DMGs. Those of you guys from Linux, you got your stuff here. And Windows, which is what we're going to be doing this course in, is over here. So depending on whatever, x86 or 64, download the appropriate version. So what we're going to do is, instead of we had talked about doing the version 3 in this course as opposed to version 2. So make sure that you download any version 3 dot something. Whatever the current version is at the time that you're watching this should be fine. But just do not download anything that is 2 dot anything. Again, 3 dot whatever should be fine. And on this machine, I'm running an x86 chipset, so I'm just going to download the x86 version MSI. And there's really no need for me to save it because I don't really care to have the installation files afterwards, so I'll just go ahead and run this. Excellent. Now we get to go through our next process, right? Pretty much every time that we go through the introduction setting up the environment, we just download something and click next a bunch of times. And that's pretty much what we're going to do here. So let's just go ahead and on the welcome message here, thank you very much. Make sure that you, with fine detail and with a lawyer by your side, read through the licensing agreement. I've already read this and had this double checked by my attorney, so I'll just go ahead and accept that. And with the stuff that we want to install, I think the default should be fine, so I'll just leave it at that. And you'll see that the location that we're installing this is going to be Python 3.3. Since this is going to be version 3.3, as you can see from this here. So that's perfectly fine with me. So I hit next, and I am ready to install, so let's let this thing go. That was pretty damn awesome. Okay, cool. So we've installed everything, and I don't really care about opening the user's guide, so I'll select that off and hit finish. Perfect. Now let's just say we want to open up a command prompt, so I'm just going to do Windows R and just do CMD. So here's my command prompt. All right, now let's see if we can run the interpreter. Python. We cannot, because Python is not accessible in the system path, as we have seen with the other C, C++, all that stuff that we've done before. In order for us to simplify the process of using Python, let's go ahead and stick it in our system path. Now, as we saw, Python installed itself in the Python 3.3 directory. Now, what some people will do is they'll just give it a generic, just call it Python or Python 32 or Python 64, whatever. But one of the reasons why Python likes to append the version number to the end is so that you can run multiple versions of Python on the same machine. So if we wanted to install Python 2. Whatever, we can install that on C:\whatever, under a different directory, and we could run a different version of Python on this exact same computer. So let's go to the Python 3.3 directory, and you'll see here we have a couple of executables. We have Python 3, Python stuff. What we want to do is just have access to this Python here. So very simply speaking, I'm just going to copy the directory path. And then on this PC, or however you have your PC set up, or it should be very similar to this, we'll go to the Properties, Advanced System Settings. And on the Advanced tab, we'll select the environment variables. I mean, again, we've gone through this before, right? I mean, this is not a new thing for us. We'll slide down to the system variable path, edit this. One simple thing, we can just kind of click in here, press the end key to go to the very last character, a semicolon, and then paste the path in there. Okay. Now what I should be able to do is start run cmd, open up a command prompt, and I should be able to type Python. And it worked. This is the Python interpreter. Now, just like we talked about in the intro video, we can actually just start typing some Python code in here, and it should interpret it. So let's just real quick, let's just say print, and we'll just say print, hey buddy, boom, and it worked just fine. We can do stuff like x equals 1 plus 10, and then we can do y equals x plus 1, and print y. And we get 12, which is what we would expect. So we were saying how you can just do real quick interpretations, running it inside of the interpreter just like this. And that's how you do it. It's actually very, very simple, as you can see. Now let's go ahead and type exit parenthesis to get out of the interpreter. And now we're back to the good old regular old command prompt. So let's just do a quick hey buddy in a script file. I'm going to minimize this. And on my desktop, I'll just go ahead and create a new directory. This will just kind of keep track of the stuff that we're doing throughout the labs in this course. And we'll just do Python, whatever, that's fine. Just call it Python. And in here, let's just make ourselves a new little text file. Right click and new text document. And we'll call this hey buddy. Now I don't have my Windows set up properly here. As you can see, I have my hidden file extensions. So I'm going to go ahead and fix that right now. View, file name extensions, cool, there we go. And just change this from .txt to .py for Python. And if you currently don't have Notepad++ installed, what is wrong with you? I don't even know you if you don't have that installed. So if you don't have it installed, just go Google Notepad++ or go back to watch our Programming in C introduction lab where we go out and download it and stuff. So I'm just going to right-click on the Python file and just edit with Notepad. Now we'll get into some more of the advanced stuff with Python as we progress. Now, as you recall, Python does not separate its code by using code blocks like what we're used to. Python just separates its code using, tabs or spaces. Indentation is how it separates its code blocks. So when we get into other structures and just a little bit like loops and decision statements and functions and classes, we'll explore that concept a little bit more. But just for the purposes of this, let's just go ahead and do a really simple hey buddy program. So we'll start with the pound and we'll put a comment here that says hey buddy.pl, and we'll just do a print. And you can see Notepad++ will try to give us an autocomplete there. And we'll just print out hey buddy. Hey buddy, exclamation point, save it. Let me go back to my command prompt, and I'm just going to have to cd into my desktop, which is where I put this, and then Python. Let me do a little CLS action here. And there's my Python file, heybuddy.py. So I can do Python, and then heybuddy.py, Now I run that. Hey, buddy. So there you go. Right now, the environment is set up, and we basically have everything that we need in order for us to go through the lab content for the Programming in Python Whippet.net course.
Python data types. What are they? Who do they love?
A great intro. That's the best intro I've ever heard in my life.
Hey, it's what I'm here for.
It made me, I shed a tear when you said that.
Well, I mean, far be it from me to call you a pansy.
So what is this lesson about, Jason?
It's about dynamic typing. All or the majority of type checking occurs at runtime in Python.
Ooh.
The values have types, but variables do not. A variable can represent any data type, so you don't have to declare what type of data type it is when you declare the variable. You just have to declare a variable and then whatever that is.
Awesome. Yeah, so to pile on to what Jason was just saying, Python uses an object-oriented derivative of dynamic typing called duct typing. Now, we are familiar with dynamic typing. We've used that in other languages. So let's take a look at this duct typing idea. It creates an environment of polymorphism without the need for inheritance. So that kind of what sets the difference. An object is not judged by its lineage, who its parents are, who it is. It is judged by the members itself. Now, that's kind of a deviation from more strongly typed languages or more structured languages, I guess, like C# and Java, where things are deciphered or discriminated or just whatever by their lineage. And in Python with duct typing, it doesn't work that way, which creates a much more polymorphic environment compared to other languages like C#, Java, C++, definitely.
So it's got your core primitive data types like Boolean, true or false. It's got strings. They can be represented by double quotes or single quotes. So pick your flavor. They have numerical data types, integers, floating points, complex numerical data types, and then none. So unknowns. Sometimes this is synonymous with void.
You know, it's funny, like when I write in scripting languages, I always use single quotes. When I write in, obviously with like C# and Java, you need to use double quotes. But for some reason, instinctually, if I'm writing in JavaScript, I use single quotes. If I'm writing in Perl, single quotes. The only exception are languages that don't support it, like TCL or a few other languages that don't. But for some reason, if it's scripting, if it's live scripting, it's single quotes for me. I don't know why. Maybe it's because I feel like this is a lighter language. So why do I need to have two marks when I can have one mark? I don't know.
I don't know. I guess since I do a lot of web stuff, I always think of it like if I want to put quotes in the string that I'm putting in there, then you don't have to worry about an escape character. You can just put in the double quote as part of your string.
That's true.
That's pretty. I have actually sat and had a good 25-minute introspective thought about why I use single quotes or double quotes. I was fired for wasting company time for doing that.
What?
It was worth it. No, I'm kidding.
Oh, okay, I was going to say, that's the most ridiculous thing I've heard in my life.
That didn't happen. Could you imagine somebody sitting there for 25 minutes thinking about why they use single or double quotes? But why?
Why?
Why do I use the single quote?
I know, I think I'm going to have to go on like a month-long, trip to India to find myself.
Yeah, you got to go to a trek through the desert or
I got to
like that.
Do the Steve Jobs trip to India that he did when he went to go find himself. So now let's look at the Boolean data type. Now we are familiar with this. I know I keep saying that, but we've seen this stuff before. Boolean data type is declared as a literal true or literal false with the capital T and capital F. You can also see that it can be declared in a couple other ways, or at least one other way here. We can use the Boolean constructor, and we can pass a 1 or a 0 into that constructor, and in effect, that's the exact same thing. Now, another thing to keep in mind, as you can see here, with this loosely typed language, we are not declaring those variables as a Boolean or a bool. We are simply saying this variable equals this value, and true and false are keywords that the language has reserved and will recognize as the Boolean data type of 1, Boolean data type of 0. So pretty simple. Strings!
Yay, strings. So again, you could use the double quotes or single quotes. We've already gone over that.
Wait, whoa. We can use 3 quotes? What is this all about?
That just blew my mind.
Wait,
well, that's a 6 quote. That's a triple double quote. That's like the triple sow cow of programming languages. For those of you who know anything about figure skating, of which I do not.
Sure you don't. Sure you don't.
I mean, okay, I do watch it on the Olympics and on the weekends and weekdays, and I have Brian Boitano's poster above my bed, but that's not the point here. The point is we have our example in front of us, right? So we're declaring our variable as string 1, and then we're using the double quotes to encapsulate the string there. String 2, we're using the single quote. String 3, we're using the triple quotes.
Whoa.
And all of them do pretty much the same thing. As you can see, our print statements are printing out each line individually. And then in our example console to the right, they're all being printed out.
Right, so with the triple quote, we'll take the innards literally, so you can do stuff like line breaks and tab characters, and it will interpret that without needing to have any escape characters. That's pretty awesome.
That is pretty awesome. That is a nice feature.
So concatenating strings, here's a simple example of that. Again, we're familiar with this type of thing. We have a variable here called website equals a string, wibbit.net, a variable called language, which equals a string, Python, and then another variable called sentence, which will equal the concatenation of several strings. So we have one string called learning, and then we just use plus to concatenate the two together. So we're combining learning language, which is Python, plus on, plus website, which is wibbit.net, is awesome. So the output of our concatenation of those strings is wibbit, or learning Python on wibbit.net is awesome. A little shameless plug for the website there.
Because everything is awesome.
Everything's awesome on wibbit.net. That's for damn sure.
For sure. Similar to other languages we've learned, strings are objects in Python. We can execute methods on them to modify and manipulate the value. More on this at 11. So the here at the bottom we have our website equaling wibbit.net, and then we're saying print. We're printing out a function to say, does the variable website start with the term wibbit? And on the right, our console has shown that is true.
Right. So the important thing to get out of this is that website, in this case, is being treated as if it is a object. So this is not like a char star in C. This is a real object. And we know that because we're interfacing it using a method called starts with. So let's take a look at some numbers. Now, numbers are just as easy as strings, except for they don't have quotations around them. Again, with dynamic typing, there is no need for that because Python is smart enough to know that you meant this as a string, you meant this as a number, and it will also let you swing back and forth between the two during runtime with no problem. That's the beauty of these types of languages. So in this case, we just have 3 simple examples. And basically, we're just demonstrating here to set the numbers. We have x equals 10 and y equals 100. Now, you can see that it's very, very easy. Just like if you were writing a math equation on a piece of paper, that's how you would write it down. Now, we're also going to demonstrate a couple of ways that we can print this. Now, we'll go more into this later, but you can see that in the very first example, we're printing x and y and then x plus y, and they all show up on 3 different lines. The next one, we're printing x comma y comma x plus y. And as you can see that by putting the comma there by default, all it does is it puts a space in between each one of the variable values. And then the next one is the exact same thing, except for now we're adding the plus and the equals to just show the person that 10 plus 100 equals 110.
So you can do complex equations and use complex numbers and things with Python too in the numbers. So here at our top left, we have pi equaling 3.14.
Which is not very precise, but...
No, well, it's as precise as we need it
It's
to be
like
right
second
now.
grade math.
We could have gone 3.141592, but whatever. We'll stick with the...
I typically go at least 64 digits in.
Oh, here you are, showing off again. Okay, well,
don't ask me to spout them off because I'm too smart to lower myself to your level.
I've run out of fingers already, so I can't count that many. So the radius is 113.89. So the circumference is 2 times pi times radius. And now we're going to print out the circumference and the equals. So just like we did in the previous example, we're adding that comma there. So we're putting in the string circumference equals comma, and then printing out the circumference, which is the result of that equation we put as the circumference variable. And then on the console printout to the right, we have what the console will print out.
Right. So the important thing to get out of that is there is no distinction when we put numbers in. We can do real numbers, like in this case we have numbers with decimal points, or we can do whole numbers like we did in the previous example, and we just type them. There's no declaration whatsoever.
The flexibility here is pretty crazy. I think with the previous example we showed sums of things being handled individually, and then with this one we're showing it, like the circumference is bringing in the variables and doing the math all there, and then we're concatenating everything in the print command. So it's it's very, you can do whatever you want there. You have a lot of flexibility on how you want to write your code. The next example we have here, we're going to combine a few other things. We have our website equaling wibbit.net. Our course name is C++, and the number of viewers is 1. So what are we doing next? We're going to print out the name of the website currently has number of viewers referencing our variables, and the output to console is wibbit.net, currently has 1 viewers watching C++.
Cool, pretty simple. Now, going back to that top example, just a little fun story. Like when I was in college and I was doing like engineers, statistic, mathematics and stuff like that, I actually used Python all the time to do my homework because I would just type the equations in and then put the variables in and then so like any of you guys that have like little kids and you want to teach them how to program, if they bring home their simple like algebra, you can show them how to, build a Python program in a very easy way with that they will have a easy time understanding it.
And Kevin, the audience at home probably doesn't know. I do have 2 daughters. One of them is just starting to get to the age where I can start to teach her to code and teach her to use command line and everything. And even though I know she should follow the C lineage from Wibbit first,
because we highly recommend it.
We highly recommend it because of the readability and because of what we're talking about right now with math and everything. I am going to start her off with Python first in a Linux environment to learn that way first.
Yep, good.
Because it's a little more useful for her in her day-to-day school life. I mean, she's going into 2nd grade. There's not a lot of there's not going to be a lot of need for complicated Java applications, but to do something like this where a Ninja Turtle equals 1 and My Little Pony equals 2, and then Ninja Turtle plus My Little Pony equals 3, that will be useful for her, and that's a good place to start for youngsters.
Yeah, and I actually kind of another side story. I actually a friend of mine, I taught her 8-year-old son how to write in Python, and he picked it up pretty easy. So if an 8-year-old and a 2nd grade, wait, how old is 2nd grade? I don't even know. Is that
7?
7? Okay, if a 7 and 8-year-old can do this, so can you.
Well, I have a pretty smart 7-year-old, so
which is kind of weird because it's your spawn, which I don't understand, but whatever, it is what it is.
Me and my wife have had talks about that. So, she clearly takes after her mother. But thanks for watching.
Yeah. Welcome back, everyone, to Programming in Python from Wibbit.net. Here we go again on another exciting lesson where we're going to talk about console input/output. Not necessarily in that order, by the way. It's just I find it weird, like, even though typically you teach output before input because you like to show people that you can spit something out first because they can see it before you show them how to consume it, but yet we still say I-O instead of O-I, but whatever.
Well, that's just the natural order of things. I mean, when you eat something and then you poop, it goes in first and then out, right?
Yeah, but when you're making sweet, satisfying, passionate love, it
still goes.
It goes in first. Never mind.
And,
shut up. Sweet, satisfying, passionate love. By the way, how's that the lube you got going on over there?
Well, I ran out on the last lesson. It was an intense lesson.
Well, you should have saved it for this one. This one actually has a little bit of meat to it. So let's talk about the print function. And simple description of the print function is it will print objects to a stream. So the basic syntax is just a print with the parentheses for the arguments. And the simple usage of it, which is the one that we've seen a couple of times. We've actually seen both of these already, where we have a list of objects, and we'll go over a little bit of how this works. So this is the basic usage of the print function. The print function in this case is just taking in a string, and it prints out what is in the string. And we've also looked at this, where we're sending it a list of objects, and by default, it puts a space in between the string representation of each object. And we'll see in a second that we can customize this to be whatever we want.
So here we have x equals 20, y equals 30, z equals 100. So instead of putting them into string format, we're just going to say print x, comma, y, comma, z. And as you can see with our console output on the right, it's put in the spaces of between 20, 30, and 100.
Right. Now, as I said in the last slide, it will print out the string representation of the object type. Now, in this case, these are not strings. These are numbers. When we get into writing classes a little bit later, you'll see that if you want to have a string representation of your class, you actually have to actively do it. So in this case, numbers are given their own string representation, which is basically the numbers inside of a string. So we'll take a look at how we can customize that later. But in this case, it's very simple. So let's talk about, Jason, let's talk about the sep param that we can implement in the print function.
Well, it's a param that specifies what character to separate the individual items passed to the print function. The default value is the space, as we talked about. So in the example, we're saying print object, comma, object, dot, 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 comma, sep equals underscore.
Right. Now, one of the things, and we're not going to spend too much time on this because it's pretty self-explanatory, but when we're passing this as a parameter, we're actually Python lets us give it a label. See how we have sep equals? So that means that you can stick that in out of order, and Python will be smart enough to know what that value is, which is pretty damn awesome.
So with our sep equals double underscore, the same example from before, we have x equals 20, y equals 30, z equals 100. It's the exact same command as before, x, comma, y, comma, z, comma, but now we're putting that sep in there with the double underscore, and as you can see in our output to console, it's 20, double underscore 30, double underscore 100, as opposed to spaces between them as is default. So we were able to change that on the fly, which is nice.
Now that just makes I'm sweating, I'm so excited. Now let's talk about the end parameter. Now the end parameter has a similar type of function with the print statement. We're just customizing what we place at the end of the string. So this is a parameter that specifies what character to end the print execution with. Now by default, it is the line feed, which is \n. So in this case, we're actually just specifying it to be the same thing. You can see that we have end equals \n, but if we don't want a new line at the end of our print statement, let's say we want nothing, or we want a different character like a tab or a comma.
Or like a bang, like an exclamation point, something like that.
But yes, like getting banged, like Jason just said. So here's a simple example where we are setting the end equal to nothing. So watch this. So we have print, hey buddy, comma, end, quote, quote, then print, how are ya? And you can see with the output here, by saying end equals, quote, quote, that means that there's going to be no characters appended to the end of that line. So if you want to have two different lines append together, two different print functions append together, this is a simple way that you can accomplish that.
File param. It specifies the stream to use.
What?
The default value is stout or
stout.
Stout. You like that?
I like that.
Okay. So now we're going to print out object, comma, object, and we're declaring the file param as sys.stout.
Right. Now even though that's the default value, in this case, we're just adding it just to show a demonstration, but you could also see how this could be a network socket. This could be writing to a file. So you can use the same print function to output data to a number of different types of streams. And we're actually going to get into that a little bit later on.
So here we're going to import sys, and then we're going to use our file param here in our example. So we're going to print out, hey buddy, to that sys.stout, and then print out, how are you, to sys.stir.
Right. So we'll write one to std out, one to std error stream, which are both, even though the console will typically show them both, they're both technically different streams that the operating systems use. So Jason, let's have an example where we combine all three of them.
Whoa, getting crazy. So, all right. So we got the same thing. We got the hey buddy and how are you? And we are going to put nothing as a separator, or a blank space as a separator, and then a blank space at the end. And then we're going to print it out to the file std out. And then we're going to, at the end of that, print out that I hope you're well.
That's awesome.
We're getting awfully familiar with our users. So the output, the console, as you can see there in the black, is hey buddy, how are you? I hope you're well.
And like most people that write comments on the internet, we spelled your correctly. So we've seen this sys module implemented a few times in the previous examples.
That we have.
So sys module provides access to variables managed by the Python interpreter, and there's a ton of things in this module. And if you go to this link, it'll explain them all. We're going to go a little bit more into sys a little bit later on, but just to kind of let you know, we have shown the sys implementation, module implementation a few times. Didn't want to leave you in the dark wondering what the hell is this whole sys thing, so
It's giving you the first look into a larger world.
Exactly.
Now go to that link and explore the world.
Yeah, it's kind of like when Hubble did its deep field, right? When you take one picture, nothing shows up. When you do a ton of pictures with low light exposure over the course of a long period of time, you see billions of galaxies. So there we go. So the import statement, Jason, what's this all about?
It imports a module into a Python script. So we've seen that in our previous example, we said import the sys module, right? So the common implementations of it are import a module as a name, or from a module, import an entity. So you could take a piece of a module and import it, import that part of it.
Yep. Now in Java, when we were importing packages in Java, you can do stuff like import java.io and then a class, or you can say import, and that would be the equivalent of that bottom example. You can say import java.io.star, and that'll be the equivalent of the first line. The middle line, we can import a external library and name it something different inside of our script, which is pretty awesome.
So here we have some examples. Some of them you may have already seen a little bit in our previous examples. The top left there, we're importing the sys module, and we're printing sys.argv.
Yeah, argv, which is the argument vector, so that'll be the command line arguments to the script. See, if you did your C videos, you already know that.
You can import your sys module as Wibbit. Again, we are shameless self-promoters. We don't mind that. So again, we're printing out the same thing as on the left is on the right. We just renamed sys as Wibbit. So we're printing out wibbit.argv, or argv, as I like to say.
Argv. You do have funny names for things. I do like that.
I just like to pronounce this language is meant to be pronounced. Everything is it's made in such a way that you want to pronounce everything.
But do you highly recommend that you pronounce it that way?
I don't know if I would go that far. That's a bit of a commitment I'm not really willing to make yet. But it works for me.
Okay, so fair enough.
So now next we're going to say from the sys module import std out.
Ooh.
Yes. So we're then saying, hey, buddy, file equals std out.
Right now,
so
you remember before, Jason, we had before we had like sys.std out and a few slides ago?
Exactly. So now we don't have to declare that. We can just say std out.
Yep.
And then our last example here is from the sys module import std out as, now this is big time because it's all capitalized, std underscore out.
Or so now, stood out.
Stood out. Or I like, well, no, std out, I like to say, or stout. I don't know. I go back and forth. So just like our previous example, here at the bottom, we're printing out, hey, buddy, and file equals std underscore out. As you notice, we didn't have to declare sys, and it is spelled slightly differently than the traditional lowercase, all one word, stout. So this gives us some flexibility there.
Isn't that something? Console output can also be achieved by directly interacting with stdout. So when we're using the print function, we're in effect using the standard output if we don't specify a different file to write to. So in this example here, we can import sys, we can do sys.stdout.write, and that will write out a line of text to console just like the print statement does. Now in this case, it's going to take it more literally, so you see that we're actually adding the new line at the end of it. Command line arguments work very similar to C and C++. Even uses the exact same variable name, argument vector, argv. In this example here, we're calling the Python interpreter, and we're calling a script called cmdargs.py for Python. And in that script, we have import sys and then print sys.argv, which are the command line arguments passed in by the user or by the caller. So our arguments are, hey, buddy, welcome to Python. And you can see it prints them out as a list. Now, we're going to talk about, lists and arrays in a little bit, but this is an example of a list. So you can see that it's broken apart into the appropriate vectors. Not bad, huh?
Not bad at all, Kevin. Not bad at all. That'll do, pig.
That'll do, pig. So here's an example where we're using the command line arguments again, just to kind of show how we can interact with them as if they're a list or array. Again, we'll talk more about that a little bit later on in detail. So in this example, we're importing sys again because we want to have access to the sys module. And we're just going to create a variable called argc, argument count, which again, those of you guys that followed C and C++, that looks familiar to you. And we're just going to use a function called len, which we'll talk more about later. And what that's just simply going to just get the length of that array. So we have argc will be the number of arguments that were passed in. We're just going to print out to the user num args, ending it with nothing, so that they will concatenate to the same line. Num args and the number of args. So in this case, we have num args 6, and then a little print statement there. This is just a simple way of just creating a blank line. So we have a print statement with nothing in it, and it will end with a new line by default, so it just creates a new line. So just to demonstrate how we can interact with this, the first line there is the same one as the last example. We're just printing out the string representation of the list, as you can see there. And then we're just going to interact with each one of the different elements by their index, 0, 1, 2, 3, 4, 5, just to kind of print them all out individually. Now later on, when we get into loops and stuff, we'll actually iterate through them and show them to you. But again, this works functionally like an array, which is a concept that we've gone over in many different languages already.
So we have two common methods of console input. There's the input method and the sys.stdin. So let's talk about those things.
Let's talk about it.
Seems like a waste of a slide just to have those two in the function.
Hey, you know what? This is my favorite slide of the entire. I get paid by the slide. Did you know that? So
I did not know that.
Yeah.
And now that I do know that, I'm going to dock your pay. I don't think I have those rights, but all the same.
Doesn't matter. It doesn't matter.
Yeah. We're just talking here. We're just talking. It's fine. All right. So let's take a look at this example. So our first name is nothing and our last name is nothing. We want to have it so, you know, our good old friend Bill Mill is who we're going to be talking about here.
Yeah.
So we have, we're printing out our form, so to speak. So enter your first name and then we're ending it. And then the first name equals input. That's that's what we're talking about. That's where somebody can input into the console something.
Awesome.
And same thing with the last name. We want them to input their first and Bill Mill. We want him to put in his first and last name. So now we're going to write it all out. What are we writing out? Nice to meet you. Enter your first name, space, enter your last name. And when that is all together and we run it, you can see on the right, the first line that comes out is enter your first name. Bill will put in his first name, hit enter. Enter your last name, he'll put in Mill and hit enter. And then it'll combine all that, saving the first name input and the last name input, and then print out the console, nice to meet you, Bill Mill.
The sys module provides a stdin property that can be read from, just like it's a file. And we've used this stdin showing the print function just a little bit ago. So this is not a foreign concept. We've seen this in other languages before. We will discuss files more in depth later on. So for right now, we'll just cover some simple basics. So let's take a look at using stdin to read data. Import sys, creating two different variables, first name and last name, when they're going to be strings, and right now they're just set no values that are equal to nothing. We'll ask the user, just like in the last example, enter your first name, ending it with nothing, so that it will concatenate together. We can call sys.stdout.flush, so we're flushing std out. Then we're going to set first name equal to sys.stdin read line. So just like we use C++ and we use read line, very similar type of thing. The person will type Bill, press enter, the line ends, enter your last name, std out flush, which basically means that we're just clearing the std out buffer. We should be familiar with that by now. Last name equals sys std and read line. So there we go. Bill, enter, Mill, enter, and then we just tell him, nice to meet you.
It's like, nice to meet you, Bill.
Mill.
So wait a minute.
Whoa.
Like, wait.
What?
This doesn't look right to me.
It doesn't look right. No,
something's off. I mean, why is it nice to meet you, Bill Mill, and why isn't it nice to meet you, Bill Mill? Why is the Mill on the new line?
I don't know.
Funny, I should ask.
Let's find out. What is this all about?
Well, when reading a line from stdin, the new line character is captured.
Oh, no.
It is. It is common to strip it, though, using a string method called rstrip.
Not to be confused with strip bar.
Right. This is like the pig Latin. Well, no, it's not. I don't know. I tried really hard to just move right on past it so that you couldn't get that in there. But, you know, I apologize to our audience. Hold on. Let me get more lube out. Okay, more lube's done. We will discuss more about this in the string lesson. But for now, we will show you how to use it to solve this problem.
Okay, now let's see how we can solve this problem, Jason. What are we doing differently?
Well, as you can see, we're doing a lot of the same stuff that we've done on the previous example. Except we're adding the rstrip to the end of the string. So on the first name and the last name, you'll see right there in the middle, after the sys.stdin read line, we're appending rstrip and we're removing the new line character. Nice. So that will fix the problem from before. And instead of nice to meet you, Bill Mill, now it's nice to meet you, Bill Mill.
Awesome. And just like we said in the last slide, when we get talking about the string class, we'll get more into that. But simple way that you can solve this problem. So when you're messing around and learning the language and you run into this problem, you could easily fix it. So that is a simple marathon of input and output to the console in Python.
Thanks for watching. Python, basic syntax, Wibbit.net. You know what I'm saying? Let's get this joint rolling.
Okay, that is the worst intro we've ever had, without a doubt. No question.
No, I'm saying Python. Let's go.
Did you cross your arms like in the old like bebop videos?
No.
Like word, you know, cross your arms. The b-boy stance. If there wasn't
Python, you know what I'm saying? There we go.
Yeah, guys, so we are now going to start talking about some syntax in Python. We've kind of gone over some of the basic stuff. Now we got to talk about the one thing that really makes Python unique when it's compared to other languages, and that's the basic syntax of the language is not at all, in any way, shape, or form, at all the same as what you're used to. So
take everything you've learned about Wibbit from Wibbit.net so far, everything, and forget it. You're never going to need it again.
I know, for loops, if statements, they don't exist anymore.
Now you're getting granular, and I don't like that. Let's just stick with forget everything that we've taught you so far.
Yes, so we're going to go over some of the basic differences so that you could more easily transition from the skills that you have into Python. So first, let's get started with a quick warning. So we're going to be showing some code samples as examples, and we're not going to be discussing the programming structures that are in them, at least not yet. We're going to be taking this in a later video, like if we do show stuff like if statements. You should have enough knowledge at this point from your C training and Java training and C# and all that stuff to recognize what an if statement is, what a loop is. So in this case, we're not going to go over it, but we will go over them in detail in a different lesson. So the reason why we're doing this is just to show the code syntax. So don't be afraid. Don't be scared. Everything is fine. We're not jumping ahead. We're not leaving you behind. Don't worry. Be happy.
If you are afraid, just do the duck and cover method. That works for both nuclear bombs and for this.
Wasn't there a South Park episode where Terrence and Phillips did that, and then they got like the duck and cover?
It was for the lava or something.
The lava, and then and they ducked and covered.
Movie.
They ducked and covered under their desk, and the lava still burned them.
And in this case, ducking and covering to avoid syntax fears it won't save you.
It won't save you. Exactly. All right, so Jason, let's talk about some of the syntax philosophy.
Well, it is designed to be highly readable, so it's designed so that you can kind of read it in like a book, I guess, a little bit more than other languages. It has very subjective statements. You may love it, you may hate it. You're going to fall in one of two camps. It attempts to be uncluttered and cleaner. It uses English words often, where other languages just use punctuation symbols. There's a complete contrast with the creative Perl developers. Python, there should be one and preferably only one obvious way to do it, while Perl, there's more than one way to do anything. So the old phrase, there's more than one way to skin a cat, does not apply to Pythons. Python can only shed its skin one way. I came up with a new phrase there.
There you go. See, I've always, Brian's brought up that phrase in previous tutorial videos, and he loves to say there's more than one way to skin a cat, and my response is automatic. It's always, yeah, there's also always more there's more than one way. Let me say that again. There's more than one way to do something a lot less gross than that. So we're not going to go over this one at a time, but just so that you have it in your documented history somewhere, Jason was saying that there's a lot more English words in Python, which is true. Here are some of the reserved words. These are words that you cannot use as variable names or anything like that in other statements because, like method names, class names, because they are reserved by the language. We're not going to go through each one of them. And, just here's some stuff. Ooh, this is cool. This is nice too. Look at all these words. Ooh.
Lambda. Typing in lambda is a secret in Python. It will bring up a guy that says nerds. That's not real. I just made that up.
But if you do ABACABB, then like blood will splat on your face.
Blood, or you'll skip the level and you'll automatically know Python.
So let's take a look at the C language, which is a language that we should all be familiar with at this point. When we take a look at all of these different code examples, each one of these is technically going to be compiled and executed the exact same. So all this code is created equal based on the syntax of C. So some of the basic syntax rules of C is the curly braces will block out code. White space is ignored by the compiler. So that means that your indentation doesn't matter. As long as you have things within the correct curly braces, it will execute, and it should execute fine. So you see all this code is equal in C. The problem with Python is that it's not like that at all. Python,
not at all.
No, not at all. Python is very strict about how you structure the code, and we're going to get into that here in just a second. So the Python syntax is based on white space indentation, so code is assigned to program structures based on left indentation. Code is often tabbed to indicate grouping. However, technically space characters are acceptable, so as long as the code is aligned, it's considered to be part of a code block. Let's talk about this a little bit more, Jason. What's going on here?
Well, on the left there, we have a C example, and on the right, we have a Python example.
Ooh.
As you can see, there is, like what Kevin said with the C example, there's curly braces, and what's between them will be evaluated. Well, with the Python example, we don't have curly braces.
Nope.
We don't even have parentheses.
No, well, we do have parentheses.
Well, not at the beginning of the if statement, though.
That's true.
It's crap. I shouldn't have said that, should I? I just confused everybody.
No
That's
problem.
okay. I told everybody to forget everything anyway, so forget what I just said. There are parentheses, but they're not at the beginning of the if statement like you see in the C example.
Well, we need one of those. We need one of those Men in Black memory erase things right now.
Yeah, you'll notice also instead of the curly braces, it kind of works with you have the colon there. Instead of exit, we have quit. So there's some different words to indicate different things. But basically, this code does the same thing. Just on the left, you have C. On the right, you have Python, and the differences are evident.
Very obvious differences. Now, when we go back and forth between these two programs, even though this one here uses the tab character to indent, this one uses a single space character. Technically speaking, both of these programs are the same as far as the Python code is concerned. But if we were to align them all up like this,
Error.
we would get an indentation error because Python is not able to decide which one of those belongs to which block of code.
I kind of like Python for this. It makes it a little bit cleaner because I've seen a lot of code where people kind of put everything between the curly braces on one line or something, and
Well, that's because that guy is a dick.
Yeah. Well, or like in JavaScript, if you use a minifier, and I know you should always have your minified code, but also your regular code, but it's still, sometimes you're looking at what's actually being executed. That minified code is really hard to read.
Well, yeah, but minified code is not supposed to be read. Minified code
it's not, but
is just to reduce the amount of data that's being transferred from server to client.
Yeah, it's making this file small.
Exactly.
But still, sometimes I've sat there and tried to read the minified code, and it's a nightmare.
That's because you're an idiot.
I don't follow. I'm a rebel. I will modify the minified code and not the source file. I'm a rebel.
Let's walk through a program here. So here's a Python program. Again, we're not going to go over the control structures or anything like that at this time, but let's just follow this logic. So we're just creating a variable x equals 3, and we'll evaluate that. If x is less than 10, which in this case it's true, we will evaluate this block here. So we'll print out to the user that x is less than 10. So we're just going to check to see if x just happens to be equal to 5, which in this case it is not. It's equal to 3. So that code down there where it says print 5 is the special number and quit, they will not be executed because that block belongs to the if statement, so the logic of the code will then follow down to this line. Now, when I change this value to 5, we evaluate this code. If it's less than 10, we tell the user that it's less than 10. We evaluate if x is equal to 5, and in this case, it just happens to be, so we're going to execute these two lines of code, and at this point, we're actually quitting the program, so we will not actually hit that code below. So this is just demonstrating how the indentation will segregate code for the different code blocks.
Pound is used to comment out your code. If you want to write something, a note to another developer, or just kind of leave yourself a marker or anything at all, to turn off some code that you don't want to actually run, you would put the pound character at the beginning of the line, or really anything after that pound character will be ignored by the application when it's run. So you can use it in a single line, like our first example where it's pound test.py, or on our second example where we're putting the comment after a bit of code, or on the third example where we're doing the same.
Yep, so this is how Jason, he likes to put ASCII art of grotesque human anatomy in his code, and he likes to put that in there using his comment so that you don't see it until you actually read his code.
I do it all the time.
He does. So let's talk about typing. So we're dealing with dynamic typing in Python. Everything is an object, and variables do not have any specific data types, and data types are assigned during runtime. So we take a look at these two examples. The first example, when we are setting an integer, all that we're doing is just like you're writing a math equation on a piece of paper, x equals 10. If we were to try to cast this as an integer, it would be bad. Because Python is designed to be fluid. It's designed to be like water. Like all scripting languages. That's kind of the whole point. And that's why we have scripting in its own area as opposed to the other languages that we've been learning, because they are supposed to be more fluid. So in this case, Python doesn't want you to tell it that it's an int. It wants to know. It knows itself that it's an int.
You can't just tell it what to do. It's going to do what it wants.
Exactly. There's no rules, man. It just does whatever it wants to do. So variables represent pointers to an instance of an object. So everything is an object in Python. And argument passing follows the pass by reference concept. So if I were to pass a mutable object to a method or a function, if the mutable object is modified, then the calling code will be modified because it's being passed by pointer reference. Now, if you're using an immutable object, such as a number or something like that, that will not be the case. But if you were creating a class and you had fields inside that class and you passed that to an object, to another method or some other code, that it's fair games to be modified. And that's just how it's designed from the core.
Common primitive types. We have conventional primitive types like an integer or floating point, collections like lists, tuplets, sets, dictionaries, or text strings.
Ooh, awesome. Yes. Very cool. The semicolon controversy, Jason. So does Python require a semicolon?
Survey says no.
So can Python use semicolons?
Yes, it can.
It can? Well, then why?
Yes.
What the hell? This is craziness. So look at these examples here, Jason. This will all execute the same.
Yeah, you're adding a whole bunch of semicolons to the two examples on the right and bottom, while the first example, it's a little bit cleaner. It's a little nicer looking, if you ask me. You don't have all that all that grammatical hermaphrodites all over the place.
You would think that. Well, the semicolon in Python is still used as a terminator character, just like it is in all the languages that we've been exposed to so far. So if you look at the very bottom example, look how the code block that belongs to the if x equals 5 statement, look how we stacked 2 lines by using the semicolon. So you can still minify the code by stacking them using the semicolon if you want. However, that is very unconventional and is not common to see, except for in my code. Hey guys, welcome back to Wibbit.net Programming in Python. Kevin and Jason are here to go over working with strings.
And that's not puppet strings.
Or is it? Or is it puppet strings?
We are the puppet masters.
We are the puppet masters.
And we're going to teach you how to pull your own string.
Yes, we will.
Oh, that doesn't sound right. Phrasing. Pull your own string. I don't know. Never mind.
Well, like in one of the labs that I was recording, I had a variable because I was doing something with hours, minutes, and seconds, and I had SECS as the variable name. So I kept saying the word sex and wasn't really realizing it. And then I was like, oh, wait, not that sex. I mean, like SECX.
Right.
Not that funny. I'll probably edit that out.
Not sex. So strings are a class. Encapsulated in each string instance are methods that allow a new mutable instance to be returned. More details are available at that address.
Yeah, sucker.
So don't try to copy and paste it because this is a video and you won't be able to do that.
I mean, you can try. I mean, you can. But
won't go well.
You can just download the PDF and everything will be just fine. So we are working with classes here, which is, concept we've gotten used to in many other languages. And as Jason was saying, that we are working with mutable objects. So that means they cannot be changed, but we can extract data from mutable objects to create other mutable objects, which again, that's not a concept that we're,
it's not foreign anymore.
Yeah, absolutely not.
Pretty common.
So we're going to kind of blaze through some of the methods that belong to the string class, because you guys should at this point be familiar with strings, what they are, how they work. We don't have to baby you on that. So let's walk through some of the highlighted methods on the string class. So the first one here we're going to look at is capitalize. So capitalize is a method that will uppercase the very first character and then force the rest to be lowercase. So if we look at this code example here, str equals hey buddy, where the H and the B are capitalized, but the output only has the upper capital for H, but not the B. Ooh.
Pretty much forcing you to be grammatically correct.
Yes, like in some instances where, you're dealing with a proper noun, like a state or, a name, and you're maybe pulling the data from a file where maybe it just has garbage in it. Well, you put capitalize and it will force the first character to be uppercase. So pretty simple. Come on.
We go into the next one? Or are we
I'm trying.
Okay.
I hit the button.
I don't know if you wanted me to say something else about capitalize, but
Yeah, we can spend another couple hours on that, I think, right? I mean,
I think there's more than enough material. So here we have the center method. And what does the center method do? It simply centers your string within a specified width. So let's take a look at the syntax here. So you can call your string variable, our hey buddy variable, call the center method, pass it a couple of things, the width that you're talking about, and then a character you want to fill the width with. So instead of filling it with blank space, you can fill it with a giant X. So our first example, we show that the hey buddy string is being centered to 80 characters, and then the bottom example, we're filling that blank space with X's.
I like how you said fill the width with the WIDTH and the WITH. Well done,
Yes.
sir. The count method returns the number of times a string appears in a string. So in this case, we have, hey buddy, how are you, buddy? And we wanted to check to see how many times the U exists. Well, in the console on the right, you can see that the U exists 2 times. But we can also do stuff if we pop down a couple times. You see the buddy exists 2 times because you see buddy and buddy. The next one down, we can pass another variable as the start position, so we could actually move to a specific position in the string. So even though buddy exists twice, if we move into the 10th index, it only exists once from that point on. And if we go from the 10th index to the end position of the 12th index, it doesn't exist at all. So it's just a way of us very quickly and easily getting the count to see how many times a string appears in another string. Very useful.
The eagle-eyed viewer may notice, and I'm not eagle-eyed enough, but buddy is longer than 2 characters. So if you start your count and only give it enough room to jump 2 characters ahead to look for a 5-character word, it's not going to return a positive result.
That is absolutely correct.
Even if 10 and 12 exist within the word buddy, it's still the whole word buddy has to be between those 2 points.
Yes, fantastic. Way to point out the inconsistencies in our material, asshole.
Hey, no problem. That's what I'm here for. And I'm also here to explain the encode method. It just converts a string, any string, to a byte object. By default, it will encode it to UTF-8, but instead, if you want to do base 64 or 10.10.321, 1-800-collect, any of those things that are real, you
or
can
ASCII, UTF-32, or whatever, like the things that exist in the real
things
world.
That are actually real, right?
Yeah.
You're probably better
Big
off.
5.
Yeah, the Pac-10 is probably not correct. That's a college conference.
The Pac-10.
So in our example here, even though UTF-8 is the default, we are still just printing out our string encoded in UTF-8, and there's the output there at the bottom.
Right. Now UTF-8 being a default, now even though the English characters kind of facilitate the UTF-8 character set, UTF-8 is also blind binary, because binary is 1 byte is 8 bits. So computers kind of have that 8-bit, that's how it computes math and that kind of stuff, at least for the most part. So UTF-8 is a good baseline because it's raw binary, uninterpreted binary. So that's why UTF-8 is a good default to have. And it's also the American languages, and that's why it makes it the greatest character set to have.
Yeah, because the American language, not the English language, is...
Yeah, it's the American language, not the Canadian language. It's the American language.
The metric system is for the devil.
No, you gotta say it. The metric system is the tool of the devil. My car gets 40
rods to a
hog's head, and that's the way I likes it. Oh, The Simpsons.
I think it is 40 rods to a hog's head, right?
Yeah, something like that.
Okay.
And that's the way I likes it.
Oh, I saw a great one going the other way. Some British author wrote a paragraph. He's like, the metric system, it's like everything rounds out correctly. So there's this much in this and this much in that, and everything kind of fits uniformly. If you try to do the same equation in the American system, the output is you. Because none of the values,
right, because
over evenly.
It's base 10, so it. Well, I mean, technically speaking, base 10 is what evens out for humans anyway. The next one we'll take a look at is starts with. And starts with is very simple. It just checks to see whether the string does or does not start with a specific string sequence. And we can also add starting position and end position, so we could just look at a small section of the string to see if it starts with it. You can see our simple example down here. We have the string, hey buddy. Just check to see, does it start with H? And the answer is yes. Does it end with EY? If I start from position 1, yes. And does it start with bud if I go into index 4 and take 7? And the answer is yes.
Yes.
So pretty simple.
Ends with pretty much the same idea, except for it's the end of the string, not the beginning of the string. We're dealing in opposites here. So it just checks to see if a string ends with a specified string and returns a Boolean result. So similar to our previous example, you can also pass the, end position or look at only part of a string instead of the whole string. So in our example of hey buddy, does it end with an exclamation point? Yes. Does it end with buddy exclamation point starting from the 4th character over? Yes. Does it end with bud starting at the 0 and ending at the 7th? Yes, it does.
I'll be damned.
I guess the important one here is really the last number you pass, the last number argument you pass, because if you notice with the second example, we're starting at the 4 position and going to the end. Or with the third example, we're starting at the very beginning and then only going to the 7th. That's something to think about too. I don't know if that was a good argument or not. But
let's look at expand tab. Now, for those of you guys that want to make some really cool console applications that display data like a directory listing or even something like a table, like a multiplication table or the result of a database query or something, expand tabs is a method that you may make use of. So it allows tab widths to be set to a custom value to better fit tabbed items. So we look down here on our example, we have 3 strings. We have hey tab buddy, tab python, tab rocks. We have hey there buddy, tab you, tab love, tab python. And then ribbit.net tab also, tab loves, tab python. Wow, that was really hard
tabs.
to say. Yeah.
Yeah.
So if we look
suddenly really want a soft drink.
or punch me in the face, either one. So if we take a look at the green, the top, we're just printing them out. So it's standard tabs. You see how it's all kind of blue-flied there, Jason? It's all like bleh.
Yeah.
It doesn't look all lined up and pretty.
No, it's not very uniform at all.
It's not, but I can say expand tabs to 20, which will represent the tab size, and then I can print them all out, and now they're in these nice, simple lines. So it makes it nice and pretty.
So the find method, it searches for a string and returns the index of the first hit. So just like our other methods that we've gone over, a lot of the other ones, you can just pass the string that you're searching for. You can pass the string in a start position from where you want to start from to search for that, or you can, define your start and end position in the string that you're looking for your seek string. So we have a string of hey buddy, comma, hey buddy. In the first example, we're looking for the first spot where buddy, comma shows up. And as you can see in the output on the right, it shows up at the 4th index. In our second example, we're looking for buddy, comma, but we're not starting until the 11th index. So what did it return? -1. That means it couldn't find it because we started looking for it too late. It was already gone. But in our third example, we're looking for just the word buddy starting at the 11th index. And because our string is hey buddy, comma, hey buddy, it found it at the 15th index.
There we go.
And finally, we're looking for the word hey, starting at the 11th index, ending at the 16th. That let us find the instance of hey right away at the 11th index. So it still kept track of, where you were in the string. So when you say I'm starting at the 11th index, it's not going to give you a 0. It's still going to return you that exact point in the entire string.
How about that? Isn't that something? Let's take a look at doing formatting. Now, we do use formatting a lot, and you're going to use this a lot in your programs, I'm sure. So in this example, we're just looking at format method and just giving a blanket arguments. So it replaces the value within a format string. So the syntax there, we have string.format and then however many arguments that you want. So in this particular case, if you look at our string equals, we have 0, 1, 2, 3. Now those of you guys that went through the C# course, that looks very familiar to you. That's a very common way of representing replacements inside of a format string. So the concept of the 0, 1, 2, 3, those of you guys that did not follow the C# course.
Which shame on you.
Shame on you, because we highly recommended it for those of you guys that didn't watch the introduction video.
In bold.
In bold and yes, and underlined and italicized and all uppercase. So the 0, 1 will represent the first argument or the 0th index in your argument. So hey will go where 0 goes, buddy will go where 1 goes, Wibbit.net will go where 2 goes, and awesome will go where 3 goes. Now, if you wanted to change them around, instead of going 0, 1, 2, 3 and go, 3, 2, 1, 0, it would be in reverse. It would be also Wibbit.net, buddy, hey, if you went 3, 2, 1, 0. But in this case, we're doing a very simple example, 0, 1, 2, 3, and it replaces that string with hey, buddy, Wibbit.net is awesome, with an exclamation point, of course.
The index method works the same as find, except for it throws an exception if the seek string is not found. So if you remember our find example where -1 was shown when it couldn't find the example it was looking for, in this instance, if you used index, it would throw an exception.
Yep, and we'll talk about exception handling in a later video. R index. Ooh, rindex. So it works the same as index, except for it works from the right side of the string instead of the left side of the string. So in a typical index of operation, you start, from left to right, at least in the English reading style, or we read our characters from left to right. We're not like those weirdos that go top down. That's just crazy. That's madness. So, but if the common Middle Eastern method of going right to left also. Well, then our index would be right up their alley.
This would be correct if you were searching an Arabic or Hebrew string or something like that. You'd be going right to left. So
right. So if you wanted to, some people will do a string reverse and do an index of, but this kind of takes away that. You can just do an R index. So this example here, we have hey buddy, comma, hey buddy, exclamation point. Now Jason did an example like this with the find. Very similar, except for he was doing left to right. We're going to do a right to left look. Now, if you look at this, we have buddy, comma. That comma is the giveaway here. It found it at index 4. Now, it's not going to index backwards. It's still going to give you the index going from left to right, but it's going to search the string in reverse. So even though we have a buddy at the end of the string, it's buddy exclamation point, buddy, comma, starts at the 4th index. And that's what the console shows there, 4. The next example, we just have the word buddy. Now, since we're going from right to left instead of left to right, we're going to find the buddy at the end of the string, which starts at the 15th index. The very last example, we're doing hey. We're starting at the 11th index, and we're searching up to the 16th index, and we find that at the 11th index in the string. So we're just searching backwards. That's the same thing as index, but we're searching backwards.
Searching backwards, but not counting backwards.
That is correct.
Isalnum. I'm sure. I'm sure everybody might have their own way of pronouncing that.
Is alnum?
Is alnum? Is isnum?
Is al azul? Yeah.
Izuzu is not correct.
No.
Isalnum returns true if all characters are alphanumeric. So in our example, we have 3 strings. We have 1, 2, 3 ABC, 1, 2, 3, 4, 5, 6, 1, 2, 3 tab 5, 6. And then we're gonna see with our isalnum number if these strings are alphanumeric or not. Of course, the first one being 1, 2, 3 ABC, that's all alphanumeric characters. 1, 2, 3, 4, 5, 6 is all numeric. But string 3 is not. Tab is not an alphanumeric character. Mm-hmm. So when you put in the tab hint in there, it's going to return false.
Right. So if you were doing an application and you wanted to do a very quick, simple input validation just to make sure that the input is just all alphanumeric characters, this is a very simple way to do that. Now, is lower is a way of just checking to see whether a string contains all lowercase characters. So the simple example here, string 1, true with a capital T. String 2, true, all lowercase. You see that the results are false for the capital and true for all lowercase.
Is numeric. It's kind of the same thing as what we just talked about, but it returns true if all the characters are numeric. So in our string 1 and string 1 is 1, 2, 3 ABC, string 2 is 1, 2, 3, 4, 5, 6, string 3 is 123.56. 123.56. Interesting. So the first one's clearly going to return false because it's got an ABC in there.
Right.
Second one's clearly going to return true because it's just 1, 2, 3, 4, 5, 6. String 3, yeah, that's going to return false because even though I guess you could say 123.56 is a number,
right,
it's not a number in what we're talking about.
Right. The period is not numeric.
Correct.
So even though that is a number, if you're judging that as a string and not a number, it does not pass the test.
A float is not numeric, so to speak.
Yes, as a string it's not because the period
is
not
as not as a numeric character.
Exactly. So like if you were just making a simple console program where you had a server-side script and something had to be an integer, I mean, boom, right? Simple. Is printable. Now we do know we've studied the ASCII chart in a couple of our different courses, including the Introduction to Computer Programming and a couple beyond. So printable characters are printable Unicode in the printable Unicode range. Now those would typically range, usually from 32 to 127 in that range. Those are like starting at the space character, numbers, alphanumeric characters, that kind of thing. So in this example, we have 1, 2, 3 ABC, which does contain all printable characters. Now we have 1, 2, 3, and then \013 13, which is a carriage return. So that would be 13 on your ASCII chart or on your UTF-8 chart. So the carriage return is not a printable character, so that will return false. And the 123.56 is all printable characters.
Is space returns true if all characters are white space. So in our first string example, we have a whole bunch of white space and then the word test and a bunch more white space. Second example, it's just one little space in there, one little lonely space. String 3, a whole bunch of white space. So when we're checking that string with the isSpace method, the first one's going to return false because the word test is in there. The second two examples, no matter how much white space there is, will return true, provided there is no other thing in there besides just space.
So the whole thing about calling it white space, right? Because typically you write on a text editor that has a white background. What if you're writing on like a Unix terminal and you have a black
space
and you have a black background?
Well, then it'd be black space.
It'd be black
dark
space.
It'd be dark matter.
It'd be dark matter. There you go.
Yeah. This is how scientists are discovering dark matter in the universe right now.
because they're writing on Unix terminals,
Yes,
just like the good old days.
Yeah, everything they talk about, Large Hadron Colliders and astrophysics, lies. They're just writing Python code on Unix terminals.
IsTitle returns true if a string resembles a title string. Now that's kind of a very convoluted, sort of confusing phrase, but let me clear that up for you. Let's take a look at these 3 string examples. It's very common when you have a title like a book title or a title of an article or something that the first character is capitalized for each one of the words. So in this case, we have this is title text, this is not title text, this is just plain garbage. It's basically the 3 strings that we're working with. The very first one, since the first letters of each one of the words is capitalized, Python will recognize that as a title and return you true. So this would be, again, a very good piece for input validation. If it's important that the input is a title text, meaning every first letter of each one of the words is capitalized.
Is Supper.
I think it's iSupper. I think this is the new Apple product that's about to come out.
It's iSupper. It's a virtual dinner.
Exactly.
So instead of taking Instagrams of your food before you eat it, it's providing you with stock photos of existing meals that you can then post to Facebook and say that you're eating it. And then that frees up all your time to actually go eat food, which is less desirable than the food that you're posting to Facebook because we all know you're just microwaving ramen.
That way your friends can think that you're all fancy and cool, but you're just a pig like the rest of us.
You're not eating that halibut. You're eating cup of noodles. Anyway, so this is actually IsUpper to kind of fit in line with the other, the naming convention here. So it returns true if all characters are uppercase. So in our first string example, it's all upper.
Yelling at
you. And
you.
the second string example is not all upper.
So Jason, if you were to take the string in the original, the introduction video where we highly recommended the other courses.
Highly recommended.
So what would the IsUpper method return on the highly recommended string?
It would return true. Just like it is true that we highly recommend that you go watch those videos.
Let's take a look at join. Now, we've used join in many other contexts. Very simple. In this case, we just have a simple list. Now, we're going to get into collections and stuff and talk about the differences between lists and tuples and dictionaries and all that stuff later on. But in this case, I don't want to bore you with the notation as far as the parentheses are concerned. We'll talk about that later. But in this case, we have a simple list. Hey, buddy are the 2 elements in that list. And we're just making a variable called sepchar. Now we can have sepchar. Now again, we're not joining the actual list. We're taking the string, the separator, which is kind of different than a lot of other languages. A lot of other languages, like let's take JavaScript for example. If you wanted to join if you have a JavaScript array and you want to join them on a comma, for example, to make a comma separated value, on the object instance of the array, there's a .join method. In this case, the object instance of the string, there's a .join method that takes in the array, and then it will output the value of each element in the list with that string in between each one. Pretty neat.
Pretty cool. Logistics. Logistically speak. Now, ljust returns a left justified string with specified right padding. So the name kind of makes sense there.
Yeah. Left justify. That makes sense.
Yeah. Ljust. The ljust method you can pass it a width, which is the amount of space that you're going to fill up, and then you can also pass it a fill character or a fill car as the
or like
slide
or Phil Collins, whatever.
That should have been what you put there, Phil Collins. Anyway, so string 1 is wibbit.net, string 2 is says, and string 3 is hey buddy. Now, we're not going to concatenate these. We're just going to show the difference between, give you a visual reference of these different examples. So our first print example, we are appending our quotes in there, but we're taking the first string of wibbit.net, we're L-justing it, we're giving it 15 character space there to fill. And as you can see on the right, the output of that is the quotes, and in those quotes, we have 15 spaces, and wibbit.net fills out the first couple of. Our second print example, we're doing the same thing, but we're passing it that second argument, that Phil Collins character, or that Phil car, and we're just putting a dot in there. So wibbit.net ... Now, the third print example is a really good way to kind of visually see what this is doing. So we're still appending our quotes, but we're taking that string 2 of says, which is only 4 characters long, and putting an L-just of 5. So as you can see in the output on the right, says in between quotes, there's 5 spaces there, but says fills up the first 4, leaving 1 empty blank space remaining. And the last example is just taking that hey buddy that we're so fond of here and putting it in a 20 space block, just like the first example.
I actually recently saw I forget what I was doing, but I came across something on a message board where somebody actually posted our Hey Buddy program as like here's how you, I think the conversation was about C and the relevance of C, and somebody posted the Hey Buddy program. Like, we've started the revolution. The Hey Buddy revolution is underway, and we're finally starting to get our hands in this. And we are going to change the world. Hello World will die out, and Hey Buddy will take its place. And you all have wibbit.net to thank for that. You're welcome, universe.
Somewhere people are getting together because instead of saying hello world, which is too general, their example program said, hey buddy. And they're like, oh, you're my buddy. I'm your buddy too. Let's start a conversation. And then they got married, and then they had kids. And that kid went on to be John Connor, leader of the resistance.
Well, I mean, hello world is so informal and so mechanical. When you hear the word hello world, you hear hello world. You know what I mean?
Would you like to play a game?
Yes, and like in war games, exactly. That's when I hear hello world, that's what I think about. I think about the old school. When I think about hey buddy, I think about, like in the buddy Christ, like the thumbs up and like, hey, what's up, pal? I'm a computer, but I'm your friend. I will do things for you.
I just hear Terrence and Phillip.
Well, that's where it came from, obviously, right? I mean, hey, buddy, but it's just, who cares? Yeah. It's still better than hello world. So R-just is the opposite of L-just. It's basically the exact same thing, but backwards. So we're going to write justify. So in this case, it's the exact same example that Jason just gave, except for it's backwards. Now we'll focus in on the string 2 because as Jason was going over says being 4 characters, and it was says and then a space. Well, in this case, it's going to be a space and then says.
Because we're starting from the other way.
So that's a nice visual of what's happening. So pretty easy.
Lower returns a lowercase string. It also will make you talk with this pleasing baritone.
You do not have a very deep voice.
I can try hard. I didn't run the lower. I had a syntax error. Now it's lower. So string equals wibbit.net. So we're going to print out that even though we have our camel case wibbit.net up at the top there, we're putting it all in the lower. So on the right, our output is wibbit.net, all lowercase, baby.
I'm sure that annoyed the hell out of all of our viewers, but when we get to the upper, I'm sure that's going to annoy them even more.
One or two, I'm sure we'll get 1 or 2 emails of somebody asking me out on a date. I think it was a pleasing baritone myself, and I'm here to pleasure myself. I don't care.
You're here to pleasure yourself.
I don't care what anybody else thinks.
So on the upper, I'm not gonna do hey, this is my upper. I'm not gonna do that. That was
my bit anyway. Yeah. Don't steal my bit.
I know. I'm sorry. That was my one and only attempt at trying to make a joke out of this. But upper, I mean, it's very simple, right? We're just gonna do a 2 uppercase. The strings, wibbit.net is all uppercase.
L strip. It removes the leading characters. White space gets stripped by default. So here
black
we have
space if you're on a Unix terminal. Just saying.
Dark matter. Yep. So you can pass in an argument of what characters you want to strip. So in our first example, we have string 1 is Wibbit, a bunch of spaces, and then Wibbit.net. The second example, string 2, has a bunch of backslashes.
Forward slashes.
Forward slashes. Whatever.
Don't give me that backslash bullshit. I hear it all the time.
Yeah, sorry about that. A bunch of forward slashes, and then Wibbit.net. And then we're printing out, as we said, white space gets stripped by default. So if you don't pass it anything, that first string example, it's just stripped off all that white space, even though we passed it no argument of, a character to remove. The second example, the second print line, we did tell it to remove those forward slashes by passing it that argument. So as you can see, the output on the right is identical for both the space-laden Wibbit.net and the / heavy Wibbit.net.
And you can visit us at www.wibbit.net/Jason is an idiot. Sorry.
You have to make that a page now.
https://. So I'm going to do strip R. I'm sorry, I didn't say stripper. I said R strip. Same thing, except for we're stripping from the right. I don't really have to spend too much time on this. We've actually already seen this in an example earlier on. So in this case, we're stripping from the spaces by default from the right. We're spacing the forward slashes from the right in the second example.
Strip removes leading and trailing characters, and again, white spaces by default.
So this is combining the previous two, L strip and R strip. It's like this. It's like doing both of them at the same time.
It's taking everything off of both ends.
Yeah.
So I'm not gonna spend too much time explaining our strings there, but as you can see, we have the forward slashes on the second string, both leading and trailing Wibbit.net, and it stripped it all off accordingly.
This is the proverbial burning the candle at both ends. This next method we're going to look at is partition, and it's not a method that either Jason and I really have used. I've never actually used it before, personally, because I've never really found a use for it. And maybe you guys can tell us, maybe there's like some scientific thing that you guys can tell us that this is used for, but it's similar to the split method, except for it returns back a 3-tuple list. Now, we'll talk about tuples and stuff later, but you can think of it as just a list. It returns a 3-tuple list where the first split, so in this case, we have this string will be partitioned, yes, it will. And you see that there's spaces in between each one of the words. So when we actually do a partition on the space, the very first delimiter, which is right after this, so this will be in its own value, and then the delimiter itself will be in the second, and then the remainder of the string will be in the third. So why this is useful, I don't know, but it's there.
I guess it's kind of like some sort of page break, sort of? I don't know.
I have no idea.
You might want to use it that way if you have like a specific character where you want to, separate your paragraph or something. I really don't know what you would use this for.
I don't know. But our partition's the same thing, except for instead of going from left to right, we're going from right to left. So in the last example, this was in its own value. Well, in this case, the very last word, which is will be in its own value.
Replaces all occurrences of a character with a new character unless the count is specified. So this is actually pretty useful as opposed to the partition one. I've used this a lot.
Yep.
The string here, we have, hey buddy, you're learning Python. Hey, are you having fun? Hey, yes, you are. And our first example is our control, so we're just printing out the string as it is. Our second example, we're replacing the word hey with what's up.
To borrow a phrase from the 90s, yeah.
To make the most annoying sentence ever read by humans. What's up, buddy? You're learning Python. What's up? Are you having fun? What's up? Yes, you are.
So basically, Wibbit the Frog got like completely blitz-faced drunk, and that's how he talks after he's had a few.
Yeah. Now our third example here, we've thrown in the count, so it'll only replace it the first 2 times.
Yep.
So we have a slightly less annoying sentence in the third.
But it's just 1/3 less annoying, which is not enough to make it usable or palatable. Do you want to say that sentence? I'd love to hear you say it.
I'm already really annoyed with myself for saying the last sentence.
What's up, buddy? You're learning Python. What's up? Are you having fun? Hey, yes, you are. You got serious at the end there. See?
Yeah, because you got rid of the was up. So,
So split is the practical version of partition. Now, we've used split before. All that we're doing is we're taking a separator character and we're blowing up a string into a list. Now, again, I keep saying we'll talk about this stuff later, but those brackets represent a list, whereas the tuples are represented by the parentheses. So in this case, this string will be split. Yes, it will. When we split on the space, you can see that every single time that there is a space, there is an element in that list. Now, we can also pass it a max split, which is actually kind of cool. I've never used this before, but I'm sure that at some point along the line, there may be a good reason for this. So when I just say a max split of 2, we're only going to have the first 2 occurrences of that separator exist on their own. So in this case, this string. And then from that point on, the rest of the string will exist in this case, in the third element of the list.
rsplit does the same thing, but it just goes from the right.
No, it doesn't. No, you're wrong. rsplit is how a pirate would say it. Come on, give me a little bit on that one. That was sort of funny. rsplit. Okay, f you. I already said it. F you. Okay.
Okay. It splits a string into a list, same as the split, except for when max split, it works in reverse. So the syntax appears to be pretty much the same as split. It's just working in reverse. So that becomes particularly obvious when we're talking about our third print example here, and we're only splitting it in 2 places, well 3 I guess, but we're only splitting it twice. So instead of it being this string will be split yes, it's this string will be split yes.
Yes. Split lines. Now this is a really simple way to do a new line split. So if you're reading in a file and you want to, instead of saying I want to split on \r, or I want to split on \n, or I want to split on \r\n, you can have this method figure out how to parse that string for you, which is pretty useful, and I've used this many times. So it splits a string contents based on the lines, and it puts it into a list. And there is a parameter that you can pass in, Boolean, true or false. This is optional. If you do not pass anything in, false is assumed, it will not return the new lines, but if you send true, it will return the new lines. Now, for the most part, there's no need to have the new lines unless you really want to combine the file in its native format later on. But if you're trying to parse this out, then typically would not keep the new lines. But it's pretty simple, just splitting it based on the line characters.
Swap case converts lowercase to uppercase and vice versa. If you don't understand what that means, then I don't know. I can't help you.
Nobody can help you.
Yeah, just what was big is now small. What was small is now big, and that's it.
And that's what she said. Now, title, before we did a is title, we checked to see if something was a title. In this example, we're not checking to see if something is a title. We're converting it to a title, which simply just capitalizes the first word of each word in the sentence. So when I have this is a title string, is all lowercase, you see TIA, TS are all capitalized. This is a title string.
zfill, 0 fills the string to a specified length. So in our example here, we have a string of 1, 2, 3, 4, 5, and we're going to fill up, we wanted this to fill up 10 spaces. So when we pass that string through zfill, it leads everything with 5 zeros so that there's 10 characters there. There's 10 spaces. There's 10 things.
Yep.
Pretty much all it does.
Yep. Yeah, it's pretty common in things like account numbers. Sometimes software will want the account to be of a specific size. This is a simple way to do that. The len function is something that you'll use a lot. Now this is a function. This is not a method on the class. This is a function that belongs to the Python environment. So you'll use len fairly frequently, I believe, at least I do. It just returns the length of a string in the same way that a .length method in C# or whatever returns the length of a string. In this case, we just have whippet.net. Len string is 9.
Escape characters. So let's talk about some escape characters. So sometimes you're going to want to, throw in a quotation mark or, some correct punctuation into a string, and that punctuation would otherwise, break your string or end your line or end your string. So you need to throw in an escape character to prevent that from happening. So what is the escape character here? It is the /.
No, that's the backslash.
No,
I know you are.
Okay, so the backslash will
as in whippet.net / Jason is an idiot. Is that
exactly?
Okay.
So the backslash before your punctuation mark will prevent it from getting mad at you.
Yep.
So that's what I'm talking about. You want to have the apostrophe before the S, before the M, after the N,
yep.
But you're using the apostrophe to encapsulate the string. So, you want to put that backslash in before the apostrophe.
Mm-hmm.
Now, throwing the same thing in when you're using double quotes in the string 2 example will also prevent it from getting mad at you. But if you use the double quotes without using the backslash as the escape character, well, since you weren't using the single quote in the first place to encapsulate the string, it doesn't matter. It's not going to hurt you to not use the escape character.
Yeah, so just like in every other language, we use the backslash to escape. Like if you wanted to have a backslash inside of your string, you have to have backslash backslash. If you wanted to have a backslash m, backslash backslash n, it's very similar to what we've seen before. Now here's sort of a continuation of what I was just saying, that if we have C colon backslash backslash temp backslash backslash file dot dat, that's going to translate to C colon backslash because we have to escape the backslash. But this is not something that is foreign to us. We know this pretty easy. Raw strings! What's all this about?
Well, strings that do not require a backslash to escape sequences.
What? You can do that? Oh my god.
This was originally designed to store regular expressions.
Mm-hmm.
So if you declare the string as a raw string with that little R guy there, you don't have to throw in the backslash backslash as Kevin was going on about to write out your C temp file.dat.
Ooh, that's awesome. Now, escaping new lines. Now, this is kind of neat, and several other scripting languages use this concept. But if I want to have a string go across multiple lines, and for readability purposes, let's just say that I am coding on a Unix terminal that only has 80 characters left to write, and I was writing a welcome message, and I didn't want it to, store it in several different strings and concatenate the strings. All that I have to do is put a backslash and then go to the next line. And the Python interpreter will escape that backslash, and it won't even consider it. So if you look at the output there, I will continue this sentence, ... on the next line. It still interprets that as one single line of text. Pretty neat, pretty awesome.
A string on multiple lines. So sometimes you want to literally put your sentence on different lines. So if you encapsulate it in triple quotes and write your lines out, then Python will interpret that as literally being on different lines as opposed to using the escape character to keep it all in one line there. That doesn't look very pretty, I guess, from a grammatical standpoint, but
I think it looks lovely, to be honest. Now we can do crazy stuff like do multiplication of strings. What? That's crazy. So in this case, if I wanted to have 5 spaces before and 5 spaces after my string, all that I have to do is space times 5. That's pretty cool, right? I'm sure you can think of many ways that you could use this. It's pretty awesome.
Well, you could have just used the center method.
You could, but let's just say that you just wanted to do this just because you're awesome.
Wanted to do a little bit of extra work.
Yeah, because you're just badass, and this is how you do things.
String indexing. So here we have a string of hey buddy, but we want to find what character is at. If you want to find, where, what character exists at a certain point in your string, you do it this way. The 0 position is an H, the 4 is a B in this string of hey buddy. So any string you want in there, if you want to just figure out what letter is where or what number is where, that's how you do it.
Yep. Yeah. So it's not stupid like Java where you have to do char at. You could actually index the string like you can in C# or C strings in C. It's pretty awesome. So ranging. Now we're going to talk a little bit more about ranging when we get to lists and when we go through like for loops and stuff like that. A range is, those of you guys that did the Objective-C course, there's the NSRange function that defines a range of numbers, iterating or for storing data. This is sort of implementing something like that. So before in the last example, we were showing a simple index. I want to look at the character at position index 0 and an index 4. Now I want to say a range. Now a range is specified by a starting number, a colon, and an ending number. So in the first example, we have 0:3, which is 0 through 3. So if I want to get the character position 0, 1, 2, and 3, then I would do that. So there's hey. Then we have :3. Now if I don't specify a colon, the assumption is 0. So I can just say,
or the beginning, yeah.
Yes, if I don't specify anything at the beginning there, that will be interpreted as the same as above 0 through 3. The next one, it will be 4 through 10. And then the next one is going to be 4 through, and if I don't specify a colon at the end, the assumption is the end of the string, so all the way to the end. Yeah.
I detect a pattern there.
Yes, I do as well. Yes. So when you're iterating through for loops and stuff, you use ranges, and we'll talk about that later, but pretty simple, pretty cool. Now, in here, we can actually do what? We can pass negative numbers? Now, that's crazy, right?
That's insane.
So when I pass a negative number, it's just going to go to the last character of the string. So in this case, it will bring back the exclamation point. But I can do -6 to the end of the string and get the last 6 characters, which is BUDDY exclamation point. Buddy.
Like when you were a kid, did you ever think that if you look at a map and the teacher asked you, oh, if you went all the way to the end of Antarctica, where would you come out on the other end? And you're like, oh yeah, up here at Greenland. Did you ever do that? And that was totally wrong, but you were a stupid kid and everybody made fun of you.
That never happened. That's probably just you because you're Whippet.net /Jason is an idiot. You can find all the information there. It's basically like, a chronicle of Jason's confusion throughout his entire life. Okay, I'm sorry. Finish your story. I wasn't trying to beat up on you, but
I mean, it really that was pretty much the whole story.
Okay.
I mean, but by the way, paste is delicious.
Like glue?
Yeah.
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 And I'm sure that. Yes. What's going on here, Jason? Why is this code exploding on us?
String cast. So we have a variable of num equals 100,
which is number, right? There's no quotes around it, so it's a number.
That is a true number.
Yeah.
So we're trying to print a string and then concatenating the variable num, which is a number, into that string. And man, it just didn't like that at all.
It's pissed off.
And it threw out a bunch of big words and
yeah. So this is one thing about Python that is, kind of a downside of the language, and that makes it inconsistent with a lot of other languages, is that for most scripting languages, like I think
PHP will be able to concatenate. Yeah,
PHP. I think JavaScript is also
JavaScript would be fine
one
with that too,
one of the de facto languages as far as scripting and dynamic typing is concerned, because JavaScript just doesn't give a it doesn't give a It's just whatever, I do whatever, that's fine. And that's what scripting languages are supposed to be. And Python does have a distinction here. The plus operator is not going to function between two disparate types. So we have to use a function, Jason, to fix this problem. And how do we do that?
Well, we're going to turn that number variable into a string by using the str function. The stir function. So it'll just return a string representation of any object.
Oh, nice.
So we're just simply printing out, it's pretty much the same print command we did on the previous example, but we're encapsulating we're passing the num variable through the string, the str function, to turn it into a string.
Now, why Python doesn't assume that? Like, Python should say, oh, you're trying to concatenate a string with an object that's not a string. Let me go ahead and, make a string representation of that for you. That's what it should do, but it doesn't, because it's evil. It's mean. So bytes, we gotten all this discussion about strings, and bytes, we haven't talked about them yet. Bytes is an object that can store a string of bytes, and it's very similar to a string because of their nature, because a string is a collection of individual characters, and a byte is a collection of individual bytes, numeric values between 0 and 255. And bytes contains all of the same methods that string does. What? That's crazy. Except it does not have encode, it does not have format, or is identifier, which we haven't even talked about. But the reason why it doesn't have encode is because encode is a one-way direction of taking a string and making it bytes. So in the opposite, the bytes object has a decode, which converts bytes to a string. And you also can't format bytes because bytes are not really designed to be represented as visual data. Bytes are supposed to be a blob of information that needs to be interpreted into data. So that's why it doesn't have the format method. So when you declare bytes in Python, it's very simple. And we can do it just like it's a string. So we have this little B object, or this B character. Jason was talking about the raw strings, and you had a little lowercase r. Well, if you want to declare it bytes, we can just say B and then have a string of bytes. So in the very first example, we're using hex notation. So \x meaning hex, and then the 41 represents the hex value. So we just have 41, 42, and 43, which if you go look at your ASCII or UTF-8 chart, you'll see that that's the characters uppercase A, B, and C. We can also have the literal character A, B, and C, and that will be translated as well. We can also use the 3-character notation, 101, 102, 103. If you go check your ASCII and UTF chart, you'll see that those map to A, B, and C. Or we can have a list. Check this out. So we have a method called bytes, and bytes is pretty cool. That function there will actually convert a array or a list of bytes into a byte object, which is pretty cool. And that's useful. You'll probably use that from time to time. Working with bytes. What's all this about? This is crazy.
Well, looks like it has a whole bunch of crazy gobbledygook that you talked about on the previous page. So we're using that bytes function. So we're going to declare a variable of B is the byte object. We're just passing it a bunch of bytes there, and then we're going to print it out. So what's that going to show? That's going to show an encoded value of hey buddy. And just like strings, you can use other methods to do things to the byte object that you've already created. So we're using the replace method to replace spaces with there.
Ooh.
There comma space.
Yeah, you like that? You like that?
Yeah. So we're getting fancy.
Yep.
And we can double up using math operators. So we can add B plus B.
What?
So we have our byte object plus our byte object. So we got hey there buddy, because we've already put in the there comma. And then we're going to use a replace function or the replace method again to undo the damage we did with the there comma.
Yes. So we're just I'm sorry. I'll shut up.
We're backtrack. We're just undoing the damage that we had done, but we're not exactly undoing the damage. We're just kind of removing the additional stuff,
the additional gobbledygook, as you would say.
And then we're going to decode this byte stream into UTF-8. So if you notice on the output, it's the showing you the first three prints with the little b there.
B.
And then the last one doesn't have that little b.
No, it doesn't.
That little b right there.
Nope.
It's our little secret.
Because it's not a bytes object. It's a stir object.
I think we should make that iSupper app.
We should.
And make big dollars.
We'd make billions of dollars.
Yeah. iSupper on the App Store. Probably never, but watch out for it.
Hey, web editors, welcome back to Programming in Python. Kevin Solo on this lesson, and what we're going to do is talk about basic math and operations. So, we've talked about this topic in every other language that we've talked about, so this is not going to be new to you. And most of you guys can probably skip this one if you really want to, but you should probably just go through it just because. We're just going to talk about some simple functions that we can use in the language, the different operators, and who knows, there may be a surprise or two for some of you guys. Like this. Did you know that the equal symbol means that you're going to assign something? I know, that's crazy, right? I would have never guessed that. Okay, I'm going to stop being a smartass now. So the equal operator works the same as in every other language that you've used. So if you wanted to set x equal to 10, you can do that just like this. Now, here's something you may not have known. Let's say you had two variables, x and y, and you wanted to set x to 10 and you wanted to set y to 20. If you wanted to do that on a single line, you can actually do this. X comma y equals, and then the value of x, which is 10, comma the value of y, which is 20. Just as you would have expected, the plus operator is the addition operator. So in this case, if x is 10, y is 6, z equals x plus y, and the print statement below using the format method on the string object, so we'll have the replacement character, the replacement of 0 plus 1 equals 2, and then x comma y comma z. 10 minus that is a mistake. Okay, 10 minus 6 is not 16, but we're going to fix that right now. See, somebody else must have done this slide, not me. So 10 plus 6 equals 16. Minus operator, same thing, right? Except for we're subtracting. So in this case, 10 minus 6 is going to equal 4. Multiplication, simply put, x times y equals 60. So 10 times 6 is 60. Division operator. Now here's something that's interesting. So, I said that there may be a couple surprises for you guys. Some of you guys might be bored to tears, but I don't care. I'm still going to go through with this anyways, like it or not. So when we set z equal to x divided by y, check this out. We're actually getting a remainder. So we're actually able to see 1.6 blah, 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 right? Now, you know that in C, when you have integer division and you divide an integer over an integer, you do integer division, which means that there is no remainder. So only the whole number is represented in the answer. Python is not like that, at least not in this particular case. X is a number, y is a number divided by a number is a number. In this case, it is a real number, 1.6 blah, 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 blah. But if you want Python to behave more like C doing integer division, so truncated division is done by 2 slashes. So in this case, 10 //6 equals 1, so we wouldn't get 1.6 blah, 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 because the double slash makes it a truncated division. Kind of cool. You may not have known that. Now, what is this doing? Holy crap. If you wanted to do a power, so if you wanted to do 10 to the 6th power, you can just do times. Modulus is the same, the percent symbol. And the compound operations are pretty much what you would expect. Plus equals, minus equals, times equals, divided by equals, times equals, percent equals, so pretty much the same as what we've been accustomed to in other programming languages. So do you notice anything kind of weird? Python does not support increment or decrement operations, plus or minus. Incrementing is done by using compound operators. X plus equal 1 will increment x by 1, and y minus equal 2 will decrement y by 2. Bitwise operations in Python, the single bar, which is shares the same key as the backslash, or, so 10 or 6 equals 14, and, so a logical and 10 and 6 equals 2, a logical exclusive or, so 10 exclusive or 6 is 12, and negate, so tilde 10 is negative 10. For those of you guys that don't exactly remember the bitwise operations, we do talk about this in Introduction to Computer Programming. Bit shifting, same thing as you were accustomed to in C. I gotta stop saying that because that doesn't really give Python a lot of credit, does it? So the bit shift would be less than, so 10 bit shift left 6 bytes will be 640. And then right bit shift 10, bit shift 1 will be 5. Comparison operators, double equal will be equal to, so 10 equal 6 will be false. Not equal, so 10 not equal to 1 is true. Greater than, 10 greater than 1 is true. Less than, 10 is less than 1 is false. Greater than or equal to, so in this case, 10 greater than or equal to 10 is true, or less than or equal to, 10 less than or equal to 10 is also true. Boolean operators, and, or not. So in Python, we're using the full word and, the full word or, and the full word not representing these operations. Let's take a look at some simple math functions that belong to the Python programming language. So ABS is for absolute value, so it will calculate the absolute value of a number. So the syntax of this will just be simply ABS paren the number paren, and in the code below you'll see n is equal to negative 50, ABS of n equals absolute value of n, so the absolute value of negative 50 is 50. The bin function will convert a number to binary. This is pretty awesome. So n equals 33, so if we want to print bin, and then we'll pass n as a parameter. Now, you see, one of the things to note in Python is that 0b prefix says that this is a binary number, so 33 would be 100001. Python also has a hex function, which is pretty awesome if you need to convert a number to hexadecimal. In this case, n equals 128, hex value equals hex of n, so print 128 in hex is 0x80. So the 0x prefix denotes that this is a hexadecimal number. The int function is used to convert a string to an integer. So if you have two strings, we have string 1 equals 128, string 2 equals 512, and we want to do value 1 equals string 1 plus string 2, and value 2 equals integer string 1 plus integer string 2, you'll see that the val 1 actually represents the concatenation of those two strings. So it's 128512, whereas val 2 will represent the addition of those two integers into another number of 640. Now this function is used quite a bit, like when you're pulling in data from the command line, or user input, or reading data from a file, because a lot of times that stuff comes in as strings and it just has to be converted to numbers in order to do math on it or comparisons on it. So long, very much like the int function, does pretty much the same thing, except for storing an integer, it will store a long integer, which is a 64-bit number, so you could store a larger value as long as you can with an integer. So in this case, the outcome of this code is exactly the same, except for we're working with a 64-bit number instead of a 32-bit number. Float, okay, it's kind of getting repetitious here, right? So it converts a string to a floating point. So if you needed to work with a number as a real number as opposed to working with a number that's an integer, this is what you would do. In this case, we have string 3.14, string 299.122, concatenating them together as strings, and then adding them together with a plus operator to get 102.2522. The max function is used to return the largest number in a list. So in this case, if we had a list, so we have bracket 1, 2, 3, 4, close bracket, that's a list. Now we're going to talk more about lists and that kind of stuff in just a little bit. If we wanted to get the largest value in that list, we can just use the max function, and that's going to return back 4. Now it's going to return it back, since those are numbers, it's going to return it as a number, so we're going to use in this case, there's other ways we can do this with print formatting, but if we wanted to print out the value of that string to the print function, we could use the str function to convert that number into a string, so print str max value of that list is 4. Min does the exact same operation, except for it works the inverse, so we're working with the smallest number in the list. So in this case, the smallest number is 1. OCT, or oct, will convert an integer to an octal string. So you guys can check out your ASCII charts, because most ASCII charts are going to have the integer value, the octal value, the hex value, and the character. So in this case, we have n equals 1, 2, 3, and we want to convert that to an octal string. So OCT of n is, now check this out, we have the 0 0 prefix. You know how in hexadecimal we had the 0x prefix? Well, this is a 0 prefix. 173 is that value. So POW, power function. So we have POW base exponent, and we could also do POW base exponent mod. Now, some of you might be asking, like, why is there a mod there? Well, because like sometimes in cryptography, when you're working with doing the power 27,000 to the power of 10,206 or whatever, sometimes in cryptography, numbers can get extremely large very fast. By having that mod of function, that mod ability available, it can keep numbers within a reasonable size so that you don't blow up your computer's memory. This is used very simple, just POW and then the base exponent. So in this case, we have b equals 2, so base is 2, exponent is 10, so 2 to the power of 10 is 1024. The range function, it returns a data type specifying a range that can be iterated. What the hell does that mean? It's used often in lists and mathematical operation. All right, so basically what this is a data type that just contains a listing of numbers that you could iterate through. Now, why is this important? Well, when we start talking about loops and stuff, you actually use ranges and loops. Like if you wanted to do for I to range 10 would be, 0 to 9 or 0 to 10. We talk about that in a little bit when we start talking about control structures. If you wanted to have a range from 0 to 10, it's simple, range 10, not bad. But if you want to specify a start value, I can say 0, 10, and I could just easily say 1 to 10 or 5 to 10 or 8 to 10, and that would create a range of that size. Now you can also step through a range, which means that you can go through at an increment of, it doesn't have to be 1, you can go in increments of 2, 3, whatever. So in that case, you would just do start and step. So in the very last example here, I have 2, which is our starting point, 10, which is our ending point, and 2, which is our step value. So we're going to go up 2, 4, 6, 8 until we reach 10. The round function will round the number to a specified precision. The default is that it rounds to the nearest whole number. So the two usages of the round function will be round n, which will just round to the nearest whole number, or round n to the number of digits, we'll round it to a specific number of digits. So in this case, if I have n equals 3.9849, so if I round it without specifying the digits, that's going to round up to 4. But if I want that to be rounded to 3 digits, you'll see that it's 3.985, right? Because that 3.98, that 4 is going to be rounded to a 5 because the following number is a 9. The sum function will sum a list of numbers, and a base count value can be set so that you can set a starting point for the count. So in this case, I have a list of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 10, which the sum of that is 46. But if I want to start at the number 4, I can just say the list that I want to add, comma 4. So that means that my starting number is 4 instead of 0, which will result in 50. So that's a simple run around of basic operations and basic mathematical functions in the Python language. See you guys in the next one.
Python control structures. My intro style is blunt as possible.
I'm on the edge of my seat wondering what this video is about.
Python control structures.
Sweet. So let's talk about control structures, Jason. So what do we got here? Logical expressions. What's the deal?
Well, Python's logical expressions are different than what we've seen before. Instead of punctuation like bang, and, or, I don't know how to pronounce what to call those lines.
Bar.
Yeah. Python uses and, or, and not.
What? It uses words? That's stupid.
Yeah. Well, it's a little more readable, and that's Python's goal, right? Is to be a little more readable, I guess. So in C, you would say, bang for not when, X equals Y, or Y does not equal Z, and Z is less than X. So in the Python, it would say where not X equals Y, or Y does not equal Z, and Z is less than X. Now, wait a minute. Now, we already said that bang is used, you could use the word not in Python, but if you notice in the not equals, it's still bang equals.
Mm-hmm.
So keep that in mind, I guess.
You guess?
Yeah, I guess. Just, maybe. So Python Boolean expressions. So here we just got a bunch of different examples of true or false statements. So in the first one, we're asking, is 10 less than 10? It's not. Is 10 not less than 10? I guess is a way to say that. So that's true because 10 is not less than 10. Is 10 less than or equal to 10? That is also true because it is equal to it. Is 10 greater than 110? No, and so on and so on and so on. So down at the bottom here, we have a few different ones where, is 10 not equal to 99? We have the bang equal. if 99 is equal to 99 and 100 is equal to 100, then that's true. And then we have the or statement at the end there, where if 6 is equal to 99 or 100 is equal to 100, it's true, which of course that would be true because 100 is equal to 100.
Right. So one of the big things to get out of this, not is different than not equals. So when we have the not, like for example, the second example there where we have 10 is less than 10, and then we negate that with a not, that's not the same as saying 10 does not equal 10. Right. So that's why the not equal still is the traditional operator, but negating a expression, we would use not. Or comparing two expressions, we use the word and instead of ampersand, and the word or instead of the two bars. So let's talk about some control structures. Now that kind of sets the stage because we're going to be using Boolean expressions to control the flow of our program, because that's how software engineering works. We have logic and we simplify things into true and false statements, and we go from there. That's how flow is dictated in a software program. Pay attention to how many times you do comparisons in your programs. Like if you actually write, if you're like a website, prop up a website, count how many times you do if statements. It's a whole lot, because your entire logical flow is based on Boolean expressions. Python supports all the usual suspects when it comes to programming control flow: if statements, for statement, while statement, and associated code blocks, as we know now, are associated by indentation and not curly braces. So in this mock-up down here of a syntax, we have the control structure and then a colon to indicate the control structure begins at this point, and then code lines are indented into the same line, so all of those code lines will belong to the code structure above it.
The if statement initiates the if the decision, and an associated code is executed if the Boolean condition is true.
Nice.
Else if a preceding condition is false, then it evaluates this next if, so to speak. So it's saying if this is not true, then something else might be true. The associated code is executed if the Boolean conditions are true there. And else is the alternative code executed if everything else, if all else fails, this is what we'll execute.
Right. Now also look at the else if. It's not ELSE if, it's elif, because yeah, which I find kind of lame because they add extra characters by having like not, or, and. They add extra characters there, so I guess they felt guilty about it, so they try to shave off characters in places where it doesn't make any sense.
Yeah.
Whatever.
Well, it's hard. It's almost harder to, especially if you're coming from another language like JavaScript, where you're writing else if out that way, or you're writing if over and over again, or like PHP where you're saying else if.
Right.
It'll be very easy for you to forget that you don't need the SE.
Right. Now, I don't mind languages like TCL where else if is one word. That doesn't bother me, but when you condense it to elif, I just think that's cheap, personally. That's just my opinion. Whatever. So
here's just one man's thoughts.
Well, yes. So here's some examples of some if statements, Jason. Let's take a look at some of these.
So here we have an if statement to start it all off. So if condition, and then we have a bit of code that we would write to, execute if that condition is true.
That's indented in, right? Yeah.
Right. And then we have another if statement indented after that. So if this condition is true, then in that code, there's another if condition. And if that condition is satisfied, it goes to that code. Otherwise, it hits that else statement and executes some code.
Right.
And then again, we have another if statement in this block of code that's, doing the same thing. If a condition is true, execute. Elif, another bunch of code, or another condition is true, execute some code. And then our final block here on the right shows, if a condition is true, execute your code. If a condition is true, execute your code, or else is your code. So that's your full example of if this is true, do something. Otherwise, if that's not true and this is true, do something else. Right. Otherwise, if all else fails, do this last bit.
And us as software developers know that the elif statement can repeat itself as many times as necessary to satisfy whatever conditions that you need. So here's a program where we're looking for the magic number. This is the magic number example. Every software programming class shows an example of this in some form. So we're going to print out to the user, enter a number, and we're ending it with the quote. That way, when the person puts the input, it will concatenate itself right next to our enter a number text. So in this case, n will equal the integer equivalent of what the person types in. So we're using the int function to cast a string into an integer. So the user will type, in this case, 4. So you entered 4. Awesome. Now, since 4 is stored as a number, and we know that because we have the int function there, we can't do you entered and then plus that, right? We can't concatenate that with a plus, but having a comma there works perfectly fine because the print statement allows us to send as many objects as we want in a list. So you entered 4. If n is less than the magic number, 4 is too low, hello, we're done. The second time that we try this, the user is going to put in 10. We'll check this statement. If it is greater than the magic number, the magic number is 6, as you can see at the top there, it's too high. So now the user does the 6, so he knows it's got to be between 4 and 10. Let's try 6 now. And then, boom, you hit the magic number. You're awesome. Here is your $20 billion in loose change.
So here's a little more with our if statement. So
Yeah. So the overall goal here, Jason, is we're going to take in a test score and convert that to a grade letter.
Yep, we're given an A, B, C, D, or F.
Yep, and notice that this also has nested if statements. So we have, not only do we have multiple elif, but we have if statements inside of the elifs. So for example, if you got a 90%, you get an A, but if you got a 97%, it would be an A+. All right, so let's check this out here. What is this all about? So
if the test score is greater than 100, then we're printing out that you're a cheater and that you are a liar and that you clearly did not get the score you said because you cannot get more than 100.
Right, and we're also calling the quit function passing the number 1. So those of you guys that remember that, doing exit codes in other languages, the quit 1 is we're telling the operating system that a exceptional circumstance happened, because 0 is success, 1 is anything above 0 is considered a bad execution. So this way, if the user was checking for the result of this program, they would get a 1 and they would know that something bad happened. So here we go, Jason. Now we just talked about this, but let's talk about it again.
So we've already established what happens if the score is greater than 100, but what if it's greater than 90 or equal to 90?
All right.
Well, that puts you in the A category.
It does.
So that's great. Congratulations. Yeah. You've got an A. But we also want to have an extra if statement inside that elif that says if it's greater than 95, which it wouldn't have got to 95 if it wasn't greater than 90 in the first place, then it'll append the plus to your grade. Ooh. So we've set grade to A, and we're adding the plus if you're greater than 95. And the other elif statements, the B range, the C range, the D range, all follows the similar logic, just with lower values. So all the way down to F. So if you put in, you got a 15, well, then you failed and you should start over. So here we have an example where the user is a cheater and they've put in their test score of 101.
Cheater.
And we've told them that you're full of it and we don't buy it. But this time they put in, okay, well, then I got 100. That score is greater than 90. So we've satisfied the first condition of that elif.
Yep.
And it's greater than 95. So we've satisfied the if statement there and added that plus to it.
That is awesome.
Congratulations. The next user put in 90, then 74. So we see that we're going down the line and just satisfying those different conditions as they come. So here is a code example that does the exact same thing, more or less, that our previous example did. Just instead of adding the extra if conditions inside of our elif statements, we've just appended the and condition to our code. So we're just saying if the score is greater than 95 and it's less than or equal to 100, make that grade an A plus. Otherwise, it's a 90. So we've just made it, instead of a bunch of nested if statements inside of the elifs, it's just a long list of elif statements with extra conditions.
Right. And one of the reasons why we did this example was because if you some people rave about how easy Python is to read, which I humbly and respectfully disagree with. I find Python very difficult to read. So if you look at this example, the more nested code that you have, the uglier the code gets. My opinion. Again, you may think differently. You may know someone that thinks different than me. So when I write Python code, I try to make my conditions so where I have as little nested code as possible to make it easier to visually follow. So you can see ugly, disgusting, yuck, and it's pretty.
Just a little more elegant, a little easier to read.
Yep. The while loop. Let's look at this good old while loop here. So the syntax example, while condition code. Again, not something that we're unfamiliar with. Let's take a look at this code example on the bottom right. We just have a simple x equals 0, while x is less than 5, print x equals blah, and then increment x. You see that just like we had it in concatenating the string in the grade example, the plus equal operator still functions in Python just like it does in every other language that we've used. That's just it's the equivalent of x equals x plus 1. We're just going to add 1 to the number until we get to 5, and then we exit the loop. Pretty simple, very basic. Once again, just pay close attention to the indentation. The print statement and the x plus equals 1 belongs to the while statement. The x equals 0 and the print done at the bottom do not belong to the while statement at all.
So loops also support common control statements such as break to abort a loop or continue to move on to the next iteration of a loop.
Right, so the break is the Planned Parenthood of the loop, if you will. I'll probably cut that out.
that was, oh man.
Let's walk through this code example here. So let's start here with x equals 0. So let's evaluate this condition, while true, which means that this is an infinite loop. This might not be safe to do unless we know for a fact that at some point we're going to hit a condition. Now, in this case, we're incrementing numbers, so no matter how low x starts out to be, we will eventually always get to an exit condition. This may not be the greatest code, but it shows how we can use continue and break to navigate through a while loop. Print x equals 0. In the cloud there, you can see that now x equals 1. If x is less than or equal to 3, which it is, we'll continue to the next iteration of the loop. Print increment, check the condition. Is it less than 3? Less than or equal to 3? Yes. Continue. Print, increment, check the condition, which is again true. Now we're going to get to a point where we print 3, increment to 4. Now this condition is no longer true, and we can use the break statement to exit this loop. Now again, since this is an infinite loop, because while true is the condition, and true is always going to be true, so if we don't abort this loop, it will loop forever and ever and ever until the program crashes or breaks or the computer explodes. So that's using continue and break to navigate through the loop. Done.
The for loop. It's used to traverse a list or a set range, and we will discuss lists later. So just keep that in mind and moving on.
Yeah.
A range is defined using the range function. So we have here in the example, the range function, we're starting at 0 and we're going to end 5 places later. So including 0, 0, 1, 2, 3, 4, that's 5 places. So that's given us our range. If we've defined the third argument, we're going to increment by 2s. So here we have starting at 0, 10 places, increment by 2s. So that starts with 0, 2, 4, 6, 8. And of course, since we're going 10 places, it would have ended at 9. And so it doesn't go any further than that.
I couldn't have said it better myself, and I didn't.
So here we have an example of a for loop. On the left, we have our Python, and on the right, we have C. So as you can see with the Python, we're just saying for I in the range of 0 to 5 places, we're going to print out I. And as long as I is within the range of 0, 1, 2, 3, and 4, that's 5 places including 0, it'll print out I. The same code here on the right in C, we are, setting I as 0 in the for condition, and then we're saying, while it's less than 5, increment I, and then print out I. So Python's a little bit more wordy, I guess, a little less semicolon dependent, but that's some people think that's more readable. That is a for loop in Python compared to C.
So if you wanted to do an increment by 2 or a step 2, depending on which software development world you come from, in this case, we have the Python example on the left where we're doing a step 2, 0, 2, 4, 6, 8. And on the right, we have the C equivalent, which the only thing different is that we're performing the math, I plus equals 2, while I, less than 10. So these two are equivalent, just like in the last example. Here's an example of using a for loop to traverse a list. Now, we've seen the argv property before. That comes from the the sys module that comes along with the Python language. In this case, we're going to set a variable argc. Argc is going to equal the length of the number of arguments that are being passed in the command line. So in this case, if we have the whippet.net says, hey buddy will be treated as one argument, whippet.net says will be another argument, but Python will also take the script that you ran as the first argument. Now, what we'll do is print to the user how many arguments that they printed, and we're using the end field there, so we're saying end equals blank. That way there's no new line at the end. Print the number of arguments, and then just the print with nothing in it will just make a new line. Now let's create a range here for the number of arguments that they have. So we'll have range 0 to argc, and we'll iterate through that. For I in range of 0 to argc. So in this case, we're going to have 4. So that will be 1 to 4, or 0 to 4. And we'll just print to the user what they typed in. Argv sub I equals, and then you see how we have the sep as blank and the end as blank? Well, that means that the sep means that there will be no spaces in between my comma separated objects. So if you look at the output, we have arg bracket 0 with no space. So that's what the sep quote is going to do for us. We're also telling it not to end with anything. So that way we can have on the next line, we can print out the argument and then have a new line. So this is just a very simple program program that iterates through the command line arguments and displays them to the user. Now in this example here, since we're using a list, lists in general can be iterated through. So in this case, you could sort of think of this like it's a for each loop. So for arg insys.argv, and we can then just print out the argument, not have to worry about indexing at all, because the lists, again, the lists are designed to be traversed. And we'll talk more about that when we get into lists, but here you go. Simple example. Now, even though we're still collecting argc just so we can tell the user how many arguments there are, but we're traversing the list using a for loop. Pretty cool, huh?
Pretty cool.
Yeah.
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 So here we have just a quick example. Not going to spend too much time going over what the individual pieces are because you should have seen this stuff before. But just notice how the indentation works here. So we have a for loop inside of a for loop as dictated by the indentation.
Ooh.
And two of the print statements, including the indentation piece, is nested inside the second for loop, while the general print statement for the whole thing is part of the first for loop. So you can see the output on the right there using that indented for, and where the prints are located, makes you a nice, evenly spaced multiplication table.
Right, yeah. So that's pretty cool. Like that second print statement is going to break on the line. So we're going to go for one line, and then once we get to 5, we break, and then we do another one and break, and do another one and break. Pretty cool.
Pretty neat.
Control structures.
Yeah. Thanks for watching.
All right, guys, let's talk about file I/O, because it's not enough for us to work with the console. We want to be able to spit stuff out to a file, read it in, and do all kinds of crazy stuff. So in this lesson, we're going to talk about file I/O in Python. The file I/O is pretty simple. The language comes with a function. It is equipped with a function called open. And open will create a handle to a resource. So in this case, this syntax example, we can call open, send it a file path, and send it a mode. Now, the 3 common modes that you'll see is writing to a file, reading from a file, and appending to a file, which these are things that we've used in other languages as well. So here's a simple write example using the write method. So we can create a file handle. You see that the open method will return a file handle object. So what we can do in this case, we have fh for file handle equals open, and we're just going to open out.txt, and we're going to open it up as a write, and then we can do fh.write, hey buddy, and we can go out there and open up the text file, and there it is, hey buddy. Not bad, huh?
Well, not bad at all.
All right, now what do we do? What is this all about here?
We've opened it up to write to it, but we need to close out that connection so that we can, kind of finish up what we're doing there. So the close method simply closes a file handle. So the same example from before, we've opened up the out.txt and we've written hey buddy to it. Now just fh.close, call that close method and shut her down.
Right. So in this past example here with write, where we didn't actually close it, if your script is just these 2 lines, it's really not that big of a deal. But let's just say you have a program that's running for a long time and you open up a resource to a file. If you don't close it when you're done with it, then that means that if something else tries to get a handle to that file, the operating system could deny it because you have a lock on that file. That's why it's good to use the close method when you're done writing to a file. So flushing is similar to the C2C's flush, where we flush the internal buffer. So in this case, we're just doing a flush. So anything that might still be in the write buffer, we're just clearing it out. It is good practice to call flush on your file streams, whether you're reading from a network socket or not. It's just, it's the equivalent of just like
I don't know, equivalent of
flushing your toilet.
Yeah, that's what I was going with. And then you got to close the lid. So
yeah, there you go. Flush and close, and in that order.
Yes. Well, you could close and then flush with the toilet, but
that's not how we do things at Whippet.
Everybody likes to admire their work, right?
Absolutely. Of course.
So the tell method, it returns the current position in the file, similar to C's ftell. So let's take a look at the syntax, the example on the right. It's similar to the example we've already done before, where we're opening up the out text and writing hey buddy. Then we're writing our position in the file immediately after hey buddy. Then we're making a new line telling us what position we're at now. Then we're writing to the file how are you, again printing out the console there where we are in the file, and then we're going to close it out. So the output on the left is 10, 12, 23.
Right. Now, one thing you may be asking yourself is, how do we go from 10 to 12? Because you just added a new line. Well, because the tell position is where you are in the file, not where the last, character or the last byte was written. It's the next byte. So if hey buddy ends at 10, the 11th position is the new line. The 12th position is now where we're pointing. So hopefully that makes sense to folks. Now, seek is very similar to what we did in C with fseek. It allows us to move positions in the file. So if you look at this example here, check it out. We just do a open out.txt to write, and we just write, hey buddy, new line. Now we're going to seek to 4. So what that does is we're basically just moving to the 4th index of the file, and we're putting ho. So we're basically going back to where the BU is in buddy. So now it says hey hody instead of hey buddy.
You know, I kind of like that one better. That's my new hey buddy is hey hody. So the truncate method, it truncates a file based on the current seek position that we just went over. It removes all the data from the seek position onward. So in the example, we are opening our out.txt, writing in hey buddy. Now we're seeking to the 3rd position. And then we're calling our truncate method. That's going to truncate everything after the 3rd position. And in this case, our 3rd position is the y in hey. So everything after the y in hey, including the space and the buddy, is all gone. Not there anymore.
It's like cutting it with a pair of scissors.
Just the seek is your dotted line and truncate is your scissors across the paper.
There you go. Now let's take a look at read. Now we can use read in the context of streams generically, just like we have seen that in other languages with read, like in C# when we're reading from a stream. Read is generic, and in a later lab we're going to do web service calls where we're all using network streams and stuff, and we're going to be using read. Now how does read work? Well, basically, let's talk about what it does first. Well, what it does is it reads data from a file. Now the data that you get back is in the form of bytes. So in this case, we're reading in the file that we wrote out. And the file, if you look there, it says, hey buddy. The very first example, if you pass read no parameters, it's going to read everything. So it just read the entire file and it says, hey buddy, how are you? As you can see there. Then we read the first 3 bytes and then it says, hey. And then we seek to the 4th position and read 5 bytes and that says, buddy.
Very cool.
Not bad.
So the read line method. It reads a single line from a file, but note that the end of line from the file is captured. So in our example here, we're opening up the out.txt, and that's shown here as hey buddy, and then on a separate line it's how are you. The output from our example, we have 2 print read lines. The first one's going to show hey buddy. The print function itself is going to be an end of line, but the read line is capturing the end of line from the file. So you'll notice that it's hey buddy, and then an empty line, and then how are you, and an empty line. And that's because print is giving it a line, and then the read line method is also noticing that these are on separate lines and is capturing that end of line from the file itself.
That was incredible. Now, when we want to do something like read line as plural, this is going to read all of the lines, and they're going to be brought in as an array. So it reads all of the lines in, and we can iterate them using a for loop. Now, we can also store them as a list and do other stuff with them. But again, the read lines method, just like the read line method, the end of line character is still captured. So just like in the last example, we're going for each line in read lines. We still have that exact same paradigm where the print statement appends its own new line and the line variable there, because we have 4 line in read lines, the line string is going to have a new line at the end of it as well. So this is just the way that we can read all the lines of the file.
The closed method. It returns true if the current state of the file is closed and false if not. So we talked before about a good reason why you would want to close out your file when you're done writing to it, so that, if something else is trying to open it and do something to it, it's not locked by the system. And with this method, you can check to see if that file is available for you to mess with or not. It'll tell you by true or false. Mm-hmm. So in our example, we're just printing out that Boolean value if it's open or if it's not. So initially we're opening out.txt and then we're printing out if it's open, or we're using the closed method to see if it's open and it's not. So it's returning false and printing that out. And in our the next example on that line there, we are closing out our file. So it's going to return true.
That is super awesome. That way we can check to see, and if we need to reopen it, we can reopen it. Now the mode is a property that allows us to check to see what the file mode is. In this case, we have read as the mode, but let's just say that 500 lines down in the file, we wanted to check to see what the mode was, so we could send the logic down one path if we're reading, the logic down another path when we're writing. In this case, we can do the fh.mode to check to see what mode that it is currently configured in.
The name property returns the file name. So you're opening out your out.txt and you just want to see what file you're messing with. You want to see what it is you're actually managing. So you use the name property, and your output to the console will give you the file name.
So Python does not support any end-of-file functions or methods. A lot of times developers have their own way of knowing when they've reached the end of a file. If you're using the read method and you don't pass any parameters, so you don't tell it how many bytes that you want to read, you could be sure that the entire contents is going to be consumed. But if you don't, like let's just say you're reading through a humongous amount of data. Let's just say that you have a program that's reading a file from disk and then sending it over a network socket. And what you're doing is you're reading bytes at a time and sending bytes at a time. That way, if you're sending a 30 gigabyte file or something like that, you don't blow up the resources on the server. So if you are reading bytes at a time and nothing is returned, then you've reached the end of the file. So let's take a look at this. What we're going to do in this example is just read one byte at a time. So just one byte and then print the byte out, read another byte, print the byte out until we reach the end of file. Now look at this while statement here. So we have while C. Let me actually go back to the top where we actually open the handle of the file. So we have out.text as read. C, which will represent the current character that we've consumed, is going to be fh.read1. So read one byte. So let's enter a while loop while C does not equal quote quote. So while it doesn't equal nothing, so while it equals something, then we know that, oh, there's more data. So we'll print that out to the user and then read again another byte. So we could use that read method all we want past the point of, data in the file, and it will just return us a blank result if there's nothing there. So here's how that works.
So here we're doing the same thing that we did with read, but we're doing it with read line. So instead of going a byte at a time, we're just going a whole line at a time. So it's instead of printing out, H, then E, then Y, space, B, U, D, D, Y, we're printing out the whole, hey, buddy, then going to the next one with how are you? So it's giving you a little more at once to print out there.
Mm-hmm. Yeah, and the main thing to get out of this too is when we reach, if the line that we read equals nothing, then we've reached the end of the file. So it works the same way as the read method does. Let's talk about binary data. So all the previous examples that we've looked at are text files. Now we all know that text is not the only thing that you're going to work with in software development. So let's talk about how we can work with raw binary. So here's a ping file, which we all know a ping file is an image file that's a binary, and this is the Whippet.net logo. If we were to open this up, so we have open, and then we open it as a read, and we read one byte at a time, and we try to do stuff. Look at this. It actually explodes. It blows up. It throws an error. It says that it could not decode this byte using a character map. I wonder why that is, Jason.
I imagine you're going to tell us, Kevin.
Probably, because this is designed to work with text files. Now, if you want to work with binary files, we have to open it up with a binary mode. So in this case, we're just going to read in bytes from the ping, and then we're going to write out bytes in the ping. So we're making a backup of a file. We're making a copy of a file. But instead of just having R and W, we're having RB and WB. That's going to treat the file as raw binary. So we're just going to read in one byte at a time from the input file. And see how in this case, check this out. Here's one way that you can check to see if a byte exists or not. If I convert that byte to a string and it equals nothing, so B quote quote, that's the equivalent of saying that byte is equal to nothing. So once we hit that condition, we've hit the end of the file and we can exit. And then if you look on the right, you see how we have logo.back.ping? Well, that actually copied bit for bit exactly the same and opened up in my little image viewer there perfectly fine. So working with binaries is the same as working with text, except where, we have to have the binary mode appended to the actual file mode, and checking for the end of file is just slightly different.
So here's a way to use the print function to write to a file. We've kind of gone over this before, but as you can see, we're declaring FH as we're opening out our print out text as writable. And then in our print function, we have our text there, but then we're specifying the file equals the file that we open, and then we're just closing it out. So that works the same as, what we've gone over before. It's just a different way of printing to the output file.
And that's that. That's a very simple blaze through file IO in Python.
Thanks for watching.
Hey, what's up, guys? Kevin here from Whippet.net, continuing this exciting journey through the Python programming language. In this lesson, I would like to talk about collections. And I don't care what you want to talk about because this is my tutorial. Just being silly. So, list. We've actually already seen lists before. Remember when we were looking at stuff in the basic math operations and we were using the sum function to sum a list of stuff and getting the range, like the highest value, the lowest value, the min, max of a list? Well, let's actually talk about what a list is and what this is all about here. So, a list begins with a bracket and it ends with a closed bracket, and commas will separate each list item, and each list item could be of any data type. So, in this case, I have 1, 2, 3 separated by commas. Now, those are going to be strings, right? Because I have the single quote around them. So I want to create a list. It's pretty simple. My list equals open bracket, item 1, item 2, item 3 separated by commas. And when I print that out, you'll see that it prints out in very similar structure that I create the object. But if I wanted to maybe create a blank list, well, Python has a list function that I can call just like this. So this is just going to create a blank list. Now I can insert data into this list at a later time, but if I just want to initialize a list to be used later in a program or something like that, this is what I would do. So let's talk about indexing a list. The same rules apply with lists as they do with strings. A list can be indexed by using the bracket, just like arrays in other languages that we've seen. So in this case, if we have a list called list and we want to get the first item in the list, or the 0th index, or sub-0, whatever you want to call it, we would just do list bracket 0 close bracket. So my list equals item 1, item 2, item 3. If I want to print the whole list object, I can just do my list. So then I can just print all 3 of the individual elements on their own just by doing my list 0, my list 1, and my list 2. Ranging a list. The same rules apply with lists as they do with strings. Okay. So it looks like lists and strings are kind of the same. So ranging a list. So if you wanted to get a range from a list, you can do it the same way that you do as a string. So in this case, if I were to do list 0:1, that's going to return a new list that contains the first element of that list. Now, if I do 0:2, it's going to return a new list containing the first 2 elements of the list. And I can do -2:, which is going to return the last 2 elements of the list. So when we talked about strings, we went over this whole concept, and the lists work the same way. Now, here is it in practice, just so that we can see it working. So my list equals item 1, item 2, item 3 again. So in this case, we have my list 0:1. So you see that the first element is going to come out. 0:2, going to be the first and second. And then when I do -2, it's going to get the last 2 elements of that list. So how do we modify an existing list? Lists are mutable, which means that their internal values can be updated without creating a new instance. So if I want to change something at an index, look at this. It couldn't be any easier, right? I could do list sub whatever index I'm working with equals, using the equal assignment, and then first element changed, boom. So it's very simple. We've done this 100 times before, right? So my list, in this case, same, item 1, 2, 3, we'll print the whole list. I'm going to change the 0th index, sub-0 to new item 1, and then 2 to new. So you see the new list on the bottom is, instead of saying item 1, it says new item 1. Item 2 remains the same, and then the third element is new item 3. Kind of cool, kind of simple. So if you need to get the length of a list, it's very easy. You can use the len function. So in this case, item 1, item 2, item 3 will return 3. Now, how do we iterate through a list? All right. Let's start using some of this stuff that we've been learning, and let's make it all into one big happy blob of awesome Python. So my list, item 1, item 2, item 3 again. So let's check this out. Here we'll do a for loop to iterate through this list. So I have 4 index, so that's just going to be a variable in range. So I'm creating a range. It's going to be from 0 to the length of my list. So that index will equal 0 through n, whatever the length of the list is. So I can print out my list bracket and then whatever the string representation of the number index is. So I'll use this str function for that. That way I can concatenate it inside of a string like this. And that equals whatever the value is. So my list sub index. And you can see I can very easily just iterate through that list and print out the values. Now, if I want to do a for each loop, lists support that. So I can do for item in my list and just print out the item. Couldn't be any easier, right? That's one of the great things about Python. Everything about Python is of course it would work that way. You know what I mean? All right, so let's start talking about some of the methods that belong to the list object. So here we have append, which will append a new item to the end of a list. So I just use it simply by doing list instance.append and then whatever item that I want to add. So here I have a list 1, 2, 3, 4, 5. When I print out the list, I have obviously 1, 2, 3, 4, 5. Now I'm going to append the number 6 by doing list.append 6, and you can see the result of that is a new item at the end of that list. The extend method will append all the items from one list to another list. So in this case, I can do list.extend and then another list. So check this out. Here's it in practice. So I have list 1 equals 1, 2, 3, 4, 5, and then list 2, 6, 7, and 8. I have 2 separate lists. So I'm going to print out list 1, and then I'm going to, just to show that it has 1, 2, 3, 4, 5. So what I want to do now is I'm going to take list 1, call the extend method, and pass list 2. So what this is going to do is it's going to take all the elements in list 2, and it's going to append it to the end of list 1. So now list 1 will have 1, 2, 3, 4, 5, and 6, 7, and 8. The insert method will insert a new item at a specific index in the list. So the way that we would use this would be list.insert, and then the index that we want to work with and the item that we want to insert. So once again, I have a list here, 1 through 5. I can do list insert in index 1, the number 11. So you can see index 1, which means the second element in that list. Now the list will read 1, 11, 2, 3, 4, 5. So how do we remove something from a list? Well, this is kind of interesting. So the remove method is going to take in a object to remove from an existing list. So if we have list equals 1, 2, 3, 4, 5, we'll print out the list just to show it. If I want to remove the number 2, I could just say list.remove 2, and then number 2 is taken out of that list. Pop! All right, so popping is really good when you're doing queue type processing. You have a list of things that need to get done, and you have to pop from the top. Well, the pop method is very useful for that. So the description would be returns an item at a specific index, and it removes it from the list. So you can say pop 0 to get the top index, but if you want to say pop 4 to get the, the 5th index, you can do that. So here I have my list 1 through 5 again. If I want to pop 0, I will get the value of 1. So you can see I have print list.pop0, and you see that I actually have 1. Then when I print my list again, that value is removed from that list. The index method will return the index of the first occurrence of a value. Okay, interesting. So check this out. So we have list.index and then whatever we're looking for. So we're basically trying to see, we want to see if something exists in a list or find out where it is in the list so we could maybe do something with it or move it somewhere else. Who knows? Who knows what application you want to do? But simply put, if I have a list that just says, hey buddy, what's up? I can print that out and you can see each one of the individual elements in that list print out just fine. Now I want to see where in that list buddy is. So I can say list.index and then case sensitive. I have buddy exclamation point, and it's going to return 1 because that exists in the 1 or second index in that list. The count method is going to return the number of times a specific item occurs in a list, which is kind of cool. So you want to see how many times the number 1 occurs in this list, where it's 1, 1, 1, 2, 2, 1, 3, 4, 1. All I have to do is list.count1, and it will tell me the number 1 exists 5 times in this list. The sort method will sort a list. So in this case, we have a list 1, 6, 55, 0, 2, 5, 12, 4. And when we do list.sort, it's going to return those numbers in a sorted fashion. In this case, it's going to be lowest to highest, 0 to 55. All right, now Python also does have a sorted function. A list can be sorted without affecting the list. So the previous example back here, when we did list.sort, well, as a mutable object, I actually changed that around. So the next time that I print out list, it's going to print out the modified list, and the original number, the original ordering of those numbers is gone forever. So in this case, we have list 987. If I want to make a new list where it is sorted, I can say sorted, pass in the list, and now I actually have 2 lists. One that's the original assortment of the numbers, and the second one where they are sorted. The reverse method, you can take a guess at what that does. That's just going to reverse the list. So let's just say you wanted to sort a list in descending order instead of ascending order. So you want to get the highest number to the lowest number. Well, in this case, we can just do list.sort. And then once we're done that, we can do .reverse. And it will mutably, don't know if that's a word, but I'm going to coin that word. It will mutably work on that object. So now the list object is a sorted list descending. So one thing for you to keep in mind as a new Python developer, so recall that variables in Python are going to refer to pointers. So if a data type is mutable, so if the data you're working with is mutable, right? So mutable means that it can be changed and it can be modified. It can be modified in a vast number of ways. So just be careful. If you did not intend to reverse your list, but instead you wanted to get a copy of the list and reverse it, well, you just have to make sure that you do that correctly because you may end up down a trail that you didn't intend to. So just be aware of what you're doing when you're writing your programs. All right, so let's talk about the del statement. So in this case, we have a list 0, 1, 2, 3, 4, and I can print out that list, and you can see I have 0 through 4. Now, let's just say I want to delete index 2. Well, I can say del list sub 2, and now look at the list. So now it's 0, 1, no 2, 3, 4. Now, I can also delete the entire list and just have a blank list by just saying del list. So the del statement will delete a variable, and that variable can be inside of a list or it can be the actual list itself. So a list can be nested. So you can have a list that contains a list that contains lists of lists. That's not uncommon in software development, especially when storing serialized objects. In this case, we have a list, and we know that because that equals bracket and then it closes bracket. And then this main list has 3 elements, and those 3 elements are 3 individual lists. So the first list in index 0 is 1, 2, 3. The second list is 4, 5, 6. The third list is 7, 8, 9. And I can iterate through this very easily. So I'm going to do a for loop here. So I have for I in range 0 to the length of the list. So I'm just creating a range to go through the list and iterate through. Print list, and then I'm just going to print out the current list element that we're looking at. And then since I'm scoped into the for loop, now I can iterate through the sublist. I have the sublist because all I have to do is do list sub I to get the sublist. So for item in list sub I, now I can get the sublist. So if you look at the output on the right, we're printing out the hierarchy of the high list first and the inner list afterwards. Now I'm about to blow your mind. Yeah. So we could, if we wanted to, for each our way through a list, which we've done before, and we could have the sublist and we can get the sub items from there. But if you wanted to, let's just say you knew that the data structure looked like this. You knew that you had a list that had 3 values for each one of the indexes. Well, you could iterate through the list like this. You can say for I, comma, j, comma, k in list. And what that will do is that will set I to the first number, j to the second number, and k to the third number. So I can for each through this and check it out. I can just print out the list. 1, 2, 3 is the first one. 4, 5, 6 is the second one. And 7, 8, 9 is the third one. Now we will talk about the set. So recall this from our data structures conversations in earlier courses. A list is a collection of items, and there's no rules that dictate how many times a specific item can occur in a list, but a set is different. A set is a collection of items in which there can only be one of each type. So the classic example of a set would be a deck of cards where you only have one of each type of card. I guess that's not necessarily Uno cards, but traditional playing cards. Now, if we want to declare a set instead of a list, we do the exact same thing except for we use brackets instead of square braces. So it's pretty easy. So you want to declare a set? Okay, great. We have a set 1, 2, 3 with curly braces around it. And if a duplicate item is inserted, it will just simply be discarded. So the program is not going to explode if I were to say 1, 1, 1, 2, 3. You know, it'll just say, all right, well, 1 is already here. I'm only going to allow 1 to be in there, and that'll be that. Now, just like the list, if you wanted to create an empty set, well, there's a set function that you can do that with. So if you wanted to just make an empty set, you could do my set equals and then call the set function, and then you'll have an empty set. Let's start marching through some of the set methods. So if you want to add something to a set, no problem. You can just use the add method. So if I create an empty set, so I have my set equals the set function. Now my set.add1, my set.add2, my set.add3, I print it out. You see now I have a set of 1, 2, 3. Now visually, right, we can see that this is a set very, very, very easily because it is curly braces, not square braces. That's the dead giveaway. So my set.add4, my set.add1. Wait a minute, Kevin. Hold on. Slow down. 1 already exists in that set. So shouldn't this program explode? No. Because Python doesn't like to explode. Because Python is like water. You know, it's like ripples on a pond. No matter what it hits, it just goes around it. So if I try to add 1 again, it simply discards it. And you can see that I have 1, 2, 3, 4 as my set. And it worked just perfectly. So removing an item, just the same as removing from a list. So if I have a set called 8675309 and I print that out, if I want to remove 8, it's very simple. My set.remove 8 and then print it out. And 8 is mysteriously missing from that set. We can also pop from a set just like we do from a list. Here's an example of that. And if you want to clear a set, it's very simple. .clear. So set 5 to 1 and get the length and it's 5. Clear it and then get the length again and it's 0 because I cleared the list. we can use the set function to either create a blank set or convert other types into a set. So we looked at the set function early on to create a blank set, but let's say I have a list here. Now we're mixing data types, right? So I have a list 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, and we know it's a list. Why? Because it has a square bracket. So let's print my list, and you can see there on the output, there's my list. Now I want to take that list and I want to convert that to a set. No problem. My set equals set, and then I can pass it in a list, and then you can see the output is, and you know this is a set, right? Because it's a squirrely brace. 1, 2, 3, 4, 5. The second 5 is mysteriously gone. 6, 7, 8, 9. So the set function can convert a list into a set as well. One of the greatest data structures in software development is the dictionary. I mean, it's so practical and it's used so frequently in so many things, including just simple object serialization. I mean, what pretty much JSON is a dictionary, right? And here we have a list of key-valued pairs is a dictionary. We're used to this. We've seen this before. Each pair is separated by a comma, and then each variable name and value name, or each key and each value, separated by a colon. So an example of visually seeing a list is key 1 colon value 1 comma, key 2 colon value 2 no comma, because it's the end of the dictionary. Now, one thing to keep in mind is this dictionary has curly braces as well, like a set. Well, a dictionary is sort of like a set in a way, but it's different. So if you think about it this way, a set is a list of objects where you can only have one of each kind. Well, a dictionary is an object data structure where you can only have one key of each kind. So you can only have, if you have a dictionary where, let's say, you're defining words, or even just a simpler example, you have a person, first name is Kevin in my case, right? So the key of Kevin can only exist once. And if you were to change Kevin, well, you're not adding a new value of Kevin or a new value of first name. You're just changing the first name value in that dictionary. Now, those of you guys that know JSON will look at this and say, wait a second, whoa, that's JSON. Yes, it is. So let me create a simple dictionary. So in this case, we're just going to do a classical look for a word, get a definition. So my dictionary equals, and we have curly braces, word 1 colon def 1. So word 1, def 1, word 2, def 2, word 3, def 3. And if I want to print the value of word 1, so I want to get the definition of word 1, I can easily say my dict bracket, quote, word 1, and then there's def 1. Now let me add a value of word 4 and set that equal to def 4. So all I have to do is just add it. I don't have to do anything crazy. That's not going to throw an exception because that key doesn't exist. It's going to add it. Remember, Python is water. Python things just work. Python things aren't supposed to explode. So I have my dict word 4 equals def 4, and the value of word 4 is def 4. All right, let's start marching through some of the methods that belong to the dictionary data type. So we can clear a dictionary by doing .clear. So it's very easy to see how this works. On the right-hand side, I have a dictionary with word 1 and then word 2. And I do .clear, and now I have all of my keys and all my values are gone. I can also copy a dictionary. So the copy method is going to create an exact copy of a dictionary. All I have to do is dictionary object instance.copy. So dictionary word 1 and word 2. I want to create another dictionary called myDictCopy. So myDict.copy. Now on the copy, I'm going to add a new key, word 3, and set that equal to def 3. So when I print out myDict and myDictCopy, you will see that the first one does not have that new key added. So it creates a copy. It's not a reference by pointer. So I can change my copy without affecting my original. The get method allows us to get values from a dictionary and also allows us to set default values in the event that that key doesn't exist. So if instead I didn't want to use the bracket syntax, I wanted to do this and perhaps set a default value, I can say mydict.get. In this case, I have word 1, def 1, then word 99. The default value in this case will be blank. So if word 99 does not exist, the value will be blank, and you can see on the right-hand side that's the case. And word 2, if word 2 doesn't exist, the value will be blank, but word 2 does exist, so the value of def2 is resulted. So with a dictionary, you can also use the set default method. Now it's pretty much the same as get, but with a major difference. It works like get. However, when you use the get method, if the key doesn't exist, it just returns a default value. But if you use set default, if the key doesn't exist, it's going to actually create it inside of that dictionary. So I can do dictionary.setDefaultKey. dictionary.setDefaultKey and default value, and then check this out. Here's my dictionary below where I have word1 and def1. So I can print out my dictionary. You see over there on the right, we have word1 and def1. Then I want to do mydict.setDefault word2, and the default value is going to be blank. So you can see on the second line of the output, the word blank is resulted because word2 did not exist in that dictionary. But now when I print out mydict, you'll see that there is now a key called word2 where the value is blank. Use this one wisely. This is mutably changing the object. So if you do this and you meant to do it, great. But if you do this and you didn't mean to do it, you could be causing some problems. The items method will return a nested list of individual key paired items. So I have dictionary.items is how I will call this. All right, let's see this in action. So we have mydict, and we're creating a dictionary, word1, def1, word2, def2. So I have 4 key valued pair in mydict.items. All right, so what is that? Well, that means that I'm going to have a list here of the 0th index is my key, and the 1th index is my value. But I can just as easily iterate this way, where I have 4 key comma value in dict.items, and now I actually have a variable called key and a variable called value as I iterate through this dictionary. If I only want to get the keys from a dictionary, I can just do the keys method, and this is going to return a list of the keys that I can iterate through however I want. So in this case, I have my dictionary keys equal to mydict.keys, and then I'll just print them out to the user by joining on a comma the dictionary key. So I have keys colon word1 comma word2, 4 keys indeed keys, and I'm just going to print out the key equals and then dict.get and then the value. So if you just need the keys for whatever reason, this is how you can do it. Now this is a very interesting and fairly useful method. I've definitely used this a number of times. So the update method will accept the dictionary and it will update the values in the dictionary that it's called with if that key exists in the source dictionary. All right. So what the hell does that mean, Kevin? All right, well, I got you here, guy. Don't worry. So dict1 equals word1 colon def1, and dict2 is word2 colon def2, and word1 colon new def1. All right, fantastic. All right, let's check this out. So I can just print out dict1, and you can see that it's just that plain old dictionary. Now I can do dict1.update with dict2, and check this out. Now the value of word1 has been updated to def1, and since word2 didn't exist in the original dictionary, it will add it. So now dict1 contains the new value of word1 and a new key called word2. So earlier on, there was a method called keys that returned the individual keys in a dictionary. Well, now if you just want the values, well, you can just do dict.values. So very simple. So for value in dict.values will return the values instead of the keys. So I have def1 and def2. All right, let's talk about a tuple, a tuple, tomato, whatever you want to say. I lean in the tuple direction. I have been known to say it both ways. I don't exactly know why, but I don't think that, you can say it wrong. I mean, if you say tuple or tuple, people will know what you're talking about for the most part. So I'm going to try to say tuple just because that's the way I like it. And that is a sequence of immutable objects. So it's similar to a list, but it is not changeable. And the way that we declare a tuple is with parentheses. So now I have a tuple down here of 1, 2, 3, and 4. And there you go. So I can do other basically similar stuff that I can with my lists here. I have tuple ABC. If I want to get the length, I can use the len function. I can print out the length there and print out the tuple to the screen as well. So here's a simple example of creating a tuple. Now tuples can have subtuples. Oh yeah. I know this is crazy stuff, right? So here we go. Let's have a tuple where the first element is another tuple of 1 and 2. The second one is a tuple of 5 and 10. The third one is a tuple of 11 and 52, and the last one is a tuple of 88 and 20. So what is the length of this tuple? Well, it's 4, because we have 4 items, and they just happen to have tuples inside of them. Print out the length there, so we have 4 items in tuple, and then I'm printing out the tuple. So let's just iterate through it the same way that we've been doing with dictionaries and with the lists. I can do 4x, y, and tuple and just print out the value. So I have x equals and then y equals and blah, 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 blah. So it's very simple. It's very iteratable, just like the other stuff that we've looked at already in this lesson. So collections, lists, tuples, sets. I mean, there's all kinds of awesome stuff that Python provides. And you will definitely find a practical use for every single one of those object types, particularly the dictionary. The dictionary object is one of the most useful objects in software engineering, at least as far as collections are concerned. So thanks for watching, guys. See you in the next one. Maybe. Let's talk about functions in Python. Now, you may be asking yourself, why did it take this long for us to talk about functions? We know about functions. We've used functions before. Blah, come on, Kev. What's wrong with you, man? Well, I'm sorry, guys. But now we're going to talk about functions. But, don't get too upset because this is going to be a quick one. At least I hope so. So again, this lesson, we're not going to talk about using functions because you know how to use functions because you're awesome. You know what you're doing. But what you don't know is how to create a function in Python. Now, Kevin will show you the way. Here we go. So we can define it with the def statement. So here is the syntax of creating a function. So def, the function name, whatever parameters you want, then colon, and then tabbed in or spaced in, same, and then the code that belongs to the function. Now, if I want to create a simple function that just prints hey buddy, I can do def hey buddy, paren, colon, tab, print hey buddy, and call it 3 times, and then here you go. Hey buddy, hey buddy, hey buddy. That's the best function ever made. Then we have our very overly simplified power function that we can do. So I have def power that takes base and exponent, and I basically perform a simple power operation where I just multiply the base by the exponent however many times that the algorithm specifies. So here we go. I can do print power 2, 10, and there we go. We have our own very simplified power function. All right, so here's kind of an interesting thing that Python provides that you may not see in other languages. Python supports nested functions. So a function that is defined and scoped inside of an existing function. What the hell is this? So nested functions are only available in the local scope. Oh, that makes a lot more sense. So functions at a higher scope cannot access them. All right, I can see that. So you want to have some function that's hidden inside of a function that sort of collapses down some specific logic for that specific function. Great. You can do that in Python. That's pretty cool. So here's a function. We have def parent function, and then inside of that function, I have another function. I have def child function, and the child function just simply prints, this is child function. So now I print, this is parent function, and then I call child function, and then there's my output. This is parent function, this is child function. So child function is not accessible from the higher scope, but it is accessible inside of the scope of parent function, as you can see here. Recursion in Python, recursion is not a programming language specific concept, but if you wanted to do a simple Fibonacci recursive algorithm, you can do this. So we have Fibonacci, which we've done Fibonacci before, and we're just iterating 0 to 10 just to get the Fibonacci number at that index, or at that value, I should say. So if n is 0, return 0. If n is 1, return 1. Otherwise, return Fibonacci n to the n minus 1 plus Fibonacci n minus 2, and there we have a simple recursive algorithm. Now, if you don't know anything about this, or this is blowing your mind, go back to the Programming in C course, because Brian and I do a thing about recursion where we have a little cartoon and stuff, and we actually go over the Fibonacci algorithm in that as well. Now let's just say you wanted to be able to take an unlimited list of parameters, similar to the printf function in C, right? You want to send it as many parameters as you want and do something with it. So here we have def add numbers. We can have a variable called *args, and that represents a list that contains an infinite number of parameters. So we have a function here called add numbers, and what it's going to do is it's just going to take a list of parameters. So I have 1, 2, 3, 4. So I will set my result as 0.0, iterate through the range of however many parameters you passed in, and then I will just simply add those values together and then return the result. So in this case, 1, 2, 3, 4. So we have 4, 5, 6, 7, 8, 9, 10 is the result. So another cool thing that you can do with Python, and other languages let you do this as well, but you can have a preset argument value. So this allows you to have a sort of function overloading without having any overloading. Now, if I want to have a write function that will write out text to a file here, I can do, let's just read this function here. We have def write, so we're creating a function called write, and it's going to take in text, and it's going to take in a optional parameter called append new line, and if that append new line value is not set, it will be defaulted to false. So the rest of the function is we're importing sys, and we're doing sys.stdout.write text. If append line, write it out. I said file a second ago, but actually this is just writing to the screen. We're just writing it out to std out. So if you say true for append new line, it will write \n. So here we go. I have write hey, and then write space buddy, specifying false. Now, the top two are going to perform the exact same thing because the default value was false. But if I were to say false, it'll be false as well. Today is a great day to learn ... true. So that's going to have a new line and then Python and then true. So this is a way you can have preset arguments in your functions. Another really cool thing that Python has, and I mean this is pretty mind-blowing. This is pretty awesome, is we can have key valued arguments. So recall the print function. I believe earlier when we talked about the print function, I may have mentioned that we were going to talk about this later, but if I didn't, you knew it was coming anyways, right? So in the print function, I could do whippet.net is awesome, and then I can say sep equals space, which means that the print function will print those out to the output, and it will put a space in between each one of those items. So how do we manage this sep thing? How does this work? How does the print function allow multiple key valued arguments? So in this other one down here, I have sep equals space, and then end equals \r\n. The values sep and end are passed as a dictionary, and it can be handled very, very easily. So here is a example of using this concept. So I have a function called print key value arguments, and the variable name is **kvargs. All right, so key valued args is what that's supposed to stand for. So I can do for kv and kvargs.items and just get the values and print them. So down there where I have print key value arguments, I have source equals whippet.net, comma, says equals hey buddy. Now here is something that you should practice to kind of get the idea of this. If you want to create your own print function, you could do this. We have a Python script called whippetprint.py. We're creating a function called whippetprint. The first argument is *args, meaning it could be an unlimited amount of arguments. And the second one is going to be key value args, and that's going to be the key value arguments. Import sys, by default sep equals space. The file that I'm writing to by default is sys.out. The end by default is going to be \n, and the number of parameters that we're dealing with is going to be stored as length. So if key value args.get, so I can do .get to get the value in the dictionary, sep. So if it contains sep, if it does not equal none, then separator will equal whatever that value is. If it contains file, then file will equal whatever that value is. If it contains end, then end will equal whatever that value is. So you can see that's pretty awesome. So now we'll just do for I in range of 0 to length, so as many of the *args that are passed. We'll do file, whatever that file object is, .write, the string equivalent of whatever is in args sub I, and then if I plus 1 is less than the length, so if the current index that we're at has not reached the end of the list, then we'll print the separator value, and if n does not equal blank at the end of this, then we'll write out the end. So the MyDriver Python script will look like this. So I have mydriver.py from whippetprint. So the inside of this directory, there's another script called whippetprint. I'm going to import *, which is import everything. So I could do whippetprint 1, 2, 3, 4, and you can see down there it's 1 space 2, 3, 4 by default. Then I can just add comma sep equals underscore. Now I have 1 underscore 2 underscore 3 underscore 4. Now I can do whippetprint and then just quote 3, 4 separate by underscore. Now, but one thing that we'll notice is that my end is quote, meaning that I'm not going to end anything. So I have 1 underscore 2. Then I will print out, I have quote as my other argument, 3, 4 separated by underscore. So that means I will have 1 underscore 2 underscore 3 underscore 4. Again, that's pretty awesome. But see, now what I can do is I can create a file handle. So I can open up out.txt as write, and I can do whippetprint 1, 2, 3, 4, pass it sep equals / comma end equals quote, and the file that I want to use is file handle, and close the file. And you'll see that creates a file called out.txt that contains that data. So that is really awesome. So we just made our own print function from scratch. I think it would be really wise for you to play with this because this kind of demonstrates a lot of the concepts that we've talked about so far. So creating functions in Python is no mystery, no big deal. Take this, run with it, kick some Python butt. Another one of the great lessons in software development is to learn exception handling, how we can handle exceptional situations and how we can create ways to handle exceptional situations in software development. So here we go. Exception handling is a critical aspect of software development. We can use exception handling to run code safely and redirect the flow of the program if some exceptional circumstance occurs. So let's look at this simple numerical example. So we're going to import math, x equals 0. So we'll say print, enter a number, and we'll say x equals, we're going to say float input. So what we're going to do is whatever the person types in, we're going to convert that to a float so we could do mathematics on it. In this case, we're just simply printing out x times math.pi, so the value of pi, the precise value of pi, equals x times math.pi. So in this case, we have 4 is what the user puts in, and 4.0 times 3.14 blah equals 12.5 blah blah. All right. Now, if the person types in the letter A, well, that's not a number. So this program's going to crash. And you can see down there we have a value error exception, and the message is could not convert string to float. So what happened? Python threw a value error because it expected a number and it got a character. So how do we handle this? Well, we can use the try statement, of course. I mean, sound familiar? We've been doing this for a million years now. We can do something like this. Let's say we want to force our user to put in a number. So we're just going to create a while loop, so while true. So this is an infinite loop that will break programmatically. We'll try, print, enter a number, and then we'll cast the input to a float and then break. If we hit that line break, then that means the float was successfully converted and we can continue to the rest of the program. And if it fails, we're going to hit the except block here and we'll just say pass. We don't want to do anything. We're not going to even write an error message. If for whatever reason the user types in something that cannot be converted to a float, we'll just force them to enter another number. So the output on the right there, you can see enter a number. The user types A and that goes to the except, so we pass. Enter a number, B, that goes to the except, so we pass. Enter a number 5, that hits the break, and it's able to continue on to the rest of the flow of the application. This example, we are specifying the type of exception that we are expecting. So we have the value error. So you can see now we have except value error, and we're just printing out to the user, you entered an incorrect value, try again, as opposed to just passing. Now, if we want to get the error message back, we can do it like this. So we can say accept value error as ERR. So ERR is going to represent the error of the exception. Now, I can convert that to a string by calling the str function and get the actual string message of what the exception was. So in this case, if the user wants to type A, we will say print str ERR, and that will say could not convert string to float, and then it will tell it what string it put in. Now, the previous example, we had the value exception, which is the precise exception that's occurring, but there's also just the generic exception class that we can use, just like in Java, just like in C#, works the same way. So in this case, instead of having a specific value exception, we're just having a generic exception. So if I wanted to get the error message or the exception message from just the generic exception, I could do it the exact same way. I can say accept exception as EX and get the use the string function to get the message, the string equivalent of the message out. So in this case, it works the same way. So it just functions the same way, except for doing a value exception, we're just doing a generic exception. Now let's take a look at this example here. Now this program is acting a little bit unexpected, at least for this example it is. So it's the same program, except we're doing whatever you put in there, we're going to divide it pi by x, and that's going to be the value of x. Why? Who cares? That's just what we're doing. So we're going to do the division inside the try block instead of doing it outside of the try block, so we can capture the situation where perhaps we do a division by 0. So in this case, we enter B and it says you entered a non-number. Please try again. Okay. Now I enter 0 and this program crashes. Why? What happened? So the code is only looking for a value error. So if I go back, see value error, but a division by 0 error happened. Okay. So we can do except stacking. Again, I hate doing this, but just like Java, just like C#, this is not a foreign concept to us guys, right? I mean, we've been through this before. So just like in other languages that we're familiar with, Python can catch a specific type of exception. So stacking except statements is just as easy as we've learned in Java and C#, just to say that yet again. So I want to capture a division by 0 exception or division by 0 error, I can do this, except value error. So let's just say you typed in the letter A, we'll capture it there. But if you type in a 0, we will catch the 0 division error and say, you cannot divide by 0. Please try again. So throwing your own exceptions is just as simple as using the raise statement. So in this case, we're creating a function that will just take a listing of numbers and then just divide them all together. Why? Who cares? That's what we're doing. As we iterate through that list, if one of the numbers is 0, we're going to raise a 0 division error and say, hey buddy, you can't divide by 0. So you can see the actual output down below. Since there is a 0 in that list, you can see that it just says division by 0 error, 0 division error, hey buddy, you can't divide by 0. Let's walk through some of the different exception classes that Python provides. Not that it's that important, but it's just kind of good to get like a quick, sprint through the park on this stuff. So there's a base exception, which is the base class for all exceptions. And then there's the exception class that built-in exceptions inherit from this class. So any Python exception will inherit from exception, including user-defined exceptions. So the standard error is the base class for a number of different built-in functions or different exceptions. Arithmetic error is the base class for built-in exceptions that are arithmetic errors, such as division by 0. Lookup error is the base class for exceptions that are raised when a key or index is invalid. So if you're looking up something inside of a dictionary or whatnot. Environment error is the base class for exceptions that occur outside of Python, such as input and output, like you're reading from a file, or something within the environment that is not in the control of Python occurs. That's the base class that you would use for that. Assertion error, assert statement fails. Attribute error, attribute reference, or assignment fails. So an object does not support an attribute reference. EOF error is raised when the input function or raw input function call reaches the end of file. Floating point error, so floating point operation fails for whatever reason. IO error, input-output operation fails. Import error, import statement fails. Index error, something is out of range. Key error, key does not exist in a dictionary. Oh crap, this just keeps going, huh? Seems kind of pointless to go through this. I agree, but I'm just going to do it anyways because I went ahead and typed it up. Keyboard interpret, so a user maybe hits Control-C to break out of a script. Memory error, operation runs out of memory. Name error, variable does not exist, it's not found. Not implemented error, so a class inherited from a base class and the inheriting class failed to implement a required class. OS error is derived from the environment error and it's raised an operating system level problem. Overflow error is arithmetic operation is too large to be represented, so something simple like a larger number than that can be represented in 32 bits or 64 bits. Runtime error, an error that does not fall into any other category, so I don't know what this is, it's a runtime error. Stop iteration is thrown in an iterator, which we'll talk about later, when there are no values left. Syntax error, Python parser encountered illegal syntax. System error, when the interpreter finds a non-emergency error. So the program can still continue even though some problem has occurred. A type error, an object is used as an incorrect type, it was casted incorrectly. Unbounded local error, locally specified variable in a method or function exists, but no value has been bounded to it. Unicode error, some Unicode related problem. Unicode decode error, Unicode error, encode error, Unicode translate error. Failed to interpret data as a proper Unicode character, and that is a subclass of the Unicode error class. Value error, which you've actually seen, an operation or function receives an argument that is of the incorrect type. Windows error is a Windows-specific error. Zero division error, division by 0. All right, fantastic. User-created exceptions. We will discuss this later because we need to talk about classes first, so don't worry. You will see a user-defined exception in a later lesson. Thank you for following me through that sort of unbearable but sort of awesome trip through exceptions in Python. Thanks a lot. See you in the next one. Here we go, ladies and gentlemen. The reason we get into software development in the first place is object-oriented programming, right? I mean, OOP is the most awesome thing on the planet. Let's be honest with ourselves. Now, let's talk about classes in the Python programming language. So Python classes provide all the standard features of object-oriented programming that we've become accustomed with: methods, fields, inheritance, construction, operator overloading. A simple syntax for creating a class is pretty simple, right? We have class, the name of the class, colon, and then scoped in whatever code belongs to that class. So if I want to create a class called Wibbit that has a field called word that's a string, I can do it like this. So class Wibbit colon word equals Wibbit. To create the instance of Wibbit, W equals Wibbit paren. So I have an object there of Wibbit type. Print w.word, and Wibbit's printed out to the screen. So if we want to define a method with a class, we can just use the same def statement that we've used to create functions. So def method name self, and then whatever parameters you want to pass. So in Python, we have to pass the self along because that is the open recursion used in this language so that the method knows what class that it belongs with. So in this case, we have class Wibbit : word equals Wibbit. We're creating a method, so def speak, and then self is the parameter, which will be for every method that we create, and then the speak method will just do self.word. So self is the same thing as in C# or Java would be this, the open recursion in those languages. So I have w equals Wibbit, and then w.speak will print out Wibbit. So one cool ability that Python provides is the ability to absorb external functions and use them as methods. Now what the hell is this? All right, check this out. So here I have word equals Wibbit, and then word len equals len. Okay, len is a function that belongs to Python. But what I'm doing is I'm assigning word length equal to len, so now that's actually a function inside this class. So now it's a method. And then I still have my speak method there where I just speak. So I have w equals Wibbit, w.speak to print Wibbit. Then I can also do w.word_length and then w.word, and that will perform the same operation that a len call or a len function call would do. Constructions in Python are using a method called __init__. Now, if we want to have a constructor here, we have Wibbit is the class. And then we have a field called word that's going to be set to blank when the class is instantiated. But when this class is constructed, we have the __init__, passing self. We're going to set self.word to the bird. So w equals Wibbit, print w.word is the word. So the bird is the word. Bird. Another cool thing about Python is you can create fields without actually declaring them, which is pretty awesome. So on the left here, we have a class Wibbit, and then we have self.word inside of the constructor, setting that equal to bird, but there is no field that's been set called word. Now, some developers really like this, and some developers think that this is just horrible, but it's your preference. Look at this over here on the right. We have class Wibbit, and then we just do a pass. We're not actually putting anything to the class. It's just a class with nothing. But I can do w.word, and I can create a field during the runtime of this program. So the method arguments can have default values using that dictionary syntax, just like functions do. So if I wanted to create a person class and I just want to be able to construct last name and first name or none, I can do this. So I have self, comma, last name equals quote, quote. So if that's not set, it's going to be blank. And then first name equals quote, quote. So if that's not set, that's going to be blank. And then I'm just going to create two fields. Self.last name equals whatever last name is. Self.first name equals whatever first name is. So P1 equals person with no constructor, so that person has no name. The second person just has a last name, and the third person has a last name and a first name. So when I print out P1.lastname, comma, P1.firstname, I just get quote because there's no first name or last name. The second one, I just get .net, and the third one, I get the frog Wibbit. In Python, if you need to destruct the class, you will just define a method called __del__. So here's the program. So we have init, so we're constructing the object, so self.word equals the bird. Then when we deconstruct it, we're just going to say whatever word is no longer the word. So I have w equals Wibbit, and then w.word is the word. So the bird is the word. Then when the program is ending, so the program is being destroyed, all the destructors are being called, and we'll actually see this print out. It says the bird is no longer the word with a sad frowny face. Inheriting in Python is very simple as well. Here we have class, whatever the subclass is, so whatever our class name is that we're declaring, and then whatever parent class that we're inheriting from, and then just define the code of the class. In this example, we have a base class called person, and that's the same person that we were playing with earlier on in this lesson. So we have init, so we're constructing it with last name, first name. We also added a method called name, which will just print out the last name, comma, the first name. Now we're creating a class called employee, and that employee is a subset of person, so it's inheriting person. So it's everything a person is, except for it also has an employee ID, job title, and an object called manager, which is set to none. Now that will be the value of whoever this person's manager is, and by default, the person has no manager, so the manager is expected to be an employee object. Inside of this employee class, we're going to have a method called print employee, and all that it's going to do is it's going to print out name, and then the name of the employee ID, the job title, and if the manager is not equal to none, so if a manager is set, then it will print out the name of the manager. So implementing this code, we have employee1 or emp1 equals employee the frog Wibbit, so Wibbit the frog is employee ID 1, and the job title is Director of Software Engineering. So it sounds like Wibbit has a pretty good job, huh? Better job than I do. So EMP2 equals employee Buzz the Fly, and Buzz the Fly is employee ID 2, and Buzz the Fly is a software engineer who is managed by employee 1, who happens to be Wibbit the frog. So when I do EMP1 print employee, I will have name colon the frog comma Wibbit, employee ID is 1, job title is Director of Software Engineering, and then print, just to put a new line in between the two of them, emp2.printEmployee will result with the fly comma Buzz, employee 2, job title Software Engineering, and since the manager is not set to none, it will print out that Buzz's manager is Wibbit the frog. Python allows multiple inheritance. So if I want to have more than one class inherited at the same time into a subclass, all I have to do is have a comma separated set of lists here. So I can do parent class 1, comma parent class 2, whichever, whatever, however many I need. So here's a really stupid, non-practical example of showing this. So I have class A, which has a field called A, which is equal to A. Then class B, which has a field called B equal to B. Class C, which is a field called C, which is equal to C. Now I want to create a class called my class that inherits from class A, class B, and class C. So when I do C equals my class, that instance will have a variable called A and B and C. So my class is just basically taking class A, class B, and class C and blobbing it into one giant class. Well, this is not a giant class, but you know what I mean. If you wanted to create your own exception, like we had talked about in the exception lesson, you could do this. So I'm creating a "you are stupid" error. Why not? And this just does nothing, so the class is just a "you are stupid" error. So when I create a function called myFunction, if it's called, I'm just going to raise that exception and say, man, you're stupid for calling this function. So I can do try myFunction, accept "you are stupid" error as error, and then print out the error message. So when I call the function, it just gets mad at me and it says horrible, mean things to me because it's a jerk. Member privacy in Python. So Python does not support traditional private members. Developers do all kinds of cool little tricks to work around this. The most common two are naming convention. If a method starts with __, then don't ever use it. Stack inspection can also be used. It's a really inefficient way to have member privacy, but basically what it does is it checks the runtime to see if it has the naming convention, and if it does, then don't allow access. But with new version of Python, just by simply having the two underscores, we could make this a private member. Now, the reason why I mentioned this slide is because some older implementations of Python didn't have this well defined. Python 3 does, at least it does better. So here I have my class def __, private method, and then I'll just say print hey buddy, and then def public method, and then I'll do self.__, private method. So my public method is allowed to call my private method because it's within the same class. So when I do C equals my class and I do C.public method, you can see that it says hey buddy. But if I do C.__, private method, it's going to throw an exception, an attribute error. My class does not have that attribute. So what Python kind of does, it does a little trick that if it starts with two underscores, then it will just pretend like it doesn't exist. You may have noticed that many times during this tutorial series, we have taken some class instance and we have called the str function on it to get a string representation. Like for example, in just a couple slides prior, we had the exception class. So we just took an exception and we did str paren the exception instance, and we were able to get the exception message. Now that's the string representation of the class. The str function, all that it does is it calls a method on a class that says, if you need to be represented as a string, what would you like to look like? Now, if you don't define that, then your string representation is garbage. So here's a simple fraction example where we're just creating a class called fraction. Our constructor will take in a numerator or denominator, and if there's nothing set, then it will just be 0/1. So we'll do self.set numerator to the numerator, self.set denominator to the denominator, and then set numerator will set the numerator field, set denominator will set a denominator field, and then we have a method called value, which will return the two divided by each other. So the value will be the numerical equivalent, the real number equivalent. So I can do f equals fraction 1, 2, which will be 1/2. So when I do f.value, it's going to print out a number, a floating point number, 0.5. Now if I do print f, I actually just get, hey, there's a, inside of the main portion of this program, there's a class called fraction. It's an object, and it exists at this address. Okay. I mean, that's What does that tell me? It tells me nothing. So why did this happen? Python has no idea how to represent a custom object as a string. So we can just simply implement the underscore underscore string underscore underscore method, and then whatever that results will be what the string equivalent of the object is. So now all I have to do is implement underscore underscore string underscore underscore, and what that does is it returns the string representation of self.value. So now if you look below, when I do print paren f paren, that will print out 0.5. If you need to do some operator overloading, well, Python has you covered. And it's a little bit easier than things like C++. Although C++ is actually really easy, but if you want to do an equal, you implement, EQ. Now, I'm going to make the assumption now that you know that that's 2 underscores, so that I'm not, saying underscore underscore all the time. So EQ is how you'll do the equal operator. NE is for not equal. LT is for less than. GT greater than. LE less than. GE greater than or equal. And I'm sorry, LE is less than or equal. So GT greater than, LE less than or equal, or GE greater than or equal. Now here in my fraction class, I'm adding a EQ method. And what that's going to do is it's going to take in an object and it's going to return self.value equal, so the Boolean representation of ob.value. So ob.value is assuming that we're passing in another fraction. And we also have not equal, which is the same thing except for we're doing a not equal operation. Less than, greater than, less than or equal, greater than or equal. You see that I'm just simply implementing these so that I can use these operators with my custom class. So f1 equal f2. Well, first let's look at what the value is. So f1 is 1 comma 2, so that'll be 1 over 2. And f2 is 50 over 100. So are the two of them equal? It's true, because 50 over 100 is simplified to be 1 over 2. So those are actually equivalent as far as fractions are concerned. So f1 does not equal f2. Well, that's false. Is f1 less than f2? No, because they're equal. Is f1 greater than f2? No, because they're equal. But is f1 less than or equal to f2? Yes. And is f1 greater than or equal to f2? Yes. Now, if you need to implement addition, you could just do add and then subtract, mult for multiply, and div for divide. Now, just so that we have a smaller class to work with, let's create a class called WibitNumber. And in the constructor, we're just going to set a private field underscore underscore number equal to whatever value is passed in the constructor. And if nothing is passed in, then by default, it will be 0. So the string equivalent is going to be the return of the string function with whatever the value of that number is. So self.value, which is defined a little bit down in this class. We're also going to implement the add method, and that will take in an object, and we'll just return a new instance of WibitNumber with self.underscore underscore number plus o.value. So we're returning a new WibitNumber that represents the addition of those two. And then value will just return self.underscore underscore number. Set will just take in a number and then set the private field underscore underscore number to that value. So here we go. WNum1 equals WibitNumber 10. WNum2 equals WibitNumber 90. So WNum1, so we have the underscore underscore string defined. So that can be represented as a string. 10 plus 90 equals WNum1 plus WNum2 is 100. So there's a nice quick run around, relax, jog through classes in Python. Definitely take these examples and practice them because they are extremely valuable, and you will definitely be using classes an awful lot if you become a Python programmer. Hey, we're sort of coming down the home stretch of this whole Python thing. I hope you guys have enjoyed yourself so far. Let's talk about iterators. Iterator is a method of traversing an ordered collection within a single object. So in this case, we have for n in, and then here we have a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're able to iterate through these. So I can do print n, and this will just print each one of those items in that list. Because by nature, the list object allows itself to be iterated. So let's break this down. Let's take a little bit of a smaller example, and let's look at the different parts that are implemented here and how we could actually add this functionality into our own custom classes. So the ability to iterate is just simply implementing a method called underscore underscore iter underscore underscore. It's a method that returns an iteratable object. In many cases, it's just self that's returned. Then we have to implement the next method, or underscore underscore next underscore underscore, and that returns the current value of an object that is being iterated. It is responsible for changing the state of the object in order for the ordered list to be properly traversed. Each time in is called in this for in structure, the next method is called within the object. When iteration is complete, this must raise a stop iteration error. So it's pretty simple. Now let's go ahead and do this with our own custom class. So let's do a nice good old-fashioned Weebit.net code walkthrough here. We're going to create a class. Now we're also going to import the random package so that we could have a random number generator. And basically what this is going to do is we're just going to specify a number and we're just going to return that many random numbers and we're going to iterate through them. So this is a class that iterates through a list of random numbers. The amount of random numbers to iterate is set during the construction. So you see random list on the bottom there where we have 3. The constructor will take in the max number of random numbers. When the class is iterated, it counts from 0 to max and it returns a random number. So here are the different components. So we have the init. When the class is constructed, the max number of random numbers is stored and a counter variable is initialized. In this case, it's initialized to -1. Now the iter method, when a control structure is asking for an iterator, this will be returned. Then we implement next. So each time a control structure asks for the current value of the iterator, this code will travel through all possible values. Starts at 0 and it keeps going until max is hit. Then the counter is reset. Lastly, the stop iteration is raised. So one of the things that you might notice is in the iter method there, this can't be iterated multi-threaded because we're changing the state of this object. So what some people will do is they will create another instance of a class and return it back. That's a safer way to do it through multi-threading. That's just kind of a side note, but I wanted to just make that known that this is unsafe to do multi-threaded, but this is just a simpler way to do this. Okay, so we construct the object. So we're going to have a field called max, and that's going to be equal to 3, and a field called counter, which will be initialized to -1. So when in is called against that list, which it is right here, we're going to return the instance of self. So now we do for rand. So what we're doing is we're going to be calling the next method, and we're going to set whatever is returned back into a variable called rand num. All right, so we have self.counter equals self.counter plus 1. So now counter will start at 0. If self.counter is greater than or equal to max, then we will reset the object and then we'll stop the iteration. But in this case, that's not true. So we're simply going to return random.random to send back a random number. So random number in this case is going to be equal to that. Print that to the screen. The next iteration, so we're going to increment counter to 1. Are we at the end of the list? The answer is no. Return another random number. Print it. Increment counter. Are we at the end of the list? No. Return another random number. Print it. All right, here we go. Now, this should be the end of the road. Our counter is then going to be set to 3. Are we at the end of the list? The answer is yes. So we're going to reset the object to -1. Then we're going to raise an exception called stop iteration, and that will exit that iteration. This is an example of creating your own custom dictionary class that basically provides the fundamental iterate abilities of the native dictionary class. Here we have our constructor that's just going to create 2 lists, one called keys, one called value. We have a private method called getKeyIndex, which will go through a list and return the value at a specific index. Set, which will set a key value if it exists. If not, it will append the value to those 2 lists. The keys method will return a list of keys that you have above there and that attaches this dictionary. The get method will get a specific key index pair. Now, we want to add the ability to iterate in this class. So this version of the class, you can iterate through the keys, but you can't iterate through the pairs. But this one, you can iterate through them in pairs by us simply implementing the iter method and the next method. And we're basically doing the same thing. We've added a current iter index, set that to -1 when the object is created, and then we iterate it through it the same way that we did in that simpler example. So creating your own iterators in Python is extremely simple. All you have to do is implement 2 methods and make sure that you keep a counter of where you are within your iteration and just reset the object and throw an exception when you're done. What's up, Wibbiters? Coming back at you again in the Programming in Python course. In this lesson, we're going to talk about modules and packages. Python modules. So we've been making modules this entire time, believe it or not. A Python script file is actually a module, and code that uses a module just uses the import statement to import that module. So here we go. In this simple example here, I have a simple math.py that just defines a couple functions: add, subtract, multiply, divide, and it just performs the appropriate mathematical operation for those methods. And as long as myscript.py and simplemath.py are in the same folder, or it's within an importable path, I can just do import, and then it's just the name of the script without the extension, and I have access to that. So if I do import simple math, then I could do simplemath.add. So it's basically treating that script as if it was an object. So simplemath.add xy will allow me to have access to that function. So a Python package is a little bit different, a little bit more complicated, but not really. A package is a collection of modules that's inside a directory, and that contains a specific structure. So you would have a directory, which is the name of the package. You would have an underscore init __.py, which initializes the package, and then the different modules that belong to that package, which will just be independent Python scripts. We're going to create a simple package called download file, which will allow us to download a file over FTP or over HTTP. So here's how the directory structure is going to look. I'm going to create a directory called download file that will have my init Python, and then an FTP.py, and then a HTTP.py. The init script can just be blank. It's required for Python to recognize this directory as a package. You can put some instructions in there, but a lot of times that's just blank. This ftp.py is just going to simply import FTP from the ftp lib package, and all that it's going to have is a function called FTP that just you scope into a remote file with a username and a password, and it's just going to parse out the server and everything. It's going to connect to the host. It's going to log into the host. It's going to change the directory. It's going to retrieve the file, and then it's going to quit, and it's going to return the path to the file on the file system. HTTP is going to import from urllib.request, and what it's going to do is it's just going to do a URL retrieve, and we'll download a file from the internet, and it will return back the file path where it's located on the file system. So here I'm on my Windows machine. I have c:\whippet.net, and I'm creating a folder called package example, and inside here I have download file, the directory, which contains my package, and then a Python script called driver.py, which is going to make use of my package. So what I can do is I can say from download file import ftp, HTTP, and I can do ftp.ftp. I know it's redundant, and then I can just go download ftp.mozilla.org/readme, and then I can go to http://whippet.net/images/logo, and I'll download those files to this particular machine, and there they are. So why do we need to do this with this all redundant thing? This seems redundant. From file download import ftp, HTTP. That's going to go to the download file package, and it will import the FTP and HTTP modules, which are the Python scripts. So the ftp.ftp notation is inside of the FTP module execute the FTP function. So can we make this shorthand? Can we make this simpler? A simple way that we can do this is by importing all the code in the __init Python file. We can import this differently in our init file if we want, just to kind of shorthand this a little bit. So I can import from download file import FTP, import FTP, and then some developers will use this technique where they just create like a sort of like a wrapper function. So we'll define a function called FTP download that will call ftp.ftp and then whatever parameters, and HTTP download, which will do the same thing. So now our driver code is a little bit prettier looking, so we can import FTP download and HTTP download from download file, and then we could just call those functions like this. So you can see that creating your own packages in Python are pretty simple. I mean, a module is just a script, and then we could just use a directory with a file called __init to let Python know that this is a package directory, and then we could make use of anything inside the init file, or create different modules that the init file can then pull in and wrap or display differently, or there's a million ways that we can do it. So Python packages and modules in a nutshell. Hello and welcome back to Programming in Python from Weebit.net. Let's do a very short discussion about multi-threading in the Python language. So in Python, there is a package called threading, and that allows for threads to be created within Python code. And let's talk about the thread class. The thread class constructor takes two parameters, the target, which is the function that the thread's going to run, and then arguments, which is a tuple that stores the arguments for that function. So here's an example. So we have thread target equals function to run, and that will be running a function as a thread without passing any arguments. We could also have function to run, args equals arg1, and then arg1, arg2, arg1, arg2, arg3, so on and so forth. The thread class has a method called start, which actually starts and gets the thread up and running. IsAlive is a method that will return a status of true or false if the thread is running or not. The name field will return the name of the thread. So here we go. So from threading, let's import thread, and then we'll import the random package as well. So let's create a function here. So we'll do def thread function, and we'll just print thread running and then a random number. Why not? So thread1 equals thread, and the target is going to be thread function, and then thread1.start, and then thread2 will do the same thing, thread2.start, and we can see that we just created two threads that ran concurrently. Almost concurrently. Now, if we wanted to pass in arguments, here we go. So we can have another one here. We have thread function that takes in a parameter called myThreadName. So when I create thread1 there, I have target equals thread function, and then args equals a tuple of thread1, and since there's only one parameter, I'll just have a comma at the end. The second one is thread2, so we can see that thread1 runs and then thread2 runs, but the thing to get out of this is that we were able to run a function as a thread and pass it an argument. So there really isn't all that much to multi-threading in Python. All that we really need to do is define a function that we want to run as a thread, and then any arguments that we want to pass in as a tuple. That's it. Let's run through a really quick video where we can talk about some of the advanced mathematical operations that are available inside of Python. Python is used an awful lot in scientific situations and engineering situations, so that's why I wanted to make sure that we went through some of the advanced math features of the language. So Python and math. Python carries a reputation for being very math-friendly. Formulas are easy to write for non-computer scientists. Many of the math operations use the advanced math functions from C. Since the syntax is easy and there's no compiling involved, Python is a more accessible way of accessing those C functions. This ease of use for complex math, simplifying complex mathematics, is one of the major draws to this language for the math, science, and engineering communities. The math library is an importable library that allows Python to access the C standard math functions. It is simply imported by doing import math. Once imported, the functions are used in a very similar way that we do in C. And if you would like a complete listing of the functions, go to this link here. We're just going to talk about some of the more common ones. So math.ceil is going to return the ceiling of a floating point number. So if we were to pass in 99.9, the ceiling of that is 100. Copy sign will take in two numbers, and it will return x with the sign of y. So if you were to pass in 79 and negative 20, 79 will have the sign of the second number, which will make it negative 79. Fabs is the returns an absolute value of x, so math.fabs, if we send it negative 20, it's going to return 20. You know how we wrote our own factorial function? Well, you don't have to do that in the math library. There is a factorial function for you. So it will return x factorial. So here we go. Math.factorial3 will be 6. Math.floor will return the floor of a value. So if you had a number, a floating point number like 3.98, that will return the low number within that real number, which would be 3. Fmod will return x mod y. So if we were to do 10 comma 4, 10 mod 4, that would be 2. Fsum returns the sum of a list of numbers. Now we wrote one of these earlier in this tutorial series, right? So we wrote our own add numbers function. Well, MathLab already has that for you. So trunks will truncate a number to a whole number. So if you have a real number like 10.55, blah, 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 it will truncate it to be the integer of 10. The exp function will calculate the power of e to the x. So if you were to do by 1, it would be 2.7. Blah, blah, blah. 2.71, blah, blah, blah. Remember that from the old, was it algebra? Math.exp m1 calculates the power of e to the x minus 1. So exp1 is going to equal 1.7 instead of 2.7. Math.log or math.log x to the base will calculate the natural logarithm of x. So math.log 75 is going to equal 4.3 and some change. And then math.log 75 to the base of 4 will return the value of that. Math.log 1p will return 1 plus x base e. So 74 will equal 4.3, blah, blah, blah. Log 10 will calculate the base 10 logarithm of x, which is the equivalent of x comma 10 in the log function. So log 1075 will be 1.875. Math.pow has the power function, so we could do a base to an exponent, so 2 to the power of 7, 128. We can also do square root, so math.sqrt 49 will be 7. You could also do a square root using the power function if you want. That would be x to the 1/2. Then we have our trigonometry functions, our cosine, tangent. We can calculate the hypotenuse of a triangle, which returns the value of square root x times x plus y plus times y. That's the Pythagorean theorem. We have our a cosine, our arc cosine, our arc sine, arctangent in radians. We could also return degrees, so it converts an angle x from radians to degrees. Radian x, so it converts an angle x from degrees to radians. You can see that if you have if you have kids or if you're in school or whatever and you have trigonometry homework, teach your kids how to do this. Like, have them do their trigonometry homework and then write a program that does it, because it's awesome. We also have the hyperbolic functions, so we can do return hyperbolic cosine, hyperbolic sine, hyperbolic tangent, the inverse hyperbolic cosine, inverse hyperbolic sine, inverse hyperbolic tangent, all this kind of stuff. Also, math contains the value of pi, a precise version of pi, so math.pi, and a precise version of e, so math.e. Wow, that was a short intended just to like, hey, look at all this cool math stuff we can do for Python. So those are the fundamental advanced math functions and fields that we could make use of in Python. Hey everybody, welcome back to another Programming in Python lab. Kevin here from Whippet.net. And what I want to do in this lab is have a little bit of fun writing a simple Python web client where we're going to actually run out and connect to the Whippet.net REST API and list the Whippet.net courses just to get ourselves grounded. Let's go check out the Whippet.net API. So I'm going to launch a web browser here and go to https://api/v1/courses. Now what this will do is return a JSON array that contains basic information about the Whippet.net courses. So what we want to do is just kind of take this and parse it and present it to the user in Python using a very simple console application. Now, one of the things that you'll probably notice that we haven't really talked much about JSON. We've mentioned JSON, and we'll talk a little bit more about it later, but let me just real quick, I'm just going to run out to a cool little website here, jsonprettyprint.com, and I'll just kind of select all, copy, and then paste them in this box here and pretty print it. So this is just a nice, prettier version of the JSON that we were looking at. This one's obviously unformatted, and this one is formatted. So you can see that we have an array of objects, and the objects just have fields. So we just want to write a program that will get this, go for each one of these objects, and just print the information to the user. So let's do that. Now, there are many ways that we can create an HTTP client in Python, but we're going to use one that I like and that works very, very, very well. So let's create this, just call it Whippet courses.py, edit with Notepad. Sweet. Let's get our command prompt up. Python, blah. Cool. Awesome. Super duper. All right. All right, let's get introduced to a couple of simple things here. The first thing that I want to import is the HTTP module.client. So we're pulling in an HTTP client. Now, what we want to do is actually call that service, and let's just simply call it and get the results, and also add some very simple error checking in here. What I want to do is create a connection. We'll just call it con and have that equal to http.clients.https connection. And I'll show you why we're doing it this way in a minute. www.whippet.net. So that'll open up an HTTPS secure socket connection to our server. Then we'll do a con.request. Now, those of you guys that follow the C# class, you saw us build a web server. So you should be a little bit familiar with the message type. So we're going going to do an HTTP GET, and we want to get the resource /API/v1/courses. Not VI. V1. Excellent. Now, once we open up that request, let's actually call the web server. So we'll do create a variable here called response, or resp equals con.getResponse. And then let me do a con.close. Now that should run. Let me actually see what that does. And it ran. Fantastic. Now let's take a look at it. Let's do a print. The response object has a method on it called read. So this should show me the JSON result. Fantastic. So as you can see here, this is the JSON result. Now, one of the things that's important to keep in mind is that Python is going to return back a byte array. So like, let's say you wanted to get a resource that's a file or a picture, it'll come back as binary. Now, how do I know that? Well, in the read method, I can just pass 10, which will just read the first 10 bytes, and you'll see that it has the notation for binary. So this is definitely binary. Now we have to keep that in mind. We're going to work with that in just a minute. Now let me do something. Let me actually give it something that is a bad request. So I will remove this. And this should be a bad request. Now we actually got a HTML, but if I actually were to take that out, you'll see that we're going to actually get a response from our web server that says that you just sent me a bad request. So we responded back with a 400 bad request. Let's see if we can capture that bad request and prevent it from actually trying to parse anything. Let's see if we can capture that bad request and prevent it from actually trying to parse anything. So what we'll do is, there is a status, resp.status. This is just the status code of the HTTP result. You see that this returns a 400, which is a bad request. Now, a proper request will return a 200, as you can see here. So let me make this a bad request again. Now let's just make a little simple if statement here. We'll just check to see if it is not a good result. If the status does not equal 200, we'll assume that something bad happened, and we'll just say print error, and we'll just print out what the error message is. Now the response object also has a property response called, well, it has status, which is what we've seen before, and then response.reason. So that's the reason for the error, and we'll do a con.close and then an exit. We run this. Cool. So it says error 400 bad request. So error, this returns the 400, and this returns the message, which is bad request. Closing the connection, exiting the program. We put this back here. Excellent. Now that worked. Now, how I said before, HTTPS connection, let me change this back to HTTP connection. Now watch this. We are going to get a 301 permanently moved response. Now that's our web server saying we don't allow non-secured connections. So if you try to give us a unsecured connection, we're going to tell your browser to redirect to a different URL, which is the HTTPS URL. So that's the reason why we're doing the HTTPS connection. Excellent. So now we've solved the problem of, okay, we have an issue and we're going to deal with it. Now, once we get down to here, we're in good shape. Once we get down here, that means that we have successfully returned the JSON result. Now let's store that as a string, because again, right now it's bytes, but I want to work with this as a string because I'm going to show you how we can take this JSON string and parse it into a Python object, and we can work with it as an object. JSON is a serialized representation of an object. So let's check this out. We'll do courses, JSON string, set that equal to response.read, which is what we did just a moment ago. So we're going to read the result, .decode. We learned this in the string lesson, and decode it to UTF-8. So this will be a UTF-8 string. Now if I do a print courses JSON string, this is the string representation of that JSON object. So you can see it's all muckily and complicated and scary looking, but in just a moment, it's not going to be. So you can see that there is no binary notation here. It just starts as an array of objects. Now let's take this string and let's actually store it as a Python dictionary. Python has a JSON module that we can use. So let's do import JSON, JavaScript object notation. So we have import JSON, and the way that we can make this a native object in Python is, let's just create a variable called Ribbit courses and set that equal to JSON.loads Now the .loads method will take this object and it will store it as a dictionary. Now how do I know it's a dictionary? Well, I'll save that here and let's actually run the program, and we're printing out a dictionary. It's very easy in Python to convert to a dictionary and then take the dictionary and convert that back into a JSON string. And the way that you would convert that back into a JSON string is by calling the dumps method. We have this here. Now let me just for kicks, I'll do JSON.dumps, and that should take it back to a string. So if we wanted to store this in a text file or something, or post it to a web server, this isn't a format where we can do that because this is a string. All right, so let me undo this. All right, now what we want to do is check to see, well, how many courses there are. We're going to tell the user how many courses there are. We're going to tell the user how many courses there are. So let's just create a simple variable. And actually, at this point, we've already read the response, so we don't need to keep the connection open anymore after this line. So let's read the response and let's just get the number of, let's store the number of Wibbit.net courses into a variable. We'll call it num Wibbit courses. Set that equal to len, which will give us the length of this list, and it'd be length of Wibbit courses. Do print, and let's just say to the user, Wibbit.net has num Wibbit courses. Exclamation point. Cool. Wibbit.net has 8 courses, at least at the time of this recording. Fantastic. So we do have 8 different objects inside of this JSON array. Now, let's traverse that JSON array in our Python program, and it's very, very easy. We've gone through the whole concept of using for loops and stuff already, and that's all that we're going to do. We're going to do a for, we'll just do I in, and we'll create a range, and we'll set the range equal to, we're starting at 0, and we want to go to the length of num courses. So if I just print I, we should get 0 through 7. And we don't, because I need to put my colon at the end of my expression here. 0 through 7. Wonderful. Let's just create a variable where we can just store the individual course that we're looking at, and we'll just call it Wibbit course, and we'll set that equal to Wibbit courses sub I. So now we have the individual course. Now let's just write the title out. So since this is a dictionary, we're going to be referencing the keys as strings, so it's very easy. So we'll do a print Wibbit course, and we'll reference the key of title because the JSON object has a field called title, and we're going to grab that. And there's the title of all the courses. Pretty cool, right? That's pretty awesome. Let me also, just for kicks, I'll add an extra new line at the end of this top one so we could separate the number of courses and then the name of the course. Now, just to kind of finish this off, let's get some simple pieces of information about the course. Let's get some simple pieces of information about the course. So let's get the, let's see here. Let's do a print, and we'll tab this in so that it doesn't look, here, watch this. So we'll tab this in, and we'll say Wibbit course, and let's get the URL to the course. URL. So we have the name of the course, and then the URL to actually view the course. Awesome. So we have that, and let's say number of lessons. Why not? Num lessons. And if you look at the JSON object, you'll see that there is a field here called num lessons. So let's take a look at that. And let's see, what did I do wrong? I was saying that this is an integer and we can't, okay, that's not a problem. We could either convert this to a string by doing str like this. But just to make this cleaner, we'll just put a comma here and a colon here. And instead of having spaces, let's make the sep equal to a tab character. That way it's nice and tabbed out. So we have the name of the course, the URL to access the course, and the number of lessons that are in the course. So not a bad start. Now let's get a couple of other pieces of information, like let's say the number of videos. Now the JSON object, you can see, has a property or a field here called num videos. Let's present that to the user. Awesome, the number of videos. And let's do the number of views. And the object does have num views, or just views. There it is right there. Cool. So we can see all the Whippet.net courses and some very simple information about them. Now, this also has, let's take a look at this because this is kind of cool and fun to work with. It has a total running time in seconds. So the total running time in seconds is the number of seconds that the course is. So that's basically taking every single video in the Whippet.net course and how many seconds it is and adding them all together to get a total running time. Now, seconds are a great way to store data because it's a single number and it's convertible into numerous formats. So let's say that we want to present to the user the running time of this. So we have this total running time in seconds. So let's make use of that. Up here where we print out the course, let's do a paren. And then in here, we'll do a Whippet course. And I'm going to go back and steal this. Total running time in seconds. And we'll implant that here. Let me back up a little bit to make this a little bit easier to see. Cool. Okay. And let's see, what do we got? Okay, looks like, all right, we'll have to convert this to a string because Python's getting angry that I'm trying to do concatenation of a string and a number. So there we go. Now this is not a very, we could tell people, oh yeah, this is a 4,307 seconds long, or this is 70,179 seconds. Not that many people off the top of their head are going to actually know, what the breakdown of that is in terms of hours, minutes, and seconds. So let's do it. Let's write a quick function that will do this. So let's do it. Let's write a quick function that will do this. Now, again, I try to give a little bit of extra information in the lab videos, and what I want to do is introduce you to a function that we did not talk about in the slides. And the function that I want to talk about is the div mod. And what the div mod function does is it takes two numbers as an argument, and then it returns a pair of numbers that consist of their quotient and their remainder. Now, what's the benefit of doing this? So I can say, all right, we'll take these two numbers, and I want the whole number here, and then I want the remainder here. So it's basically a simple way of doing long division, I guess, and having your remainder separate from your quotient. Why would this be usable? Well, what we're going to do now is write a quick function that will convert seconds into a more human-readable format. So when we do stuff like we take in a total number of seconds, and let's say we want to get the number of minutes and the number of seconds there are. Well, what I can do is get a calculator here. And let's just say something is, 500 seconds. Now, if I want to get, I can divide that by 60, and I can get, 500 seconds is 8 minutes and 0.33333. So 0.33333 is my remainder. Now, the remainder of that would be the number of seconds. Now, that 0.33333 minus 8 times 60 is 20 seconds. So that's actually 8 minutes and 20 seconds. Now, we'll do the math real quick and see if I'm correct about that, but we'll do the math using the div mod function. So let me just, above all this stuff, let's just do a quick exit here, and let's just play around for a second. Just make sure. Okay, cool. Let me do this. Let me do, let's see, print, and inside of here, I'm going to do div mod, and what did I say, 560. So let me see what this returns. This is going to return a tuple or a tuple, depending on how you feel like pronouncing it. I go either way. I prefer tuple because I believe that's how it's supposed to be pronounced, but everybody kind of says things their own way. You see how I calculated on the calculator 8 minutes and 20 seconds? Well, just by simply using div mod, I just very quickly and very easily did that mathematical operation where I divided 50 by 60, and then I got the remainder back. The remainder in this case is 20. So 50 divided by 60 is 8 minutes and 20 seconds, right? 8 minutes, the remainder of 20, which would be 20 seconds. So if I wanted to get a number and I wanted to convert that into, let's just say, hours, minutes, and seconds, it's actually very, very simple. Let me write a quick function to do that. So we'll create a def, and we'll just call this seconds to human time. Why not? And this will take in seconds as the parameter. Now that I have this, the tuple, this also might be something that we haven't talked about. And actually, before I continue, I'm going to go back and do this. This is something I don't believe we've talked about this, but I think this is really good to know. So when I do this, you saw that before when I printed this out, the tuple printed out in this case. Now, in Python, this is really cool. If I wanted to set one variable as this value and one variable as this value, I can simply do this. So let me do minutes, comma, space, seconds, equals, and then I can do Now the quotient will be the very first one, and the remainder will be the second one. So watch this. So if I do print mins, I get 8, and then if I print sex, not that sex, but SECS, I get 20. So you can see very easily, I can store these two as individual variables. So let me go back to my, let me go back to writing my function here. So we'll do def seconds to human time, and this takes seconds. All right. Now what I want to do is I want to store the minutes, and seconds. So I'm going to override my seconds as divmod, and the divmod is going to take the number of seconds and 60. So the results of this, I will have how many minutes there are and how many seconds there are. Now I could have a very long number of minutes. So if something was, 47,000 seconds long, I would have several minutes and a few seconds. Now what I want to do is also be able to translate that leftover minutes into hours. And then the remainder of that I want to store as minutes. So here's how I can do that. I want to have the quotient be hours and the remainder be minutes equal divmod. And what I want to do is minutes by 60. So at this point, I have the number of hours, the number of minutes, and the number of seconds. So let's return a format string. Now what I want to do is just create a quick and very simple format string. We'll do %202D, which means that we'll be padding it with, it has to be 2 digits and padded by 0, colon, %2D, colon, %2D. So what we're going to do is have hour, colon, minute, colon, second, colon, and the values here will be a tuple of hours, minutes, seconds, and let me run this without calling it just to make sure. Okay, great. So there's no syntax errors. So let's call this. So let's do this. Let's do print, and we'll call this seconds to human time, and we'll just send it, I don't know, like the example we had before, 500 seconds. And you can see that that is 0 hours, 8 minutes, and 20 seconds, but I think I have a problem. %02D, %0. There we go. So now it'll be 0820 seconds. Now let me make this 5,500 seconds. So you'll see that's 1 hour, 31 minutes, and 40 seconds. So that's pretty cool, pretty simple, and pretty cool. So just to conclude this, let me cut this and simplify my life. We'll zoom back out and scroll down here to where we have this, and I'm going to replace that string function with this. So now what we should see is the final product. There we go. Check that out. Whippet.net has 8 courses. Introduction to Computer Programming is this long. It exists at this URL. It has 13 lessons, 43 videos, and it has 2,200 and whatever views. And then programming in C, object-oriented C++, Objective-C, Java, C#, Introduction to Scripting, and coming soon, programming in Python. So this is a very cool, very simple example of how you can use Python to do a very common and very useful function. Let's run over the code real quick, and then we'll call it a day. So we're going to import the 2 modules that we want to use, the HTTP client, which allows us to be an HTTP client, and JSON, which will allow us to take a JSON string and convert it into a Python dictionary, and take a Python dictionary and convert that into a JSON array. We write a simple little function here that will convert the number of seconds that we pass into an hour, minute, second notation, so it's easier for humans to read. We're going to open up an HTTPS connection to Whippet.net, and we're going to use that connection to send a GET request to the following resource, /API/v1/courses. And again, this is accessing the Whippet.net RESTful API, and this is going to return a JSON array of the different courses that we have for Whippet.net. The response object is going to be the results of this request. We're going to use a simple if statement to check to see if the result does not equal status code 200. So status code 200 is the okay, continue, everything's fine. And if it's not 200, we're going to assume that there's a problem because we didn't get the result back. And if there is a problem, we're just going to write out to the user error, the status code that was the error, and the message sent back from the web server, close the connection, exit the program. If the program is successful, we're going to take that response object that we got, we're going to read every single byte on that response. So this will be a series of bytes that represents the JSON object. Now we want to treat this as a string inside of our program, so we're on the byte object, we're going to call the decode method, and we're going to decode this into a UTF-8 string. So at this point, we have this stored as a string, and we no longer need that connection to be active because we've already connected, we've already read what we need, close it. Now, once we have this JSON string, we're going to use the JSON module called the loads method and pass it the JSON string, and that's going to return us back a dictionary containing the result. Now, in this case, this result is an array, so we're going to be running through this array. So it's going to be an array of dictionaries. Now, we're first going to check to see what the length is. Now, we know that this is going to be an array going in because I'm telling you right now it's going to be an array. We're going to check the length and just kind of store that as a variable here. So number of Whippet courses. We'll let the user know the number of courses that there are, as we can see here at the top of the output. And then we're just going to iterate through each one of the courses. We're going to create a for loop in a range, and the range will be from 0 to the number of courses. So for those of you guys that remember C, for int I equals 0, while I is less than non-Whippet courses, I++. It's effectively the same thing. Just going to create a variable called Whippet course and store that Whippet courses index as Whippet course. We'll tell the user what the title of the course is. We'll give them a nice human readable version of the hour, minutes, and seconds of the length of the course. And then we'll just tell them the URL where they can access the course, the number of lessons, the number of videos, and the number of views that the course has seen. So I thought that this is a pretty fun example. I hope that you guys get an opportunity to play with this and mess around with some other stuff. Happy coding! Hey guys, Kevin here from Whippet.net, and we are about to do another exciting lab in the Programming in Python course. In this lab, what we're going to do is show a sort of practical example of using Python as a script to do a dirty job to run through and parse out a log file. So here's kind of the simple use case. Here's the example project. Let's just say that you as a new developer at company XYZ was handed down this project. It's your first day on the job. Your company implemented some sort of financial process that started running on September 9th, 2007. Now, let's just say, just for the sake of a backstory, this is a process that selects information from a database and it reconciles, charges for your business. So let's say there's money involved here. So that's why it's such a big deal and everyone's all up in arms about it and they need you to help them. Somebody was going through the server and found a log file. Now, this log file, as you can see, is 600-ish megabytes. That's a pretty big log file. This is not something that you're going to want to read as one slurp and then split on the new line and then read each line. This is something that we're going to want to just parse through one line at a time. You've called the vendor and they've told you that if there is an error in the line, it will have all capitals error with a colon in it. Now, the format of the log file, let's just say, for example, is the date stamp, then a tab character, and then the log. So in the event that there is an error, there's going to be an entry that's this. Something like this. So what we want to do is write a Python program that will read this in one line at a time and then try to find each one of those error logs. And then each time that we find an error log, we'll just go ahead and write that to another text file. Sounds simple enough, right? So let's do that. So let's do that. Now, we're going to try to encompass a couple of simple things here. So let's first start off by accepting a command line parameter to be the input file that we want to work with. So in this directory here, I'll just go ahead and create our new Python script, and we'll just call this logparse.python. And let's open this up in Notepad++. Excellent. All right. So the first thing that I want to do is accept command line input. So let me run out to desktop, Python, log file lab, Python, logparse.py, sweet. So what I want to do is get a file. So we'll do, what was it? It was event.log. So what I want to do is actually capture that input. Now we remember that we can do, let's just do first an argc equals len sys.argv. And as you guys know, we're going to need to import sys. So if I save that and run it, excellent, we have an argument count. Now, we know if we do a print argument count, we see that that equals 2 because we have these two parameters. So let me just go ahead and pull this back. And 1 is the parameter. And that's actually the name of the script that we're running. So if this is not equal to 1, so let's do that real quick. So let's say if argument count does not equal 2, then I want to tell the user, so let's do a print. We'll say error, missing, inputs, file. That's good enough for me, right? And then exits. All right, so let's go ahead and run that and see what happens. Error, missing, input, file. Wonderful. Now, just to kind of practice some other stuff that we can do, we'll make this equal to file sys.stderr. That way we'll write this to standard error. Wonderful. Not that there's a difference at all really running on the command line here, but we can see that this is writing the standard error because this is telling us that. Okay, so if we do have 2, that means that the very first one is the input file. So let's do a print. I'll do arg sys.argv, and then if I do sub1, that should, oops, I'm sorry, I have to actually put the event log in there. So that tells me that the file that I'm pulling in is event log. Cool. Now, one thing that we do want to check is to see if that file exists. Now, one thing that we do want to check is to see if that file exists. So we want to make sure that we do this nice and clean. So let's do a if file exists. Now, there is another module that I want to import, and this module is going to be called OS. The OS just has some really cool operating system level stuff. We can do stuff like see if files exist, run command line calls, and that kind of thing. So what we want to do is now check to see if that input file exists. No problem, right? This is pretty simple. So we'll check to see if not, and then we'll do os.path.exists, and this will give us a Boolean response, whether that exists or not. So if the file does not exist, then let's tell the user, we'll say input file does not exist. And so here I have event.log. Let me do event.no.log, which no means it's not there. So input file does not exist. Wonderful. So now if we run this if we take the no out, the program functions as we would expect. So at this point, very simply speaking, we've just checked to see if the number of arguments that have been passed in by the user are the number that we're expecting to see. And if they are, we're expecting the very first parameter to be the input file that we want to read. And if the file, for whatever reason, does not exist, we want to tell the user and then exit the program at that point. So we are now at a point where we can start to do some interesting stuff. So one of the things that I mentioned that we have to do is we want to push this out to another log file. So let's just take the name of the input file and we'll just add the file extension .err to signify error file. So let's just create a variable called error report file path, and we'll set that equal to the sys.arg1, and then we'll append to that .err. Let's print that out. Okay, check it out, check it out. Cool. So this will be the file that we actually write our error log to. So this thing is starting to write itself. Now, just for good measure, let's do this. Since we could potentially have tons and tons and tons of errors, we don't want to store any of these results in memory. We want this program to be as light as possible. I'm going to read in a single line at a time from my big, gigantic 600 megabyte log file that's been accumulating logs now for several years, because in 2007, nobody seemed to prune the log or anything like that. So we want to keep this thing light. So I don't want to keep accumulating the error logs just in case there are tons and tons of them. So let's just make sure that the file that we're about to write to has been completely eliminated from the disk. Pretty simple. So we'll do this thing again where we do the if the os.path.exists. Only thing that's different is we're not going to do a not like we did up here. So we're going to check to see if this file does exist. And if this file does exist, I want to delete it. And the way we can delete this is os.remove. And then I'm going to remove the error report file path. And let's see here. If I run this, everything should be fine. And even though it doesn't exist right now, let's just do a quick test. Let me just create a file here. And I'll just call this events.log.err. And what should happen is if this program is working as expected, when I run this program, that file should disappear. Let's see. And it did. Fantastic. So the program so far is working as we expect it to. Now that we've kind of cleared the error report log file, let's create a file handle to that location. Now that we've kind of cleared the error report log file, let's create a file handle to that location, and it's very simple. I'm just going to declare a variable called outfh, just simply out file handle, and have that equal to the open function. I'm going to do an open to the file that we're reading, which is the input file that came in from the command line, and I want to open it. I'm sorry, I said that wrong. I want to open the error report, because that's what I'm writing to, and I want to write that as append. So every time that I write something to it, I want it to append to the bottom of the file. And then just for good measure, just so that I don't forget later, I'll just do a .close and close the file. So now if we run the program, see if I do a dir, you see that there is a log file here. And then since I opened it and I didn't actually write anything to it, it just created a blank file. So a blank file is there, but we'll fill it up with data here in just one sec. So let's go ahead now and start read the file one line at a time. Why not, right? We're at that point now. We're actually ready to do this thing. Now, I'm going to introduce you to something that we did not talk about in the slides. Now, you know, those of you guys that do like to watch the labs, you know that every once in a while we like to give you a little nugget of information that the slides don't go over to kind of give, you know, an incentive to actually watch these, what can be somewhat boring and drawn out lab videos. So I'm going to introduce you to the with statement. Now, those of you guys that remember us using C# and we use the using statement when we were working with file streams or network streams, and that would handle, you know, freeing up any unmanaged memory, calling dispose and close on the back end so that you didn't have to actually do that. Now, with the with statement, it kind of functions the same way. Here I have the file handle open. I'm doing this manually and I'm closing this manually. Now, what I'm going to do is I will open the input file using the with statement, but I won't actually close it. Watch this. Let me show you. So let me do open, and I want to open up the input file, which is the argv sub1, and I want this to be referenced as f within the scope of this block. Tab in. Everything that then belongs to the with will have access to this variable f, which represents this file, which has been opened. I should be able to, if I just pass this, I should be able to run this, and it worked. So basically, it just opened up and closed the file handle. So now that we're at this point, all that we have to do is start to read in each line one at a time. Now we can do this very easily by doing for line in f. So we're basically iterating for each line. Let's just simply just do a print, and then I'll print line. First off, let me print, watch this. So we'll print quote line quote, and we'll run it, and maybe we'll have to do a quick break. So, ooh, look at all these lines. So you can see that this log file contains a bunch of records that say stuff like processing record blank of blank. And there's tons of them, as you can see here. These are all from September 9th, 2007, and none of these are reporting an error. All this looks pretty clean. Now, one thing that you'll notice, though, as we do this, reading this in by line, you see that the new line is captured. And the reason why we know this is because we have the quote here and the quote here, and at the end of this, there is no quote, so there's a new line that brings this quote down here. So for those of us that have been paying attention, we can do an R strip, just like we talked about in the console input-output. And here we go. So now it's nice and sort of in balance. What we want to do is check to see if we can find an error message. Now we have, like we said before, this is the timestamp, and then between these two is a tab character. So it's timestamp, then a tab, and then the log. And we were told that it will be in all capitals, error, : if the log message is an error. So what we want to do is let's simply just check for that. Now, as you can see, we're reading this file in one line at a time. So even though it's a huge file, I mean, I could run this, and let's run out and let's actually look at the system performance. As I look here at python.exe, you can see that my memory is hanging pretty low. You know, we're reading a 600 megabyte file, but we're not jumping above 2.8 megabytes. So that shows us that we're not reading the entire log file in at a time, which is good. When you're working with data of this size, that's how you want to handle this. If I were to read this all in at once, if I were just to slurp it in, there's a chance that the program might crash or cause a significant drag on the system if it doesn't crash. Now, we're going to go for each line. I want to check to see if line comes in as a string. And what I want to do is find, which is basically an index of, we want to check to see if we can find the tab character and then error, : and if we find this, then that means that the index will be greater than or equal to 0, because it can be 0 or greater. 0 meaning at the beginning of the line, which we know, and based on how this log file looks, that will never happen. But just to be safe, we'll have it set up this way. So if we find tab error colon, then let's go ahead and print out to the user. So we'll just say print, and we'll print a line.rstrip. That way we can just tell the user, whoever's running this, hey, this is what's going on. And then we have out file handle dot write, and we'll write line. Now, when I write the line, notice how I'm not going to do the rstrip because I want that new line to append at this point. Because when I do dot write, I'm not actually adding a new line just in itself. Since this contains a new line already, I'm just going to leave it in there so when I open up, they'll all be separated. When I open up the file, they'll all be separated by a new line. So let me save this, and this should be the final product. Just for fun, we'll do a CLS, and let's let it rip. Let's see what we can find. May take a while because it's a big file. All right, so cool. We found a failed to process this record, and on this day, no records were found. Failed to process, failed to process. So in this fictitious scenario, we're finding errors that can account for some money that might be missing. Maybe perhaps on this day, there was a problem with this record, and we'll basically be handing this over, hypothetically, to somebody that could work these errors. So we went through the entire 600 megabyte log file, and we pulled out all the errors. Now you can see there weren't that many. That's pretty cool. We went through all of this data just to find a couple of lines reporting an error. Not bad. It's actually a practical usage of Python in a sort of real-world scenario. So let's just real quick run over the code. So let's just real quick run over the code. Let me pull back. We can see it from a helicopter view. So we're going to import the modules that we want. In this case, we're importing the system module and the OS, the operating system module. Just checking to see if we got the number of arguments here that we were expecting. So we'll see what the count of the arguments are by calling the len function, which will give us the length of this array. And then we'll just check to see if it doesn't equal to, report an error, and then exit the program. If it does equal to, then we'll check to see if the very first argument, which is the expected input file, exists. And if it does not exist, then we'll go ahead and print an error, exit the program. Now, once we've gotten to this line of the code, we have the number of arguments that we want. The input file that we want to work on does exist. So let's create a file that we can write to. In this case, will be our error report file. So it's going to be, just because this is how we made it, the input file plus .err, which, as you can see, this is our error report. If this error report file already exists, delete it. Now that's just so that we can clean it out. We can stick our new data in there. Open a handle to the file. Now we could have used the with statement here as well. We could have just said with, open, and then tab over. But in this case, we didn't do that just because. And here, we're using the with statement. Now remember, kind of like I said before, those of you that are familiar with C#, it's not 100% an accurate comparison, but you could sort of think of the with statement in the same context as the using statement that you see in C#. So in this case, we're going to open this file. We're going to reference it as F. And then at the end of this code block, this file will automatically be closed. So while we have the file open, we're going to go for line in F. We're just going to go for each line of the file, not reading all of the lines in at once, one line at a time. We're gonna scrutinize the line. If the line.find, which is an index of, contains this character sequence, tab, all caps, error, colon. If it's greater than or equal to 0, that means it exists. Then print to the console the line plus an rstrip. Now, remember that the print statement does add a new line to the end of it. So if you didn't want to have the new line, you could just do something like this. You could do the end character could be equal to nothing. And that in effect would be the same thing, but just to kind of keep it how we had it. There we go. Pretty simple. Introduce you to a couple, using the string class a little bit more. Then once we print that out to the console, which we have here, then we'll take the record and we'll write it to the line with the new line character, which is not being stripped. And at the end of this, we'll close the file handle and we will have an output that contains on the console, this is all the errors that we found, and a log file that also contains the errors that we found. So I hope that you guys found this a fun, useful, practical lesson. Thanks for watching. Hello, my internet friends. Kevin here from Wibbit.net to do another super exciting Python lab in the Wibbit.net Programming in Python course. This lab was requested by one of our Facebook friends, and what it is a simple unit calculator. This is not going to be fully encompassing, but what I wanted to do was get across a couple of different types of methodologies that we can use in Python. I wanted to use reflection, so I found this as an excuse to use reflection and data normalization. Here is the concept. We're going to write a simple console application that will accept different input units of measurement. Now, for simplicity, I'm just doing measurement of length. So we will support millimeters, centimeters, inches, feet, yards, meters, kilometers, miles, and nautical miles. And what we'll do is be able to convert those into each other. Now, the way that I did this was I wrote a class that contained some simple methods, and then the logic will normalize everything into centimeters, and then the final conversion will be a centimeters to something conversion. You'll see what I'm talking about. Now, you could do this a number of ways. You could have a different function that will do each one of the different conversions, but I chose to do this just a little bit differently, a little bit non-conventional, because I wanted to just show a couple of different things. So data normalization is something that you may do in a software development project at some point in your development career. So it's good to have some exposure to that. So here I have my unit calculator folder. Let's create a new text document, and we'll just call this unitconverter.py. And we're going to, like I said just a moment ago, we're going to make use of a couple of different programming concepts here. What I want to do is, first, I want to write a class. Now, this class is going to function as our base for doing our calculations. Now, the reason why I want to do a class is because I want to create an instance of this class and be able to reflectively see if this class supports whatever conversions that we need to do. So let's give this a try. Let's create a class, and we'll call it unit converter. Excellent. Let me just go ahead and also get my command prompt up. Cool. All right. Now, what I want to do is add my 2 centimeter conversions. Now, like I said, here's how we're going to do this. We're going to take in 2 measurements. Let me just get a scrap document here. So let's just say we take in 10 inches, and I want to convert 10 inches to feet. Now, one of the ways that I could more easily, swap centimeters with meters with miles is to normalize the data into one format and then have a conversion into the other format. So the way that I would solve this problem using data normalization was I would take 10 inches and convert that into centimeters. And then I would take the centimeters and convert that into feet. That way I know that all of my input, whether this is miles, whether this is yards, whether this is meters, whether this is kilometers, this will be centimeters, and then all that I'll have to do is have a centimeters to something conversion. Otherwise, I can get myself into writing a lot of code that can satisfy every single circumstance. I have to write a kilometer to foot converter. I'd have to write a meter to foot converter. When I don't really have to do that, I just have to normalize everything as centimeters and then have centimeters to feet. And that reduces the amount of code that I have to write. Now, you could argue that it maybe makes it a little bit more complicated, but, in some circumstances, perhaps that's correct. But, this is a valid way of solving this problem, at least in my opinion. So you get the idea. Now, what I want to do is first write a 2 centimeter converter method for every single unit that we want to support. Now, let me make a quick comment here. We want to support millimeters, inches, feet, yards, meters, kilometers, miles, nautical miles. So these will be what we support in this particular example. So the first thing we want to do is create a millimeter to centimeter conversion. And you can just go to Google and search for these conversions. It's pretty simple. Let's create a method here, millimeter to centimeter, and we'll take in self and the millimeter measurement, and then we'll return back. This should be the millimeter times 0.1. And just to make sure that this is working, let's do a unit converter equals new unit. Equals unit converter. Let's do a print unit converter dot millimeters to centimeters, and I'll send in, let's just say 1 millimeter. And I forgot my colon at the end of my class here. Sorry about that. Okay, so 0.01, which according to Google is correct. As you can see here, 1 millimeter is 0.1 centimeters, and That's what we've got. So now let's create another conversion method. So now let's create another conversion method. So we have millimeters. Let me cross that off the list. Now we want inches, and the inch conversion is going to be approximately, now this isn't 100%, it'll be 2.54, and that's actually a slight roundup, but that's okay. We're not trying to be perfect here. We're not writing a program that will take us to the moon. We're writing a program to learn Python. Inches is done. Now let's do feet. Whoops, wrong button. Let's do feet. So the feet conversion is going to be approximately 30.48. And then let's see, yards. And the yard conversion is approximately 91.44. Okay. Next is meter. Meter, that's going to be times 100. Okay. Kilometer, 100,000. Okay. Next is mile. 160,934. And the last one will be nautical miles. 185,200. Now I did notice a small little thing here, my variable here. Let's just kind of make this more generic and just call it input. So I'll paste that across the board here. Maybe just do one of these jobbies. Replace mm with input. And I got to fix this one up here. Cool. Awesome. So let me save this and run it and see what happens. All right, so we do have an error on line 28, and that's because I have to fix my search and replace kind of screwed me over there. Cool, excellent. Let's see, so we have millimeter to centimeter. Now let's do kilometer to centimeter. Wonderful. So we'll say, let's say we're 91.54. How many centimeters is that? That's a shitload of centimeters. Okay, fantastic. So we have our base converter. Now what we want to do is be able to accept some command line input. Now what we want to do is be able to accept some command line input. Now, what I was thinking is something simple like this. The very first value can be our input value. So let's say 10. The second value will be the input measurement. Let's say it's coming in as feet. And then the output measurement, let's just say millimeters. This is what I would like to see because that's really simple to parse. Now, what we want to do is pull that in. So let's run up to the top of the script and let's import sys. And now right down here with this print is, let's start our program. But now let's also just go ahead and put some comments here so that the code doesn't get completely unnavigatable. Because, you know, for whatever it's worth, a lot of people like the Python indentation syntax. I'm not fond of it. I think the code kind of looks ugly. And for, you know, a lot of text editors, when you have stuff like this, where you have, you know, method, whatever, and then you have like 50 billion lines of code, I can click on this, and a lot of text editors will highlight the matching curly brace. And with Python, you know, it's just not as easy to do that kind of stuff with a lot of editors. So you live with it. You deal with it. It is what it is. Some people love it. All right, so now let's go down here, and I'll just kind of get this out of the way for now because we're going to be creating an instance of our class, but not this particular moment. All right, so now that we have the import sys, we'll do if the length of sys.argv. Starting to get really used to this by now. If it doesn't equal 4, now the reason why it would equal 4 is because this is 1, this is 2, this is 3. I'm sorry, this is 1, this is 2, this is 3, this is 4. So we want to have 4 arguments because the first one's going to be the script we're running. The second one's going to be the input value. The third one's going to be the input unit, and the fourth one's going to be the output unit. So if it doesn't equal 4, then I want to print an error. We'll just say error missing required arguments. And as for you guys, if you want, you can maybe create a usage function that will print out how this is supposed to be used. But anyway, so here we go. We have this. Pretty easy. Pretty cool. So we do have 4 in there. Now let me just to test this out, I remove the very last parameter. We're getting the error as we would expect. All right, so let's start parsing in those values. All right, so let's start parsing in those values. Let's create a variable called inMeasurement, and we'll set that equal to the float value of sys.argv sub1. Now, the reason why we have to set that as a float is because we're going to be doing math on this, and we can't do math on a string. We have to do math on a number. So we're going to throw that as a number. The in unit, we'll just set that equal to sys.argv sub 2, and we'll add a lowercase. That way we're normalizing everything to lowercase, and keep saying int. I don't mean int. And then out unit, we'll say 3.2lower. Excellent. Now let's do a little try-catch action here. Why not, right? This way, if we find an error, we can just throw an exception or raise an exception and be done with it. So let's just test to make sure that this is all working. So I'll do that and then accept exception as EX. And if an exception gets thrown or raised, we will just print out the exception, and it will be the string value of EX, and we'll make sure that we write this to file equals sys.std error. And you know what? I should probably do this up here as well. Okay, let's make sure that this doesn't blow up, and it doesn't. Fantastic. Now let's test our thing here, and we'll raise an exception. So we'll say raise exception, and let's just say testing. Cool, and we got our exception. Fantastic. Wonderful. So if an error occurs, the error will nice and politely display to the user. Now that we have a basic framework for our program, we're going to need to create the opposite of each one of these methods in order to fully support these conversions. All right, so let me just copy this and we'll put this here. And the opposite of the conversion is a division. So this will be centimeters to millimeters. And instead of multiplication, that's division. And this one will be centimeters to inches. Division. Feet to centimeters will be centimeters to feet. And I'll kind of explain one more time the concept of doing the normalization here as soon as I'm done this, because you guys might be thinking, hey, Kevin, you said that we're not going to have to create all these different conversion methods, but you're doing it anyways. Well, I'm actually not, and you'll see in just a second. Maybe some of you guys already do see, but I will, as soon as I'm done typing this like a madman, centimeters to meters, kilometers, this would be centimeters to kilometers, miles to centimeters, centimeters to miles, and centimeters to nautical miles. Now, one of the things to keep in mind is as you look at this list of methods here, let's just say we had an input of kilometers and we wanted to get miles. Well, by normalizing kilometers into centimeters, I then have a centimeter to mile conversion. So I don't actually have to make a kilometer to mile converter at all. I can just normalize everything as centimeters and then convert the different items into the different units from there. And let's see here. Line 56 looks like I took this out, didn't I? Okay. All right. So now that we have the class built and we have the framework of our application done, let's make use of some other concept to get this program written. Now, the way that I chose to solve this problem is maybe a little bit different than how you would do it. But what I'm going to do is just check to see if the input unit is centimeters, then I don't actually have to perform any conversion into centimeters because it's already normalized into the measurement unit that I want. But if it's not in centimeters, then I want to convert it into centimeters, and then I will convert the centimeters into whatever output unit that I want. So let's start this off. We'll just create a result. Now, result will represent the actual completed result of the math, the conversion. We'll check to see if the input unit equals centimeters, then all that I want to do is I'll just set the result equal to the in measurement because I don't have to do any conversion. It's already in my normalized format. Otherwise, let's do our conversion. Now, I wanted to use reflection to pull this off, and we're going to make use of a function in Python called getAttribute or getAttr. And we're going to use the getAttr function to extract the method from the class instance. So watch this. Check this out. This is pretty cool. So what I want to do is just create a string that will represent the name of the method. So we'll just call this centimeter method name and set that equal to in unit, and we'll concatenate that with to centimeter. So here's the logic behind that. If the in unit, let's just say right here, the in unit is feet and the out unit is millimeters, we are looking for a method called ft to cm. So if we go up here, we should see ft to cm. Now that means that when we actually run that, we will get this method back out of this class and we can actually call it. And if it doesn't exist, then we will get a bad result and we'll handle that exception or we'll handle that situation separately. So here we go. here's the name of the class. Now let's then see if we can actually get the method. So centimeter method equals get attr. And here are the parameters that I'm going to pass in. The unit converter instance, which actually I need to uncomment and bring back into my code. So we'll stick this here at the first line. Unit converter, and then the next parameter is going to be the string representation of the method. And then I'm going to pass none as the very last parameter. Let's do a print, and let's print out the CM method, and let's see what this actually prints out. Okay, so we have a, oh, I forgot my colon. I always forget those. Colon. All right, there we go. So you see that this actually equals something. Now watch, if I were to do, instead of FT, let me do FTQ, which doesn't exist. You'll see that the result is none. So that's kind of the same as void. Now we'll be able to check to see if that is none, then that means that this conversion is not possible. And we would have to create some FTQ to centimeters in order for that to be possible. What we'll do is, let's handle this situation right now. Let's handle this situation right now. And pretty simple. All we have to do is this. We'll just check to see if not CM method, then we'll raise an exception. And the exception will just say conversion is not supported. Run out to the command prompt and run this again, and you'll see we very cleanly get this error message. Conversion is not supported, and let's make this back to feet. And there we go. The conversion is supported now, and we know that because it did not throw an error. So now that we know that we can convert this into centimeters, let's go ahead and do that. So we'll make results equal. Now again, result is this value that will represent the calculation, the conversion. Let's do CM method. Now this is going to have a method on it called call underscore underscore call underscore underscore. So this is going to actually call the method. So this is in effect the same thing as doing this. So if we have converter instance and I want to do feet to, what was it, feet to millimeters? Is that what I had? Yeah. I would do this dot ft to mm and then a value, whatever, 1, 2, 3. In effect, this is the same thing. Just one of them is using reflection, one of them is not. So instead of doing 1, 2, 3, we'll do in measurement. So at this point, we've normalized the data into centimeters. If it came in as centimeters, then we don't do anything. But if it did not come in as centimeters, then we will find the method that will convert it to centimeters. And if it exists, meaning if it does not exist, we'll go ahead and throw an exception. If it does exist, we'll do the conversion. So let's do a quick print, and we'll just say results. Now, if I run this program, let's see here. 10 feet is 304 centimeters. Now let's check this out. Centimeters, 10. I want to do 10 feet into centimeters, 304.8, 304.8. Fantastic. So we've taken this feet measurement and converted that into centimeters. Now, the final product will be to convert the centimeters into whatever measurement that we want to get out. And again, this was just to do a shortcut method so that we didn't have to create a different method for every single different type of conversion that we wanted to do. Normalize into centimeters and then convert centimeters into the final product. And the way that we do this is we did create a list of input to centimeters and then the reverse, centimeters to input. So now what we want to do is we want to reflectively find this method, and let's do that. So we'll do a variable called convert method name and set that equal to centimeters to plus and then out units. All right. And then see another variable here called convert method equals get attr unit converter, convert method name, and then none. And we'll do just like we had up top, we had a if the input unit is centimeters. Let's also do a safety check down here because we don't want, we can do a centimeter to centimeter up here and just kind of cover our bases. But, just to be a little bit more cooler, I guess, we'll do if the out unit equals centimeters, we'll just do a pass and then we'll do an else. So if the output is not centimeters, we'll take this code and stick it in there. Hope that makes sense. Now, in the case where you're converting it into something else, here we go. We want to check to see if this convert method exists, just like we did before. Matter of fact, we could actually just copy these exact lines and we can paste them here. And all I have to do is change this variable to that variable. Now, if I run this, let's see here. So far, everything looks okay. So the very last thing left left to do is for us to actually perform the math. And the math is pretty simple. We'll just basically do exactly what we did here. So result will equal, but instead of the centimeter method, it'll be the convert method. And instead of measurement, it will be result. And this should be the end of it. So we should be able to do then print, and then we'll print results, and then out unit. Let's see, let me pull this. Well, probably too difficult to read that. Let's run the program and let's see what happens. Okay, so we have 10 feet is 3,048 millimeters. Let's see if we can confirm that. So 10 feet into millimeters is 3,048. Cool. Now let's do 10.6 centimeters into millimeters. So that says it should be 105 millimeters. So we'll do, what did we just do? We just did 10.5 centimeters into millimeters. So that says 105. Now, that one condition that we accounted for was if some Dimmy wants to do this, then we have a simple conversion. So let's do a quick one-over of the code. Now, what we did was imported sys so that we can have access to argv. Created this unit converter class, and we did this kind of in a shorthand way. We just created all of our input types we wanted to convert to centimeters, and then convert it from centimeters back to the input type. So for each type of measurement that we want to support, we're going to write 2 methods. And again, the reason for that is, just like we demonstrate here, if I want to convert miles into kilometers. So let's just say I want to convert 15 miles into kilometers, which is 24.14. Let me just confirm that. So I have 15 miles into kilometers. This says 24.1402. 24.1401. So we have a little bit of a rounding issue, but that's not a big deal. That's perfectly fine. So you can see that there is no miles to kilometers method. There's not. We didn't do it. What we did is we took the mile here, converted that into centimeters, and then we took centimeters and converted that to kilometers. It's just a shorthand way of me not having to write 50,000 different methods that I want to do. So data normalization, I know I've said it a million times, but data normalization is a great thing, and it's very useful in your software development career. So here we go. We're just going to support millimeters, inches, feet, yards, meters, kilometers, miles, and nautical miles. And hopefully I have these conversions right. I just did a quick Google right before I started to record this. I wrote this live and just use Google as kind of my guide to get these numbers down. So if you see anything wrong, just let me know and try not to kill me over it. We have the class written, and after we define the class, check to see our input. If we do not have 4, then we're going to throw an error. And again, the 4 is going to be the first one is going to be the script that we're running. The second one is going to be the input measurement. The third one is going to be the input unit. And the fourth one is going to be the output unit. In measurement, argv1 converted to a float. That way we can treat it as a number. Input unit, again, like I said, second. Output, third or fourth if you're indexing at 1. Then we'll do our little try catch here. So we'll try this code, and if that code fails, we will catch it down here and just basically write an error to the user. Unit converter will equal a new instance of unit converter. That will just be the class instance of the class that we wrote above. Result will equal the final result of the calculation. If in unit equals centimeters, then do not perform any centimeter conversion because it's not needed. But if it's not, let's go ahead and check to see if we have a method that will convert the input unit to centimeters. If we do not, throw an exception. If we do, perform the math. Result will equal the call of this method, and we'll pass that as the input parameter. So at this point, whether we input this line of logic or this line of logic, once we hit this line of code right here, result will equal centimeters. Now, if the output unit does equal centimeters, if we're doing an output of centimeters, there are no more conversions that are required because it's already in centimeters. And if it's not in centimeters, then we'll follow this logic down here. So if it's not in centimeters, then we'll find the centimeter to output unit method. So centimeter to miles, centimeter to whatever. Check to see if it does not exist. And if it does not exist, we'll throw an exception. If it does exist, just like we did above, we're going to reflectively call that method by using the method instance, calling the call method, sending it the parameter, storing that as result. And then very lastly, we're going to print the result and then comma, which will be a space by default, in the output unit. So we can see this is the output. Unit converter.py, 15 miles converted to centimeters is a very big, 2,401,010 centimeters. I hope this was fun. It was fun for me. Thanks for watching.